This is our complete top-down 2D Unity foundation template. It's fully modular, so you can pick and choose which features you want, and generic for any genre. We have our drag and drop inventory with item stacking and splitting, our hotbar and item pickup notifications, NPCs with branching dialogue, dynamic quest systems, rewards, and saving persistence, smooth fading map transitions, a full shop system with buying, selling, and custom stock, and everything else you see here, which we build step by step in this series. Let's get started. In this video, we're going to talk about our next series, which is going to be based around top-down games. This is just a little test project I did, but it'll look something like this. But first, let me explain. Top-down games share a lot of the same features. For example, if we take a look at action combat RPGs, turn-based RPGs, and even farming simulators, you want to save and load, have an inventory, NPCs, quest systems, shop systems, etc, etc. So for example, I started off by doing an action combat RPG tutorial series. I'd cover all of these topics, and then the ones that make it an action combat RPG, like combat and health and that. But then if I went on to make a turn-based RPG series, I'd have to again cover these features. So because we're all very clever, what we're instead going to do is create a top-down base template, which will cover all generic features used across the majority of top-down games. Then with this base template, we'll be able to go and create any genre we want. For example, a bullet hell or heaven, a roguelike, a survival, and I run out of room, but also a puzzle and adventure game, or a stealth game, starting with this base template and then branching off to add in the features that make these genres what they are. Pretty smart, right? Pretty cool? I'm going to pretend you just went, woo, yeah, great idea. Okay, let's get started. And so you know we're going to be using the Ninja Adventure Asset Pack by Pixelboy on itch.io, since this contains everything you'd ever want for a top-down game. Cool, so in Unity Hub, select New Project, and then we'll select the top option being the 2D built-in render pipeline. I'm going to name my project Top-Down Template and click Create Project. Cool, now we have this nice blank canvas that we're going to be working with. As always, I'm going to keep the videos as bite-sized as possible, separated into each little step and feature we add. So this is it for the intro video. So in the next video, we're going to get our player moving using Unity's input system. So I hope you'll join me for that. If you're craving some coding already, I've got a whole platformer series now completed and up, so you can check that out. I hope you're as excited as I am, which is very excited. By the end of this video, we're going to get this little froggy running around the screen. Maybe not this fast, but pretty fast. We're going to be using Unity input system. We're also going to look up setting a basic little sprite for our character. Cool, let's take a look. So first of all, I'm going to go to Pixelboy's itch.io page for his Ninja Adventure Asset Pack, and then download this using the Download Now button. Now from my downloads, I'm going to find this, unzip it, and then go inside Ninja Adventure Asset Pack, go to Actor, and go to Characters. In here, you can choose whoever you want to be your character in your top-down base template, but for me, I'm going to grab Masked Frog. To keep this easier to see, I'm going to go into Separate Animation, and then I'm going to bring in Idle just for now. So I'm going to click and drag this into my assets, and then back in Unity, I'm going to click on my player's idle, set the sprite mode to be multiple, the pixels per unit to be 16, filter mode to be point no filter, and compression to be none. Sprite mode is multiple because there are multiple sprites in this image. Pixels per unit to be 16 because that's the size of our individual pixel guys, 16 by 16. Filter mode to point no filter. This means that our pixels will be crisp and they won't go blurry. And our compression to be none, similar thing, means our pixels will be nice and crisp. Click apply. Now click on sprite editor. Click slice. Type to be grid by cell size. And now we can choose the size of our pixel. So like I said, it's 16 by 16. Then click slice to cut our image up, then click apply in the top right. And now if we close this down, you can see we've got this little arrow on our idle picture. If you click on this, you can see your individual sprites. I'm going to grab the first one of this and drag it into our game scene so that we now have a player game object created for us with our sprite that we want. I'm going to rename this to be player, and you can see he looks a little funny in the game scene. This is because it's on free aspect and the pixels are a little warped. If you click this free aspect drop down and set this to be the size that you want it to be, I'm going to set mine to be full HD 1920 by 1080, and he still looks a little weird. It's because the scale is off. So if we set this, it is on 1.3, set this back to ×1. Now he looks pixel perfect perfection. Okay, let's get on with the movement. So for our player to move, we're going to need to add a component. For game objects to be able to move, they need rigid bodies to give them physics within the game. Because this is a top-down RPG and not a platformer, we're not actually going to be using any gravity. If we press play now, our character is just going to fall straight down. That's because his gravity scale is set to 1. So instead, let's set that to 0, so he'll no longer leave us. Cool, now because we're going to be using Unity's input system, which is their kind of new way of mapping our players' inputs. This makes it easy to implement different types of controls, like a controller or a keyboard. We're going to need to go to Window, Package Manager, and change the drop-down in the top left from In Project to Unity Registry. Then search for Input, and you should be able to see Input System pops up. If you click Install, and then wait for it to install, you get this pop-up asking if you want to restart the editor. You could say yes, and your Unity editor will close and then reopen. Now that's all installed, we can close this off. Then we'll click back on our player, scroll down and go Add Component, and search for Player Input. You can see here under Actions, we currently have none. So if we click the button Create Actions, then click Save, this will create us some default actions. All these actions are fine for us for now. You can open them up to take a look if you want to, but they just have all the basic key bindings that you would expect from any normal game you've ever played. So cool, we don't have to do anything with this, so we can close this off. And finally, we can write our player's movement script. So once again, click Add Component, and at the very bottom, click New Script, and I'm going to name this Player Movement. Cool, when that's ready, double click on it to open it up, and at the top we'll add in the variables we're going to need. First we'll add a private float for our movement speed, which I'm going to set to a default of 5F. Then a private rigid body 2D, which I'm going to call RB. And then we're also going to want a private vector2 to store our move input. Now to be able to access our player's rigid body, in our start we're going to go rigid body equals get component, then triangle brackets, rigid body 2D. What this will do is try to get the component off of whatever this script is attached to, which is going to be our player. Now in our update we're going to use our rigid body and go rigid body dot velocity and set that to equal our move input times our move speed. Cool, now we need a way to set this move input using those actions we just created with the Unity input system. So down below, we're going to write a new function called public void move. We're going to say input action dot callback context and call this context. You can see there's a red squiggly underline under input action. If you hover over this and then go show potential fixes, it'll suggest the correct import that we need to get this working. If you click on this, it adds it to the top. So now all we need to do is go move input equals context dot read value, triangle brackets, vector2, and then close brackets. Cool, and that's it for the script. If we go back to Unity and go back to our player, we're going to have to make a way for our player input to communicate with our script. My favorite way to do this with Unity input system is to go to the behavior dropdown, which currently says send messages, click on this and click invoke Unity events. Now you can see we've got this new events section. So if we open this up and then open up player, you can see we've got these free events. These events correlate to the events inside our top-down template input actions that we created earlier. So what we want to do is move our player. So let's click the plus under move. And now we have an empty object slot. So what I want to do is in the hierarchy, grab my player and drag it over to this empty slot. Now in the dropdown that says no function, we're going to click on this and go down to our player movement script and then click move. And guess what? That's it. If we now press play, I'm going to try moving my character around with the arrow keys. There he goes, there he goes. Very nice, very nice. And now I'm going to move him around with WASD. Very cool. Now, if you feel, oh, my player's too fast or too slow and I want to change his movement speed, but to do that I'm going to have to go back into my script because it's a private field. See, if we scroll down our player movement script, you can't see any variables inside it. But if we go back to our movement script and in front of our private float move speed, type a square bracket and then serialize field, and then another square bracket, and save that. When you go back to Unity and you select your player, scroll down, and you can now see your movement speed inside the inspector. Now you can see I'm moving at 5, let's say miles per hour. I can up this to 10, and he moves way faster, or to 2, and he moves way slower. Oh, he's so slow, like old man frog. You can do that with almost any variable to keep it both private but also editable in the inspector. If you edit this field while this is playing and then you unplay, you'll see it goes back to our default number 5. But if you edit this outside of our playing debug session, it'll stay to whatever value you give it. So if we press play again and scroll down, you'll see it's still set to 10, as I did that outside of the debug session. If I stop this again, it stays at 10. Using the serialized field makes it easy to test things, so it's very handy. Sorry if I went over any basics that you already knew, but I wanted to make sure we're all on the same page. Now, if you don't feel like doing any of this yourself, or something's gone wrong and you're not sure what, you can grab this whole package on my Patreon, or you can just grab the script for free. In the next video, we're going to get our character animated. So we're going to focus on the idle and walking animations. By the end of this video, we're going to have our player animated and walking around our game. We're also going to set up our idle sprites, which for me are just still static sprites, but I'll show you how to do animations for that as well. I'm currently using 4 directional sprites, but even if you have 8 directions so your player can move diagonally, I'll also show you how to set that up. So this is for everyone, as long as you're making a top-down game. If you haven't done the previous video, I'll link that below so you can get your player moving. Otherwise, let's get started. So first of all, let's go to our Ninja Adventure asset pack. And if you don't have it yet, I'll link it below so you can download it for free, or you can use whatever sprites you want. And in here, we'll go to Actor, Characters, and I'm using the Masked Frog. So I'm going to go into Masked Frog and then separate animations. And we've got in our idle for our character. We're going to want that, and we're also going to want our walking animations. So I'm going to drag that into our assets. Then I'll click on our walking animation, and if you haven't done this for your idle yet, you can hold down Control and click idle and walk to do these both at the same time. What you want to do is set sprite mode to be multiple, since we've got multiple sprites here. Pixels per unit to be 16, since these are 16 by 16 sprites. Filter mode to be point no filter, and compression to be none to keep our sprites crisp. Now we need to cut out these individual sprites, so we'll go to Sprite Editor, click Slice, type will be grid by cell size, pixel size to be 16 by 16, and then click Slice. Then click Apply. Now we can close this off with the little X in the corner, and you'll see that all our sprites are now individually cut out. Next, to be able to do our animations, we're going to want 2 new windows. So at the top, go to Window, Animation, and then click Animation, and drag this in next to your game view. Then we'll want another one from Window, Animation, called Animator, and we'll leave that next to our scene view. So now if you click on Player, and down in our animation window, you'll see it says we can create an animator and an animation clip for our player by clicking this Create button. If we click Create, we can right click and go New Folder and call this Animation. Then double click on here to save all our animations in one place. I'm going to rename this animation Walk Down, as I'm first going to animate our frog walking down the screen, so facing towards us. I'm going to click Save, and if we double click inside our animation folder, we'll now see we've got a player animator controller and a walk down animation clip. If we select our player in the hierarchy and scroll down, we can see this has added an animator component to our player and slotted in the player controller. If you go to the animator tab at the top, this is our player's animation controller and will be where all our animations appear, but we won't look at that for now. So now if we go back to our assets and open up our walking sprites, I'm going to click on our first sprite and then hold down Control and find all our sprites where our frog is facing us. So that's 0, 4, 8, and 12. I'm going to drag these over into our animation window. I'm going to zoom in on our frog. If in the top right of your scene view, you can click this little orb with dots. That will get rid of your gizmos so you can see your frog sprite better. If I press play, you'll see he walks very, very fast. To make this slower, what I'm going to do is drag this out to around the 1 second. Now if I press play, you'll see he walks and then at the very end he does a little jitter. This is because we're jumping back to the first frame really fast, so we never get to see that final frame. So if we zoom out and grab our final frame again, we can stick that 20 seconds later, since that's the spacing between all our sprites, at the very end to stop that from flickering. So now our froggy's doing a nice little run. Now we're going to want to do this for all our other directions. So making sure your player is selected, where it says walk down in this animation section, if you click on this and then click Create New Clip, we'll be able to create a new animation. And next I'm going to do walk left. So walk left is going to be 2, 6, 10, and 14 for me, and whatever your sprites are for you. Drag them in, drag them out to 1, grab the final frame and stick it in 120. Press play to check it out. There he goes. Again, walk right, 3, 7, 11, 15. Drag it in, drag it out, grab the final frame to 120. Test it with play. There he goes. And finally, walk up It's 1, 5, 9, and 13. Drag it in, drag it out. Final frame, 120. And there he goes. If you want that to be a bit faster, what you can do is press Ctrl and A, which will grab all your frames, and you can pull these in to whatever speed you want. So we could pull this back to be actually 1, which I actually prefer, and I'm going to go back and change all my sprites to do this. So just Ctrl A and drag it to where you want to be. Cool. Now, even though my idle for this character doesn't have different sprites, I've only got a single sprite for each idle frame, I'm still going to want to create an animation. I'm still going to want to create an animation clip so that our animator has something to call just to make him stand still. So in the same drop down, I'm going to go create new clip and go idle down, drag in the single clip, create new clip, idle left, drag in the sprite, create new clip, idle right, drag him in, create new clip, idle up, and drag him in. You can see when we press play, this doesn't do anything. If you did want to add some kind of idle animation to your player, but you don't have the sprites for it like me, what you could do is over here in the animation, there's a little record button. If you press that and drag your mouse to around 0.30, we could scale his Y down by going 0.9, click on your first frames at 0, then do Ctrl C to copy these, move your cursor to the 1 second mark, do Ctrl V to paste them. And then when you press play, you'll see your frog does this little in and out animation. We don't want his bottom half to actually be squeezing in and out like that. So if we go to the 0.30 second mark and do position in Y to be -0.1, then go back to the 0 mark and copy these frames back to the 1 second mark and paste that back over. Now when we press play, a frog does a kind of little bounce in place. Just about. It's not perfect. That's just an option if you don't want your character to be static. You could always just make your own frame of a sprite. I'm just going to keep him still while he idles. So I'm going to delete all of these and just leave it as a sprite. So he won't move while he's idling. But cool, now we've got all our animations ready. We can check our animator scene and see every animation we've made is all collected up here. Now we're actually going to create something cleaner instead of having all of these different animations to look at. So you can select all of these by dragging your mouse over them and then press delete. Don't worry, they're still here in our assets. But what we're instead going to do is right click next to entry, hover over create state, and then click from new blend tree. We'll click on this blend tree and call it idle. So we're going to stick all our idle animations inside this one idle blend tree. If we double click on this, and on our blend tree, we can now see its details in the inspector. The blend type we're going to want to use is going to be 2D simple directional. And we're going to want 2 parameters inside here for our X and our Y. Over on the left, we can create these parameters. So it will be selected on layers. You just have to click on the tab that says parameters. And then under here, we have a plus. If you click on this and then click float, for our idle, what we're going to want to know is the last direction we've moved in. So you're moving, you're walking, and then when you stop, which direction have you stopped in? So we'll name this last input X. And we'll need another one. So click the plus, new float, called last input Y. Cool, now using these in our parameters, we're going to want to go last input X by last input Y. Now this motion is for the different directions that our player can face. Even though we only have 4 animations, a top-down character can move in 8 directions. So if this is our character, we can go up and down and left and right, like we know, but we can also move diagonally. So, I gotta draw all the arrows. So even though I don't have animations set up for these directions, I'm still going to want the correct sprite to display. If you do have sprites for diagonal movement, this is where you can put these in. So this will work for you if you've got 8 directional sprites as well, or if you've only got 4. So cool. What I meant by all that is that we need 8 motions in here. So click on the plus and go add new motion field. 1, 2, 3, 4, 5, 6, 7, 8 times. Now we have to set up these position X and position Ys. You can see up the top here, this dot in the middle is our player, and we need to get all these little diamonds around the player in the correct position. So idle down is our character facing down towards us. Let's put that one in first. And our X will be 0 because we're staying straight down the middle, and our position is going to be -1. You can see this moves it straight down. So when our player is moving in this down position, we're going to play the idle down. Next, let's do idle left, so drag that into our next motion slot. Our Y, we want it to stay in the middle of our player, and our X, we want it to move over to the left, so that's -1. So idle left is -1 by 0. Idle right will be 1 by 0, since we want it to the right, and then 0 on the Y axis, straight in the middle. And then idle up, if you can guess, is 0 on the X and 1 on the Y. You can see now we've got our basic 4 directions. Next we need to set up our diagonals. So on your X position and Y position, we'll go 1, 1. So this is a diagonally right. For me, if I was walking diagonally right, and I only have 4 directional sprites to play with, I'm not going to use idle up, I'm going to use idle right. So if we're walking to the right in any way, it's going to be a right directional sprite. The other idle right we're going to do will be if we're walking to the right, so that'll be 1 again, but down and right. So down towards the camera and right. This way, I'm sure you get what I mean. We'll walk in the right again, anything on the right side, right sprite. And then to the left, which will be -1 and 1. So that's top left, idle left again, -1 and -1. That'll be bottom left. So cool, hopefully that all made sense. What we're going to want to do now is click on base layer at the top, right click next to idle, create state, and go from new blend tree. Click on this, and I'm going to name this walk. So this is going to be our walking animations or running animations, whatever you want to call it. So I'm going to double click on this, click on our blend tree, and exactly the same blend type we want to be 2D simple directional. And now our parameters, we want some new parameters again. So we don't want our last inputs, we actually want a live feed of our current inputs. So I'm going to just call this input X, click on the plus, new float, input Y. So these will update as our player pushes in an input, either by keyboard or controller. Then on our parameters drop down, change from blend to input X, and then input Y. And once again, I want 8 different motions. 1, 2, 3, 4, 5, 6, 7, 8. Cool, so again, I'll speed through it this time since you kind of know what I'm doing. But we've got walk down, -1. Walk left, walk right, walk up. So walk left, -1 by 0, walk right, 1 by 0, walk up, 0 by 1. And then our diagonals will be walk right, 1, 1 in the X, -1 and 1. Okay, I'm saying that weird. You can look at my screen so you don't get messed up. Walk left, first walk left be -1 by 1. Then the second is -1 by -1. So you should have all of these diamonds circling around. It doesn't matter what order your motions are in. See, I can drag these around, it doesn't do anything. Just as long as your positions are correct with this animation clip. So cool. One more thing to do in the animator, which is if we go back to our base layer and zoom on in, we're going to need to set up our transitions. So I'm actually going to drag this down below our entry. Makes no difference, I'm just doing it so I can zoom in easier for you. So our base entry point, when our player enters the scene, is going to go straight into idling, which is great. Now we want to right click on idle and click make transition and drag this over to our walk. So we want to be able to go from idling to walking. You can click on this transition by clicking on this line arrow. And over here in the settings, I'm going to open up the settings panel so we can see it some more. And what we want to do here is untick has exit time, untick fixed duration, and set transition duration to 0. What this means is that as soon as we start walking, we want to show the walking animation. We don't want it to wait at all for any idle animations to end. We want it to be an instant switch. Now we need to know when we want to start walking. So down the bottom, we can add in conditions. If you click the plus, you'll see we can use one of our parameters as a way to check if we're moving or not. To make it real simple, over in our parameters, click the plus, click bool, and call this is walking. Now just a heads up, your casing does matter in these animation strings. And by casing, I mean the capital letters. So I've done lowercase I and capital W in is walking. If I typed this wrong when using this in my code, it won't work. So make sure your casing is the way you like it and the way you'll remember. Now back to our idle to walk transition in conditions. We can now click on this drop down and click is walking. So if is walking is true, we want to start walking. If we now click on our walk animation, we can right click on this, click make transition, and click back to idle. Click on this arrow pointing towards idle, and we're going to want the same steps. Untick has exit time, untick fixed duration, set transition duration to 0, add our condition down the bottom, go is walking, and we want it to be if is walking is set to false. So we're no longer walking, we want to go back to idle. Cool, so now our animator's all set up. Next thing to do is get into the code and get our animations playing. So I'm going to click on my player and scroll down to our player movement script. I can double click on this to open it up, and then at the top in our variables, I'm going to type private animator called animator. Then in our start, same way we did for our rigid body, I'm going to go animator equals get component and pass in animator. so we can grab our animator component off of our player. Now in our move function, at the very top we can go animator.setBall, and inside our brackets we want to pass in the name of our parameter inside our animator that we want to set. There's a tongue twister. Name of our parameter inside our animator. Name of our parameter inside our animator. Blah, 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 blah. Okay, so we want to set is walking to be true. Then after we've got our move input, we can use this to set in our animator's input X and input Y, which we use for our walking animation. So let's go animator.setFloat and pass in input X, comma, then we can use our move input and say .x. If we hold down Control and then press D, you can duplicate this line, change input X to input Y, and move input.x to move input.y. So cool, now we know when we're walking, we're going to set it to true, and when we're moving, we'll be able to grab our move input X and Y. But how do we know when we've stopped walking? And how do we store our last X and Y for our idle animation? Well, I'm glad you asked, because I know the answer. Underneath where I set is walking, I'm going to go if our context is .cancelled, which is something that gets set if we've let go of our button or sprung our joystick on our controller back to the center. Then we'll set our animator.setBall is walking to be false, our animator.setFloat last input X to be our move input.x. Because we haven't set this yet, this will be our last input that we've done before we stopped, since we haven't reread the value to be 0 yet. So make sure this does happen before you set your move input to be the new context read value. And then again we can do Control D on this line and change last input X to Y and move input.y. So just to make it easy, we always set is walking to true at the top, and then we check, actually, has it been cancelled? And if it has, we set this back to false. And guess what? That's all we need in the code. So let's go back to Unity. Now, if I press play, you can see with the animator open, this is playing our idle over and over again. It looks a little scary, but that's just because I only have one frame. So it's just calling that frame again and again. Now, if I walk, you can see our walking animation plays and it moves in all our different directions. You can see our parameters are flickering around at the top as well. They're all changing. And when we stop moving, it saves our last direction. If we double click on our walk blend tree, it's pretty cool. You can see this triggering all our different paths. But cool, we've got our little guy all animated. Like I said, this will work for 8 directional if you've got the sprites for it. You just have to drag them into the right spots into your blend tree. I've got another video on it if you want to see it more clearly with the 8 directional sprites. But yeah, all done. If you don't feel like animating this yourself and you want to grab this whole package, you can grab it on my Patreon, as well as every other script I've ever written for this whole channel. In the next video, we're going to make a nice little world for our frog to run around in. So we're going to look at tile maps and sprite sheets and layering our tile maps so our player can walk behind objects in the game, in front of objects in the game, collide with objects in the game. It's going to be great. So I hope to see you in the next one. Like and subscribe, and I'll see you later. Bye. In this video, we're going to get our tile map set up where we'll be able to walk in front of our layers or behind them or collide with them and also add decor. We'll go through the plan. Getting your tile map layers down correctly at the beginning is important for your game, otherwise it can quickly become a mess. So first, let's plan out our layers that we actually want. So we're going to have to start thinking a little bit three-dimensional and think about things layering on top of each other. So of course our very bottom layer, something we're going to want to walk on top of and everything else should be above, will be our ground. Next, it's going to be something we want to be on top of the ground, but we'll always be able to walk in front of. So I'm just going to call this one walk in front. But these will be things like our staircase or maybe some plants on the floor. Next, we're going to need a specific layer for things that we collide with. This could be the base of a tree, a big rock, the base of our pillars. And why I say the base of the tree and the base of the pillars is because of our next layer, which will be walk behind. This will be where our player can walk behind them, like the top of our pillar here. Our player would disappear when walking behind it, or be able to walk behind the back of this building. The bottom half of the building will be collidable, and the top half will be on our walk behind layer. And then finally, just another extra one, handy for sprites you want to add on top of things like vines or plants growing or signs in front of houses. I just call this the decor layer. Now within all this, of course, we need our player to be on a sorting layer as well. So he actually falls between collision and walk behind. So we want to be in front of things that we collide with, but behind things we obviously want to walk behind. So cool. Hopefully that makes sense, and going into this will be a much simpler process. All right, let's get into it. So in Unity, first of all, I'm going to want to grab the tile sets that we're going to be using. For this series, I'm using the Ninja Adventure Asset Pack. I'll link it below if you want to grab that. And in our asset pack, I'm going to go inside, and this time go inside the folder called backgrounds, then inside tile sets. And in here, I'm going to want to grab tile set floor. Then I'm going to hold down Control and grab tile set house. With both of these selected, I'm going to drag them into our assets, then go into Unity. And in our assets, what I'm going to do is right click and go create folder at the very top and call this tile sets. I'm going to grab both of these and drag them into our tile sets folder. And you know what, while we're cleaning up, let's create a new folder again. I'm going to call this sprites, which is going to be for my player sprites or any other sprites we add in. So cool. I'm going to double click on our tile sets folder, and we're going to want to set up both of these just like we did for our player. So I'm going to hold down Control and select both of these, set sprite mode to be multiple, pixels per unit to be 16, or whatever your sprites are set to. These sprites are all 16 by 16, filter mode to be point no filter, and compression to be none. Then click apply. Then you have to do this individually of your sprites, but click on, I'll go tile set floor first, click on sprite editor. Then in the top there's a button that says slice. If you click on this, where you can click type and set that to be grid by cell size. Pixel size, we want it to be 16 by 16, like we said. And then you can click the button down the bottom that says slice. Once that's all sliced up, you can click apply and then close this off. Let's do the same thing for tile set house. So sprite editor, slice, grid by cell size 16 by 16, click slice, and click apply. Cool, now if you open up these, you can see all our individual tiles cut into little pieces. Close that back up. Now to be able to paint on our scene, what we're going to want is a new window. So in Unity, go to the very top where it says window, go down to 2D, and select tile palette. This will bring you a little pop-up. You can click on the tab at the top and drag it next to your inspector. And now, like it currently says, we don't have any valid palettes or targets. So over in your hierarchy, if you right click and go 2D object, tile map, and then we'll go to rectangular since we're using square-based tile maps. I'm going to click on our gizmos because that's turned off at the top. Now you can see automatically this has created us a grid, which will just hold our tile maps for us, and then a tile map, which our tile palette is automatically selected. We still have no valid palette, so if we click on this and then click create new palette, I'm going to name this ground, and then I'll click create. Inside this tile sets folder, I'm going to actually create a new folder to hold all our new palette information. So I'm going to call this ground palette. Double click on this, click select folder, and then what you can do is go into your assets, into your tile sets where we've got tile set floor, click on the overarching main image and drag this into your palette. When you let that go, it's going to pop up this window. I'm going to select our ground palette folder again, click select folder, and this will generate all our tiles for us. Now what this has done is created a palette for us, and like with any palette, like with anything like paint or whatever, where you select a color, you can click on one of these. So if I click on this green one down the bottom, you can now paint on your scene view. This doesn't work in your game view, it'll only work in the scene at the top. There's lots of different tools you can use at the top of your tile palette, like the eraser if you want to remove things, the fill bucket, like you can find in anything else, so I can fill in the middle of that if I drew a little square. And yeah, basically anything that you need to be able to paint. So like we had in our little notepad, we wanted different layers to play with. We've got our palette now for ground. So now let's create our ground tile map. We can use this one that we've already created. So if I go back to the inspector on this tile map selected, I'm going to rename it to be ground. And for our layers to work properly, down in the tile map renderer, in additional settings, you have a sorting layer. All of this will be set to default by default. So let's click add a sorting layer, and while we're here we can actually set up all our layers that we planned out. So we wanted ground, next walk in front, after that we wanted collision, then we said 3.5, which obviously isn't an option, will be our players layer, so we can actually add our player in here as well. Next will be walk behind and then decor, so let's add those quickly, walk behind and then decor. Cool, so if we go back to our ground tile map, we can go to the sorting layer, and I'll select ground. If I go to the tile palette, I'll show you. Right now, our player is hidden behind our ground. We've added our player layer, but we haven't set our player to this in the inspector. So let's select our player, and in Sprite Renderer, we've got the same sorting layer option. He's currently set to default, so let's set that to player. And there he is, pops up above. Just gonna draw us out a nice background. Beautiful. So this is all on our ground. Next, I'm going to want something I can walk in front of. But we've already got our ground layer, and all these tiles are a bit boring to use as examples. So let's click on ground in our tile palette and go create new palette. And I'll name this houses, because that's what it was named in the tile set. Click create, go to tile sets. Now create a new folder called house palette. Then select folder, and the same as before, in our assets, I'm going to drag in tile set houses. Make sure you're in the right palette folder. So I want the house palette. Select folder, and it will create our tiles for us. Cool, so now we're going to want a new tile map to be able to draw onto so we can set this onto a different layer. So on our grid in our hierarchy, I'm going to right click and go 2D object, tile map, rectangular, and I'll call this walk in front. I'll go to the inspector and set our sorting layer to also be walk in front. Back to our tile palette. At the very top where it says tile map, we've currently got ground selected. So instead I'm going to set this to walk in front. So like I said in our example, staircases are pretty good. And something handy to note is you don't have to individually click and place each one of these tiles to place them on. Instead, what you can do is drag over all the sprites you want to select and then paint it onto your scene. So you can see I've got all these staircases selected in our tile palette. I can paint it on like this. So what I'm actually going to do is grab the left side of the stairs, place it at the top, the right side, and then I'm going to grab the middle and paint it on twice. So I've got a nice centered wide staircase. Very cool. Because this is on the layer walk in front, if I press play and test this out, our player can walk up and walk on top of the staircase. So he doesn't get hidden behind this either. Okay, very cool. Now, next in our list, let's get our player colliding with something in our layers. So again, on our grid, let's right click, 2D object, tile map, rectangular, and I'll call this collision. In the inspector, I'm going to select collision and set our sorting layer to be collision. Cool, now before we actually make this collidable, we'll draw on some things to collide with. And you know what, everything's beige, so let's change the grass color to green so we can actually see these better. Back to houses. So first, make sure you've got collision selected on the top. So let's select our pillar and stick it on our scene. Now, of course, right now, our player can just walk right over it because there is no collision set to this. So click on your collision tile map in the hierarchy, go to the inspector, and we're going to add some components. If you click add component and search for tile map, we'll want to add the tile map collider 2D. For things to be collidable as well, they need rigid bodies. So let's add a rigid body 2D. And because this isn't going to be moving anywhere, we can set this to static. Now we're not done yet because our player actually doesn't have any collision boxes on it. So let's go to our player and go add component and search for a box collider 2D because he's a bit square. Cool, I'm going to click edit collider and zoom in and drag this down so it hits just the top of its head. So he doesn't go bumping into things before he's actually touched them on our scene. Cool, so now when we press play, we walk into our pillar and we bump into it. I can't get through. Oh, and my guy's spinning. Okay, to stop your guy from spinning, back on our player, on our rigid body 2D, we want to go to constraints and freeze Z rotation. That way he doesn't spin, unless you want your player to spin around. It's up to you, no judgment. Okay, so cool, we've got him colliding now. Next, we want to do walk behind. So on our grid, right click, 2D object, tile map, rectangular, walk behind. And we don't need any collisions for this because we want to be able to pass right through. But we do want to set our sorting layer to be walk behind. Don't forget that step. So let's go to the tile palette, select our tile map in the top to be walk behind. And then I'm going to go in and grab the very top of our pillar and stick this on the walk behind. So he'll collide with the bottom, but he'll be able to walk behind the top of the pillar. So if I press play to test this out, I bump into the pillar at the bottom, but I can walk behind the top of the pillar. Very cool. This gives a lot more depth to your game. So it's a nice thing to implement and worth the effort to sort out your layers. Cool, now my final bonus layer is decor. Something I've found handy when making these top-down games. So let's go to our grid, 2D object, tile map, rectangular, call this decor. To the inspector, our sorting layer to be decor. And back to the tile palette, let's zoom in and pick something. So as an example of this, you can see we've got like this barrel of, is it fish or is it weapons? I'm going to want the bottom half of this to be on our collision layer. So we can't walk through this. And the top half, you see how it's semi-transparent? I'll want this to go on top of our collision layer. Now you could say, well, you can just put it in the walk behind layer. That's fine. That does work. But there may be something that you want on the walk behind layer to also have decor on it, say for some ivy growing up or something like that. Imagine this was taller. My example's not working that great, but you get the idea. So we've got this decor layer which goes above all that you can decorate things with. So over on this side, let's say, sure, you could use walk behind on the bottom instead of a decor layer, but yeah, I want this sign to be hanging at the top of the column, but it disappears and overrides it. That's why we have our decor layer. You can stick it on top and it doesn't make anything look weird. Or like a window for some reason is on the side of this pillar. But cool, we've got all our layers set up. Like I said, this helps a lot when adding the feeling of depth to your game. The main thing to be sure of is you're switching between the layers at the correct times. And be sure to always test this out. Look, where's our player gone? I can't see him. Oh, he's behind the building. Well, it would be handy if the camera followed him a bit and actually tracked our player as we moved. Was that a good segue? In the next video, we're going to be adding some camera movement to our game so our player can never escape from us again. And in the future, if I've already done this, I'll link it below, but I am planning on doing a live stream where I create a rule tile for our tile map that's handy for alleviating doing what I'm doing right now, where you have to draw on every single tile yourself instead of it automatically filling in. Okay, spoiler alert. This is the rule tile I'll be making in the live stream. You see, as I draw on, it creates our map for us. So all the pathing is automatically done. So be sure to subscribe so you can see when that happens. And now I've made a mess on my scene, so let me undo that. Cool, this whole package is going to be on my Patreon. So if you don't want to set up these tile maps and layers, you can grab it yourself there. But if not, I'll see you in the next one, where like I said, we'll get our camera movement down. By the end of this video, we're going to have our camera following our player around and also staying within the confines of our set boundaries. So for me, that's the fence around this town. This will also work if you don't want to set boundaries around your town, so don't worry about it. So cool, let's take a look. In our previous video, we set up our tile maps and added different layers so we could create this little town scene. I've just made it look a little prettier and added a fence around the edge, which I'm going to use as the guidelines for our boundaries. These will be collidable so our player can't walk out, and our camera won't be able to leave the bounds of these walls. Because right now our player can walk off wherever he wants and leave our camera view. So we're first going to get our camera following our player, and then if you want to do this you can, where we're going to add boundaries for each section of our map so the camera won't be able to leave this town. But yeah, this is optional, depending on how you want your game. These boundaries we're going to add is going to be a bit like in Zelda, where you get to the edge and then move to the next screen. But if you want your game to be more of an open world kind of feel and not so grid based, you can just skip this bit, that's fine. So cool, first of all, to get our camera following our player, what I'm going to do is go to Window, Package Manager, and in the search bar, search for Cinemachine. Cinemachine is a tool made by Unity, which makes adding camera movement much easier. If you click Install, and wait for this to install, and once this is done installing, you can close this down. Now over in our hierarchy, if we right click and go down the bottom to Cinemachine, you'll see one called 2D Camera. You click on this. I'm just going to rename this CM Cam, since it's a Cinemachine camera. And then with this selected, if you take a look in your inspector, you can see there's a slot here called Follow. If you click and drag on our player from the hierarchy into this Follow slot and press play, now when we move around, our camera follows our player. Amazing, perfect. Now you might have noticed, but as we walk around, you can see some white lines popping up between our sprites and a bit of tearing. To fix this, if we go into our Tilesets folder, in our assets, right click and go Create, 2D, Sprite Atlas. I'll just name this Sprite Atlas. Then you can grab our tile sets and drag them into objects for packing. So I'll do this on our floors and also on our house tile set. Then set filter mode to be point and click Pack Preview. When we press play, you'll no longer get this tearing between your sprites. So cool, now we have our sprites not tearing and we have our camera following our player. Next up, let's get the camera not showing these blue edges on the side and sticking just within the boundary of our town. So the Cinemachine actually has a handy extension we can use called a confiner, which does exactly what we want to do with keeping our camera within these bounds. So under extensions, you can click Add Extension and look for Cinemachine Confiner. Next, you can see it's asking for a bounding shape. So we need to draw out the bounds and give it to the collider so it knows where to keep the camera. So in our hierarchy, I'm going to right click and create a new empty object, and I'm going to call this our map bounds. I'm going to use this object as the holder that's going to contain all our different boundaries. So we're going to have one for down in the town and another one for up in the forest, and any other direction you want, it'll make kind of like a little grid for us. So on our map bounds, I'm going to right click on this and go create empty again. And since this is a town and our first town, I'm just going to call it T1. In my head that makes sense. You can call this whatever you like, but I'm thinking like maybe I'll have another town and I'll call it T2. And for our forest I'll call it F1. You could do this any way you like. Like I said, this could be like battleships, so this could be A1 and this could be B1, you know, columns and grids, and you had one over here and it's called B2 and this one's A2. I don't know, whatever you feel like. But on our T1, which is going to be for my town's boundary, I'm going to add a component and search for a polygon collider 2D. If I click on edit collider, you can see we've got this little pentagon, not a pentagram. So I'm going to want it to be like a box. So if I open up points and paths and then element, I'm going to set the size to be 4. So we've got 4 little edges here. I'm going to just click and drag these out. If I zoom in a bit so you can see, I'm going to click and drag these out around our fence. I'm going a bit over, but basically where you draw is going to be where our camera can see to. So if you wanted to see a bit on the edge, you can do, you know, it could go a bit wide on this side, why not? But to show you, I'll leave this side wide and this side short, just so you can see what it's like. And since we want to be able to walk through this collider and not get stopped by it, you want to set is trigger to be true by ticking this little checkbox. And then if we click back on our Cinemachine, you can see on our Cinemachine Confiner 2D, we have this bounding shape empty. We can drag T1 object over into this and it'll grab the polygon collider for us. And just before I press play, our camera's lens ortho size was a bit big. So I'm going to set that to 5, just so it was actually zoomed in on our little player there. So when I press play, our camera now follows our player around and stops on that edge. You can see we got a little leeway since we made the confiner bigger there. And there he goes, walking to the side, and it stops on the edge there. Cool, now we got our camera working, which is all well and good for when our player's inside our town. But wait a minute, where are you going? He's just left the town and he's left the camera view. So what we're going to want to add next is transition points from one map to another. And of course, to keep this bite-sized, I'll put that in the next video. For your convenience, this whole package is going to be on my Patreon, along with all other code I've ever written, all my work. It's all up there. So you can support the channel there if you like. But if not, I hope you enjoyed the video, and I'll see you in the next one. Bye! In this video, we're going to be adding some transitions to our game, where we can go from this map to this map. Wow, what an interesting map to come see. Very exciting. Oh, it's a bit boring actually. I want to go back to the town. Let's walk down. Oh, there we go. Amazing. Cool, let's take a look. In our previous video, we got the camera following our player around. The camera also confines to the bounds that we set. So right now the camera is bound to the confines of this town and the fence around it. That means when our player walks up and out into this green forest area, if there were trees it would be a forest, we no longer see him in our game view, but you can see him walking away, leaving us behind. So right now we have T1, and T1 is just what I've called this town number 1 grid map place, basically the name of the boundary for our town. We're going to add another boundary up above for our forest that I'm going to call F1 since it's our first forest. Then what we're going to do is add some waypoints, which will be colliders at the edge of our town that when we walk into, we'll switch our T1 confiner to then look at the F1 confiner and move our player up and into the next grid of our map. Then we're going to need to do the same thing so we can get back from F1 to T1. So a waypoint on the other side, pointing back down and completing the cycle. So cool. First, let's add the bounds for our F1 zone, the forest. So I'm going to select T1 and hold down Ctrl D, which duplicates this object. I'm going to click at the top of the inspector, call this F1, and then if we click Edit Collider, you'll be able to see where this collider is showing. We don't want it in the same spot as T1, so I'm going to click the Move tool, drag it up and into our forest area. I'll just do this by eye, and then click Edit Collider, and yeah, it's too big. So these boundaries don't have to be the same size. I was just being lazy instead of making a new one. I'm going to set our confiner to show just the top of our fence here for our town, so we can see that there's an entrance here, and this can be where we place our waypoint. And I'm going to just drag these down. Like I said, this doesn't have to be perfect, but you can make it perfect if you want to. And it's okay that it overlaps a bit with our T1. They both show the fence there. So cool, now that that's set up, let's click on T1 and work on our town waypoint first. So right click and go create empty. And I'm going to name this F1 underscore waypoint, since this is the way into F1 from T1. I'm going to click add component and add a box collider 2D. I'm going to move this up so it's just at the top of our stairs here. Edit the box collider and make it fit in this little area. So just at the top of the stairs. We only need this to be a skinny little box because as soon as we touch it, we're going to be sent up and into our forest area. We're also going to want this to be is trigger. So you can tick is trigger on our box collider 2D. Cool, so now we're going to need to write a script to get our Cinemachine camera's bounding shape to change from T1 to F1. So we can see up above into the forest. And then also to move our player up a little bit so he's not still touching the waypoint. You'll see what I mean. But cool, back on F1 waypoint, I'm going to go add component, new script, and call this map transition. And double click on this to open it up. And we can remove start and update since we won't be using those, but we will need some variables. So first of all, let's add a serialized field since we want to be able to edit this in our inspector. We're going to want our polygon collider 2D of our map boundary, and this map boundary will be the one we're transitioning to. Then we'll want our Cinemachine confiner, which we'll call confiner. And this will have a red underline so you can just add using Cinemachine to the top. Then we're going to want a private void awake function, which is Unity's function that will call as soon as the script is loaded. And in here we'll go confiner equals find object of type. And since there'll only be one of these in our game, we can use this and search for our Cinemachine confiner. So this will grab that confiner script off of our Cinemachine. And then on our waypoint, when we walk into it, we'll fire on trigger into 2D. So let's call this function and say if our collision.gameObject.compare tag, and type some brackets, quote marks, and search for player. So if it equals to player, which if you haven't already, make sure in Unity, which I actually haven't done yet either, is that your tag on your player is set to be player so that this does work back in our script. So if our collision game objects tag is player, we want to set our confiner.m underscore bounding shape 2D to equal our map boundary. So that's the new one we passed in. And I've made a mistake already. We want a Cinemachine confiner 2D. This is future talking, and actually I'm saying here that the Cinemachine confiner is meant to be a Cinemachine confiner 2D, but it's not. The component that we use is meant to be a Cinemachine confiner. So this is correct. Cinemachine confiner is correct. And this extension I added, we don't want Cinemachine confiner 2D. We want to add the extension Cinemachine confiner and set the confine mode to be confine 2D. Silly me. Cool, we are going to add more to this script, but first I want to show you what it looks like so far. So again, player should have the player tag on it, and our F1 waypoint, we want to drag in F1 into our map boundary slot and press play. Then when we walk up and hit our waypoint, it moves us up to our next place. But now let's add in the waypoint from the forest back down to our town. So if we press Ctrl D on this F1 waypoint and drag it under our F1, we'll rename this T1 waypoint and drag T1 into our map boundary. Don't get confused, don't get lost. we got this. Then on our box collider, we're going to want to drag this up just between the fences. Cool, that looks good. And now when we press play, you're going to see our issue and why we need to add a bit more to our script. So we'll walk up, and then if we keep walking, we're going to walk back down to the town, which is broken. And now, oh yeah, it's not looking too good. Okay, yeah, it's broken. So let's think about this. We've got our two waypoints. Our player walks up and into this one, and then what's happening is we're moving the camera, but we're not moving our player. So our player is still in this location. So then when he keeps walking, he walks into this waypoint, which transitions us back to the town, and it causes a mess. So basically, what we want to do is when we walk into this location, we're just gonna push our player up. It's not this far in our actual game, but in our drawing, it looks far. But what we're going to do is teleport our player up a little bit, so he should be above the next waypoint that would transition him back down. So we'll stay up inside our new point. So if we go back to our map transition script, and I'm actually going to add a new enum, which I'm going to call direction. And in here, I'm going to go up, down, left, right. And with this direction, we're going to want another serialized field, which we can call direction, so we know which way the waypoint is facing, so we can adjust our player's position in that direction. So let's write a new private void update player position. In the parameters, let's add a game object called player, and at the top we're going to want a vector free, which we're going to use as our new position, so new pos. And to start with, we're going to initialize this to be our player's transform.position. Now to know which way to move our player, we're going to use a switch case, so type switch, and then in brackets, pass in our direction, and we'll say if our case is of direction up, then add a colon, and say our new position dot y is going to plus equals 2. And then you type break after each one of your cases. So if we want to move up, which we will do, from our town to our forest, we're going to push our player up just 2 units, which should be enough to just bypass our other waypoint. Now you'll probably be able to guess these ones, but our case for direction dot down is now going to be new pos dot y minus equals 2. So it pushes us down. Don't forget your break. And then case for direction dot left is going to be new pos dot x this time, since we're moving horizontally, to be plus equals 2, and break. And then case for direction dot right will be new pos dot x minus equals 2, and break. Cool. Now outside of our switch case, you want to go player dot transform dot position equals our new position. Oh, semicolon. Now up in our onTrigger enter 2D, under where we set our bounding shape, we can call update player position and pass in our collision.gameObject, since we know this is our player. And that's it. It's all done. Very cool. Now let's go back to Unity. And on our F1 waypoint, we are going from our town up to F1, which is above. So we can keep our direction as up. On our T1 waypoint, we are in F1 and we're going down to the town. So we're going to want to switch the direction in this drop down to down. Now when we press play, we'll go up to our waypoint, get ready, we're about to touch it, and go into our forest. You see we're pushed up a bit, so we're right in there. You can edit this to be a little less, tweak it around, make it perfect for your game. But I don't really mind him being kind of pushed in. Let me get in there, get in the midst of it all. Okay. Now if we walk down to our town and hit our waypoint again, we get moved down into our town. Bling, blong. Bling, blong, bling, blong. Like I said, you can work with this, make it as smooth as you want, as close to where the waypoints are as you can get. But yeah, I went a little safe and made it +2. I could try +1. Let me try it. So if you do want to change it, an easy way of doing this, I'm just going to add a float to be our additive pos. I'm going to set this to a default of 2, which is what we have it at now, and replace this 2 down here with our additive pos. Blah, blah, blah. So now when I save it, go back to our waypoints, we can actually make these different for each one for any reason you might want that. If I try this at 1, let's see how this works. So now we're moving up 1 unit. Oh, no, I land exactly on the waypoint. Let's try 1.5. You're gonna need both of them to be 1.5. So 1.5. Oh, it's still messing up a little bit. It's not happy with me. 1.75. Nah, see, 2 worked really well. As if I tested it or something. There you go, 1.75. So that's not as far up. You get pretty close. To make this even smaller, if you really wanted to, you can just make these really tight. You can use the pixels to kind of like check where the waypoints are. So if I make that teeny tiny, that's all you need. As soon as he bumps his head on that line, it will be triggered, and I can set this to be just below this teeny tiny line as well. It's like 1 pixel high now. So now if I try 1 and move, oh, it doesn't like it. Look at him. It's because he's got a big fat head. Big fat frog head. Okay, 1.5. I'm just messing around, huh? There you go, 1.5. It's even tighter now. Blop, 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 blop. Cool. Now remember, if you test this while you're playing, it's not going to save when you unplay. So you edit your details. Like if I make this 5 for an additive position, and then turn off my play mode, it goes back to 1.5. Same with any colliders you change. You're going to have to edit these outside of your play mode to get them to actually stay. Cool, now our waypoints are working. We've got our game set up now. Look at it, it's walking around. That could be the whole game, you've done it. Walking simulator. But that'd be a bit boring. So in the next video, we're going to be adding our menu UI, which is going to include tabs, so we can switch between different menu content. And like always, I'm going to put this whole package up on my Patreon. So if anything went wrong and you can't be bothered to watch the video again, you can grab it on there. But if not, I'll see you in the next one. Bye! By the end of this video, instead of just our froggy walking around in this game with nothing in his pockets, we're going to be able to press tab, or whatever button you want, and open up a menu. Wow! We're going to have a couple tabs at the top. You can add as many as you want. It'll work no matter how many you'd like. And when we click on another tab, it'll grey out the others and highlight the one you're on while switching your page. So we got maps, settings, inventories, player, Very cool. And then when we're all done with that, we'll press tab, close it on down and carry on playing. Cool, let's check it out. So first of all, in our hierarchy, I'm going to right click and go UI, Canvas. I'm going to rename this canvas UI as I'm going to use it to store all of our UI for our game. In our canvas's settings, we have a canvas scaler, and I'm going to set UI scale mode to be scale with screen size. Then I'm going to set this reference resolution to be 920 by 1080. As this is the size I'm targeting in my game, this will work for any screen size. It'll scale, as it says, with the screen size. So even if it's bigger or smaller, it should still work. Next, I'm going to right click on our UI and go to UI and add a panel. This panel is going to be for our menu. So I'll rename it menu. Now you can see in our game view, we have this white overlay on our game. That's our panel right now. In the React transform of our panel, I'm going to set left to be 100. So it pushes it into the side a bit. Right to be 100, top to be 100, and bottom to be 100. So our menu will only appear in this little section in the middle. It's just kind of nice to see the edges of our game. And I'm going to change the color from white to black. Now, as we saw at the beginning, we're going to have header boxes at the top and then a main screen at the bottom. So when we click on our tabs, it'll switch between the different pages. So to do this, I'm going to right click on menu and go create empty and call this tabs. And then right click on menu, create empty and call this pages. So right click on tabs and go UI, image, as we want an image for our little tab at the top. And I'm going to rename this to be our player tab, which is going to be the first tab on my menu bar. Inside our Ninja Adventure asset pack, which we've been using, we can double click on the UI folder and then double click on dialogue. You can use whatever you like for this, but I'm going to be using the choice box PNG. So I'm just going to drag this into our assets. And in the settings of this choice box, I'm going to set the pixels per unit to be 20, filter mode to be point no filter, and compression to be none, and click apply. Now if I click back on our player tab, I can drag choice box into the source image. And it's a bit squishy right now, so all you have to do is click set native size. I'm going to hold down Control and press D while selecting our players tab and duplicate this 3 times so we can have 4 icons at the top. You can do as many as you want in your game, but for me I'm going to have my inventory tab, my map tab, and my settings tab. Now, so we don't have to position these out ourselves, what we can do is click on tabs and go add component and add a grid layout group. Now you can see these are still all squished up together. So what we need to do is edit this tab shape to fit the size of our menu. So if we double click on menu, our scene will zoom out to show you your full UI. And we click on tabs, you can see it's just this little box right now, which is why our groups are getting so squished together. So you can drag this box out and it should snap to the edge of your menu on both sides. And then click on the move tool, drag the green arrow and move it to the top of your menu. Now these are still a little squished together. So over in our grid layout group settings, you can mess around with these as much as you like to make it how you want. But what I like is cell size to be 400, add an X spacing of 20. And to get these centered, my child alignment I set to middle center. Now we got some nicely spaced out tabs. Cool, so I'm going to collapse that for now. And now we can work on our pages. So we're again going to want an image. So we'll right click on pages and go UI, image. And I'll call this player page. And for the background of this, in Ninja Adventure Asset Pack, I'm going to use the dialog box simple. Drag that into our assets. The pixels per unit on this one I did to 60. Filter mode to be point no filter and compression to be none. Click apply. Then back to player page, drag in dialog box to our source image. Now again, this is very squishy, so let's click on that rect tool and drag this to the edges of our menu. Cool, just line that up with the tabs. Very nice. We can now simply duplicate our player page down by holding Control and then pressing D 1, 2, 3 times and matching what we had above. So I'll have my inventory page, map page, and settings page. Cool, I'll close that back down. So we're doing well, we're layering up our UI. Next, let's get the text onto our tabs. So if we open up our tabs again, I'm going to right click on player tab and go UI text. And this will be Text Mesh Pro we're going to be working with. So if you're like me and you haven't used Text Mesh Pro yet, you can import TMP by clicking the button here, waiting for these to import, and then you can close this down pressing the X. So right now our text is white, so let's make this black so we can see it. And our first tab is called Party. Make this text a bit bigger, so I'm going to go to 42 and I'm going to center it. Now this font doesn't look very fun for a nice pixely game, so I'm quickly going to show you how to import any font you want into your game. Ninja Adventure comes with a font itself, so in the UI folder we have a folder for font. Here you can see some preview images and then the TTF file of normal font. You can drag this straight into your assets, and you can't use this straight away, this normal font. It won't work if you drag it into that font asset. What you need to do is go Window, Text Mesh Pro, and then Font Asset Creator. In the source font file, you now drag in normal font into here. You can leave all the settings the same and just click Generate Font Atlas. This will load our font down the bottom and we can click Save. And I'll save this just inside our assets here. Now you can see we've got this blue font file. This is the one we can drag into our text for our party. And there you go, you can see it's changed. This party looks a bit low, so I'm going to change the alignment down here to be in the middle as well. But on the bottom actually looks more centered to me. So I'll put it on the bottom for now and we'll see how that goes. Cool, now really I should have done this first before duplicating these tabs. So I'm actually going to delete those and now duplicate the player tab. So hold down Control D and we'll get the text coming with it as well. So let me just rename these quickly. Sorry. Cool, so yeah, if you copied and pasted, these might mess up. It's easier to just duplicate your player tab and it'll follow all the settings along with it. So I want to name this one Inventory. Oh, I want it all in caps as well. You can see our inventory's gone over the line, so I'm just going to drag this out so it fits in the boundary. Map tab, rename to map. Oops, capitals. And settings tab, I'll rename to settings. And that's too big too, so let me just drag that out. Drag it to the edges so it's centered. Cool, cool, cool. Very nice. Cool, so now let's get some code going. So for our menu, of course, we don't want it always in front of our screen. We want to be able to open and close our menu at will. So on our UI canvas object, we're actually going to have our menu controller. So we can open and close our menu and the code will still run. So let's click Add Component, New Script, and I'll call this Menu Controller. Double click on this to open it up. So at the top, all we're going to need is a public game object for our menu canvas. And in our start, we're going to want our menu not to be active. So it's not blocking the screen as soon as we play our game. So let's go menu canvas, set active to false. And then in update, I'm going to go if input.getKeyDown. And here you can pick a key code that you want to be the button that activates your menu. So do you want it to be M? Do you want it to be I? I'm used to in games pressing tab to open my menu. So I'm actually going to type tab here and that'll work for the tab key on your keyboard. So it's going to be press tab to open, press tab to close. And to do that, we'll go menu canvas dot set active. And we want it to be whatever our menu canvas currently isn't. So if it's open, we'll close it. If it's closed, we'll open it. So to do that, we'll go exclamation mark, which means not. So our not menu canvas dot active self. So what the menu canvas currently isn't, if that makes sense. Some backwards logic for you. And that's all we need here. If we go back to Unity, on our UI canvas, you can see we've got our menu controller script with our menu canvas slot. We can drag that menu canvas over into the game object slot and we can test this out by pressing play. Then of course our game starts with the menu closed. If I press tab, the menu opens. I press it again, it closes. So cool, very nice. What we want now is to be able to click on these tabs, and I'm going to want to gray out any that are not clicked on and move to the correct page that the tab relates to. Cool, so I'm going to use our tabs object to handle all this control. So let's add a component and go new script. I'll call this our tab controller. Double click on this to open it up. So at the top, we're going to want to go public image and do 2 square brackets. We'll need to import image and we're going to be using Unity engine.ui. And this will be for our tab images. We're going to be using these to gray them out and highlight the ones that we've selected. Then we're going to want another array, which will be a public game object array. So that's what the square brackets is, that makes it an array. And this is going to be for our pages. So we can activate and deactivate the pages that we've clicked on based on our tabs. So we're not going to need this update function, so we can delete that. But we will want a public void activate tab. I'm going to use numbers to identify my tabs, so the order that they go along from left to right, 1, 2, 3, 4. So I'm going to go int tab no is going to pass into this activate tab. And this activate tab we're going to call when we click on the image of our tab in the header. Cool, so first of all what I'm going to do is use a for loop, and I'm going to go around all our tab headers and pages and set them to deactivated, and then I'll just activate the one that we did click on. It's like the easy way of doing this. So I'll go int I equals 0, while I is less than pages.length, then I++. So in here, we'll go pages i.setActive to false, so we can disable it. And then we'll also do our tab image, square brackets I, and set the color by going dot color to equal color dot gray. Oh, not green, gray. So this will gray out our tab. Next, we're going to want to set our pages based on the tab number passed in. So pages tab number dot setActive to be true. So the one we've clicked on will be true. And the same for our tab images. Pass in the tab number, set the color to this time be color dot white, which will basically make it transparent and just be the color that it is. Now it's up to you how you want your menu to work. If you want to open the menu and it always be on the first page, what we can do here is activate tab and pass in 0, since that's the first item in our array, always starts at 0, not 1. If you want it to stay with whatever was last opened, you can just not call this, but I'm going to leave this in here so it always opens to our first page. So cool, if we go back to Unity, I'm going to click on our tabs, and in the inspector, if you click on this padlock, it'll keep our tabs page here. Otherwise, if this was unticked and you try to grab one of these, it moves it from the inspector. So I'm going to click the padlock at the top so I can click on the player tab, hold down shift, click on the settings tab, and it selects all of these. And I'm going to drag these tabs into our tab images array. You can see this sets it to 4, and if we open it up, it's grabbed the image out of all of these objects. Now the same thing for our pages. I'm going to click on player page, hold down shift and click on settings page, and then drag this into our pages array, which has grabbed all our objects for us. Now we're not done yet, so before you press play, like I'm doing, if I click on our other headers, it doesn't do anything. I've just noticed I have party written on here instead of player on our tab, so let's change that, player, not party. Okay, so to turn our images into a button-like thing, so when we click on it, it'll change to the next tab. We're going to go add component and search for event trigger. We'll then click add new event type, and we're going to want pointer down. So when we click our pointer, which is our mouse, down on this tab. So we'll click the plus button on our pointer down event. We'll drag our tabs object into this slot, and then on the no function drop down, click on this, go tab controller, and select activate tab. We'll want to keep player tab at 0 since arrays start at 0, so it's the first in the array and it's the first on our list. And then to make this easier, on event trigger, on the 3 dots on the side, you can click on this and click copy component. And if we click on our inventory tab, just on something like the image 3 dot here, you can go paste component as new. And don't worry, your image is still safe. It just adds our event trigger. So player tab was 0, we're going to want this one to be 1, and we'll go to map tab, do the same thing, and paste component as new, set this to be 2, settings tab, paste component as new, set this to be 3. And just for testing, I'm going to change the colors of our pages so we can see that they are actually changing. So player page, I'll leave white, inventory page, I'm going to set to be green, map page will be red, and settings page, I'll make blue. Cool. So if we press play, let's press tab. Here's our player page, still white. Click on inventory and now it changes to green. You can see our inventory page in the side is being activated. Map all red and settings all blue. Very cool. In our next video, we're actually going to be populating our menu, one of the pages at least, and we're going to be starting off with our settings page, where we're going to look into a simple save system so we can get our head around saving before we have too much data to try and store and it gets too big and complex. We're instead going to add in something simple. We're going to be saving our player position and loading that on game start. So when it comes to bigger stuff like inventories, we'll have the base down and you'll know what you're doing. So cool, hopefully this all worked for you. If it didn't, you can grab this whole package on my Patreon, or you can just support me there if you like the videos. Don't forget to like and subscribe, of course, and I'll see you in the next one. Bye! By the end of this video, when we move our froggy over to a new zone and we press save in our settings, close our game down, you can see, oh, by default he's in the middle and he's in the town. But I just saved. Shouldn't he be over in the forest, not in that place? Oh, he is in the forest. We're going to learn to save our game state. We're going to be saving this to a JSON like this, exactly like this is what I just saved, and loading it on game start. And we're going to be storing our player position and our map boundary, since in our tutorial we're using boundaries for our different zones like this. This type of save system should work for any type of data you have in your game, so don't worry if you're not actually following this tutorial, it should still work for you. So cool, let's take a look. So in our previous video, we added the UI in for our menu. So when we press tab, our menu pops up. I added in a tab for settings, and this is where I'm going to put our save button. So over in our hierarchy, I have a UI game object, which if I expand, I have our menu game object, which if I expand, and then I have our pages. On our settings page, if I expand this, you can see the little title text. And if I enable this, I'm also going to right click on settings page, go UI, and add a button. I'm going to call this save button. I'll make it a bit bigger by changing the height to 100 and the width to 200. And if I expand save button on the side here, we can see the text that's within our button. I'm just going to rename this to save, and I'm going to change the font to our custom font that we set up in our last video. So cool, if you're not following the tutorial, you can just add a basic save button to your game anywhere you want it to be. So now we're going to want a save controller script. We're going to need this script to live somewhere on a game object that's always active in our game. Our settings page gets deactivated when the tab isn't active. Instead, what I'm going to do is right click on our hierarchy and create a new object, which I'm going to call our game controller. So on this game controller, I'm going to click add component and go new script and call it our save controller. Now just before we open this up, I'm also going to go into our assets folder and right click and go create C# script and add another new script called save data. This save data script is going to be the model for all the data we want to save. So let's work on this first by double clicking on this file to open it up. And for our save data, we don't want this to be mono behavior, as we're just going to be using this as a class to define our data model. And as we're going to be saving to JSON, I'm going to type at the top above public class save data some square brackets and type system.serializable. Having things serializable means that you can pack and unpack data to a text-based format, which is what we're going to do by saving things to JSON. So as this is just a data model, we don't need this start or update function, and instead we're just going to define the data we want. So like I said, we're going to keep it simple and store our public vector-free player position. And if this is an open world game you're making and you're not using map boundaries like I am, you don't have to do this next bit. But if in your game you have camera boundaries that lock you to an area, and then when you move to another area, you move to the next boundary, what we're going to want is a public string map boundary. And here I'm actually going to be storing the name of the boundary for our map. So for me, I have things like T1 for my town and F1 for my forest area. Doesn't look like a forest, there's no trees, but you get what I mean. Field area perhaps, not forest. But cool, so in our save data, that's all we're going to need. For now, as I go through this tutorial some more, we're going to be adding our inventory. So we're going to add inventory saving here. But with this tutorial, you can add any data type you want in here, as long as it can be serialized. So let's go back to Unity. And on our game controller, we can now double click on our save controller script. So we're going to want one variable at the top, which is going to be a private string for our save location. And in our start, we'll define this save location. So let's go save location equals, and you can store this wherever you want for your game, but I'm going to use path.combine, and we'll have to hover over this and click using system IO to get path to work, then pass in the brackets application.persistent data path, comma, and then this will be the name of your JSON that you want. So I'm just going to name mine the same as our data file, which is savedata.json. If you want to know where this save location ends up being, you can put a breakpoint on here, click the play button where it says attached to Unity. And back in Unity, when you press play, we'll hit our breakpoint. We can step over once, pressing F10 or clicking this step over button. And if you hover over save location, you'll see where our data gets saved. Like I said, you can make this wherever you want, but this is just the common place used by a lot of Unity developers. So we'll stick it here as well. Next, we're not going to need this update function, but we are going to want a function to save our game. We're going to want this to be a public void save game. And we're going to want this public so that our button can call this. And in our save game, I'm going to go save data, calling our save data file we've just written. I'll name this save data, and we'll say equals new save data, then curly brackets, and now we'll initialize what this save data needs to be. So inside our save data, we want something for our player position, which I'm going to get by calling GameObject.find GameObject with tag, not game objects, but game object without the S, and then I'll pass in player. For this to work for you, make sure that in Unity, if you select your player game object, you have got the player tag on it. This should be a default in the list of Unity's tags. And at the end of this, I'll type .transform.position. Then we'll type a comma at the end and add in our map boundary. So for this, like I said, I'm going to grab the name of our map boundary, and this time I'm going to go find object of type Cinemachine Confiner, as currently in Unity. On our Cinemachine camera, we have a Cinemachine conveyor attached, which is what controls our boundary. And what I'm going to do is grab this bounding shape 2D from here and then grab the name. So let's do that in the script. So Cinemachine conveyor, and we need to import in using Cinemachine at the top. Then we'll say .m bounding shape 2D .game object .name. This grabs the name from our actual Unity game object that is in our bounding shape 2D. So again, if we look at our Cinemachine bounding shape 2D, you can see we've got the polygon collider from T1, which, as I showed before, in our map bounds, we've got T1, which is our town, and then F1, which is our forest or field. Cool, I need a semicolon at the end there. That's my save data all set up. Now we need to write this to a text file. So to do this, you type file dot write all text, then brackets, pass in your location, so save location. And now we're going to want to make this save data object into JSON. So we're going to call JSON utility dot to JSON brackets and pass in our save data. Cool, and that's all you need to do to get this saving. Now let's get our data loading. So let's write another function of a public void load game. For loading the game, we want to check if our file dot exists in our save location. So do we have a save file currently? And I'm actually going to do if we don't have a save file first. So if we don't have a save file in our location, all we have to do is call save game, and this will save our game for us and create a new file. This means that whatever your game's defaults are when it starts up is going to be the initial save point. Cool, so now if we do have a save file, we're going to want to grab that save data. So let's make a new object, save data, and say equals JSON utility from JSON. And if you do a triangle bracket, you can pass in your type, which is going to be save data. And this is going to try and convert the JSON in that file to fit into this object of save data. So then we do brackets and pass in our file dot read all text, and then in here you pass in your save location. So read that file in that save location. Now, depending on what you're saving, this is where you do basically the opposite of our save game, where here we grabbed and saved our player position. What I'm going to do is copy this game object, find game object with tag player transform position, copy that section and paste it. And instead of taking that value, we're going to set that value by saying equals save data dot player position. Now the map boundary one's a little trickier. So with this, we're going to do the same as above and say find object of type Cinemachine confiner, point to our M bounding shape 2D. This time we're going to say equals and try and find the game object that this name has saved from. So because we saved it by the name, we're going to use this name to search for it. And that's where it needs to be a unique ID. Otherwise, we're just going to grab the first one it finds. So we're going to say GameObject.find save data dot map boundary. Then outside the brackets, we'll go dot get component. And we actually want to grab the polygon collider 2D from that, since that's what fits in our bounding shape 2D. And then your load game, you could add this to a button as well in your game. I'm not going to do that for now. All I'm going to do is go to our start function. And when this starts, I'm just going to call load game. So the first time we run this, we're not going to have anything in this save location. So it's going to go through load game and save a new game for us. If I stick a breakpoint on this save game and press play, I'll show you this file popping up. So let's go back to Unity. And if I press play, we can see we hit our breakpoint. I'm going to grab this save location and I can paste this in my file explorer, get rid of the little quote marks and delete this / save data.json. So we just go to this folder. You can see right now this folder is empty. If we step over and check this folder again, we've now got save data.json. I'll open this up in Notepad. And you can see this is how our save is stored. Our player position is set to 0 and our map boundary is T1, since that's the defaults of my game. Cool, so let's hook up our save to a button so we can actually make this change. So I'm going to stop our debugger and back in Unity on our UI, I'm going to click on our save button inside our settings page and scroll down to the bottom where we can see on click. We're going to click the plus button to add an event, and then from our hierarchy, dragging game controller into this none object slot. Click on the drop down of no function, go to save controller, and then you can see our save game function in here. If you wanted to make a load game, you'll do this exactly the same way, just make a load game button. So we'll click this, press play. Now if we move our little froggy around, let's go into the next zone. Let's move him over into the corner or something. Cool, that's good enough. Press tab, settings, and click save. If I now check in our notepad, it says, oh, this file is being modified by another program. Let's reload it. You can see now we've got a new X and Y position and our map boundary is changed to F1. So if I close our game down, and you can see by default he's in the middle and in the town. When I press play, we start back to where we saved. Cool, it's working. That's it. You did it. Hopefully that all makes sense, and hopefully this can help you with your future games. If you want to grab these scripts or this whole project for yourself, it's all on my Patreon, so I'll link that below. Otherwise, I hope you like and subscribe so you don't miss out on the next video, which is going to be our inventory system, or at least the beginning of it. We're going to get the UI down for our inventory, and I think that episode after that we'll look at saving and loading our inventory state, so that's cool. Very exciting. Hope you enjoyed, and I'll see you in the next one. Bye! By the end of this video, we're going to add an inventory to our game. We're going to have items that you can drag and drop to any other slot, and also swap places with each other if you drag them on top of each other. This is the initial UI for our inventory, but we're going to be expanding on this in the next videos as well. Adding our inventory to our save state, adding hotbars, and anything else inventory related I can think of. We're going to be using this menu I've created in a previous video, so you can follow that video, I'll link down below, to get this bit set up. But if all you want is an inventory, all you need is a UI panel to work with. So cool, very exciting, let's take a look. So I don't get confused, I've written out my little plan so we can follow along together. So first of all, let's make our slots. Now our slots, since they're in the UI, are actually UI elements. So if we open up UI and open up our menu and open up our pages, we can go to our inventory page and open this up too. And I'll right click and go UI image. I'm just going to call this slot. And on our image, I'm going to set our color to be a darker gray. So let's say I wanted lots of slots. I copy and paste another one. And if I double click on this, I can see this actually in my scene view. Now I've got 2 slots, and what? I'm going to like space them out individually like this. That would take forever. I ain't got time for that. I'm a developer. I got coding to do. Luckily, if we go to our inventory page, you can scroll down and add a new component called grid layout group. And I'm going to have to delete this title text that says inventory for now, just so we can sort our slots out first. You can see now if I copy and paste some slots, ooh, they all line up next to each other. That's nice. They're a bit close. So let's click on our inventory page and open up the drop down for padding. I'm going to add 100 in each of these, as well as 100 in spacing on the X and Y. So if we now hold down Control D on these slots and spam them out, whoa, that looks cool. It automatically spaces these out for us. Very nice. Next, to make these interactable in our game, we're going to want to click on our slot and add a component called a canvas group. And you can leave the defaults for this, but basically it means it's interactable. So we'll be able to trigger clicks on our slot. And finally, we're going to add another component, go new script, and call this slot, and write our script for our slot. It's really short, get ready. Okay, you ready for our short script? See if you can follow along, okay? Public game object. Oh, I can't type fast and talk. Okay, whatever. Current item, semicolon. We're done. So for each of our slots, we're going to want to know the item that's currently held in this slot. So cool, that's the script. Close this down. And now we're going to delete all of our slots, apart from the top one that we've worked on. Don't delete that one. And drag this slot into our assets to create a prefab. And we can delete this one in the hierarchy. And next up, let's take a look. We want a inventory controller. So our inventory controller is going to hold the data on our inventory details and also make the slots for us using the prefab. This can be so you can have expandable inventories over time. You know, maybe you want to upgrade your bags and make more slots. So I'm actually going to reuse our game controller object that has our save controller script and add a new script called inventory controller. Double click on this to open up, and at the top let's add our variables. So we're going to want a public game object for our inventory panel, so we know where to place our slots. Public game object for our slot prefab, the one we just made. I'm going to set a public int for our slot count. This can be so you can upgrade your bags, like I said. And then we're also going to add a public game object, an array, so add the square brackets, for item prefabs. So this is going to be a public array for now for testing. We're going to create some items and drag them into this array so they can be populated in our slots. And I don't have to show you all at once items being made and picked up and all that rubbish all in one go. I'll do that in a bit, don't worry. But cool, we're not going to need this update function. And in our start, we're going to initialize our slots and then add our items to it. So let's say for int I equals 0, I is less than slot count, and then I++. Then we're going to go slot equals instantiate, pass in our slot prefab For the transform of the parent, we want it to be the inventory panel. So inventory panel dot transform, and then outside the brackets go dot get component. I'm grabbing the slot game object and storing it here so I can work with it and populate it with some items for us to test. If you just want to see the slots appearing, all you have to do is go instantiate the slot prefab and you'll be done. But otherwise, so let's say if I, so the slot that we're on, is less than our item prefabs dot length, so the length of our array, do we have an item that can fit into this slot? And if we do, we'll go game object equals instantiate bracket item prefabs square brackets I, comma slot dot transform, because we want to put the item in the slot. Oh, I just have game object item equals instantiate blah blah blah. Cool. And then with this item, I'm going to go dot get component, grab its rect transform, and set its anchored position to equal vector2 dot 0. This anchored position set to 0 makes sure that our item is centered within the slot. So no matter where we're going to place it, it's going to snap to the middle. And then we'll say slot.currentItem equals item. Very cool. That's it for our inventory script, so we can close this down. And if we click on our game controller, we can see our inventory controller script. We need our inventory panel, which is on my inventory page object. So I'm going to drag that over. And then our slot prefab, which I'll drag from my assets, and the slot count, we actually want 24 slots. And we'll add these item prefabs in a bit once we create them. But first, let's press play, press tab, and on the side already, you can see all our slots created. If we click on our inventory, all these become active, and you can see they're nicely spaced out. Cool. So now let's add some items to populate in this inventory. So I'll close this back down. And first off, we're going to be treating our items as images. In a future video, we're going to add in-game sprites. So they'll appear in our game and we'll be able to pick them up and they'll be added to the inventory. But for now, I'm going to reactivate our menu and inventory. Right click on our inventory page and go UI, image. And I'm just going to call this item. Right now our item is just a white blob, but let's grab an image for this. You can use any image you want, but if like me, you're following the tutorial with the Ninja Adventure Asset Pack, what we can do is go to tile sets, and I'm going to open up tileset house, and you can actually use these tileset images for your items as well, because I know somewhere in here, near the bottom I think, scroll, 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 here's a potion, there it is. Cool. I'm going to just straight up drag that from the tile set, and you'll see this appears nicely in our inventory. We're going to want a canvas group. So if you click add component and add a canvas group, this makes this interactable. And then finally, to make this draggable, I'm going to add a new script and call this item drag handler, and double click on this to open it up. To be able to drag and drop, we're going to use Unity's drag handler events. So after mono behavior at the top here, I'm going to go comma, I begin drag handler. And with the red underline, let's go show potential fixes using Unity Engine event system and continue, as we also want I drag handler, then comma, I end drag handler. Now Unity does something cool for us here. It says, oh, it doesn't implement the interface on begin drag. So what you can do is say implement interface. Do this for all of them. So I drag handler, we need our on drag, and then end drag handler on end drag. This automatically creates our functions for us. We're not going to need our update, so let's get rid of that. And let's move, just because I like it to be consistent, our start to the top of the file so it looks pretty cool. So let's begin with our variables at the top that we're going to need. We're going to want a transform original parent. So this will be the slot that the item's coming from. So if this gray box is our original parent and we drag our item off of this slot, maybe off the whole page and not into a new slot, what we're going to do is snap it back from where we let go back to its original parent. So that's why we want this transform. And we're also going to want a canvas group, which we'll just call canvas group. So cool, in our start, we're just going to go canvas group equals get component canvas group. So this is the canvas group on our item. In on begin drag, we'll delete this throw exception and go original parent equals transform.parent. So we're going to save the OG parent in there. Then we're going to go transform.set parent and set this to be transform.root. What this does is make sure it's above any other canvases. Then we're going to want to say canvas group.block raycasts equals false. And then our canvas group.alpha to equal 0.6. So the alpha is the transparency. So it's going to go semi-transparent as we drag it. Now, while we drag it, we want the item to follow our mouse as we move. And to do this is really easy. All you have to do is go transform.position equals event data.position. So this will make it follow the mouse. And then on end drag, this is the big one. This is why I'm sighing. So the basic stuff first. Our canvas group dot block raycast. Before we set it to false, let's set it back to true. Enables raycast. So this means we can click on it again. Canvas group dot alpha, set back to 1. So it's no longer transparent. Now we need to set up our slots. So moving from one slot to another. So let's go slot drop slot to be the one we're dropping it into equals event data dot pointer enter. So has our mouse entered a slot? Because we might not be in front of a slot, we need a question mark. That means it's nullable if you put a question mark there. And then we'll go dot get component, pass in slot. So yep, that's the slot we're dropping the item in. And then we want another slot for our original slot. And we can just go original parent dot get component slot, as we grabbed the original parent in the beginning. So first of all, let's go if drop slot does not equal null. We have ended our drag on top of a slot. Now the first thing we're going to code for is if, let's say we've got 2 slots and we've got an item in each slot. I don't know what that is. Don't even worry about it. Let's say we drag this item into this slot. Well, there's an item already in there. So what we're going to need to do is put this one on hold, move this item into here, and move this one to here. So you can do some item sorting and repositioning. So basically, if there is an item, which we're about to check, swap these items around. So we want to say the drop slot we're dropping into, does it have a current item? So drop slot current item, not null. Then, so the one we're dropping it into, we'll go drop slot dot current item dot transform dot set parent to be the original slot dot transform. Our original slot dot current item will now equal our drop slot dot current item. So moved this item into here, and that's where we're up to. Then we can set our drop slot dot current item dot get component, and we need to get the rect transform again, same as before, and do anchored position equals vector2 0. So this snaps into the middle. Then we're going to want an else. So if there is no current item in our drop slot, all we're going to want to do with our original slot dot current item is set this to be null. And no matter if there is or isn't a current item in here, what we're going to want to do is move our item into our drop slot. Since we moved this item over here, we now need to move this one over here. Cool, cool, cool. So let's go to transform dot set parent to drop slot dot transform, and the drop slot dot current item to equal this game object. Cool, so that's everything that happens if there is a slot under where we drag to. Now we need an else for if there wasn't a slot, so there's no slot under our drop point. Then simply all we have to do is go transform dot set parent and send it flying on back to the original parent. And just to make sure everything's nice and tidy, we're going to go get component rect transform anchored position equals vector2.0. So this centers it inside the slot. Okay, and that should be it. That wasn't too bad. Okay, we're good. Let's go back to Unity. And now we've got our items all set up. We can drag our item from the hierarchy into our assets, delete it from our hierarchy, and then in our game controller, we've got this slot for our item prefabs. I'll add just one of our items for now, deactivate these back down, and just before I forget, we click on our item prefab. You need your pos Z to be 1, your width to be 100, and your height to be 100, just to make sure this is visible in your game view. And this is the size of our slots. That's why I'm setting it to 100. Cool. Now if I press play and press tab, I'll go to our inventory, and our item is not in the right place, but look how it drags and drops to the edge of our thing. Okay, I know the fix. Go on our slot. On your rect transform, you can see this weird little box that says bottom left. We're going to want to click on this and select center. So everything is stored in the center of our slot. And same as our slot, click on your item, and we need to do that with our item as well. So it's set to bottom left, we want it on center middle. So click on here, 1 in the center. Cool, press play, press tab. Go to our inventory, haha, right in the center. Nice. It's dragging to the slot I'm taking it to. And then if I drag it off our page, it snaps back to where it was. Cool. And real quick, I'm just going to drag our item into our scene and make another one by going to tile set, scrolling down, grabbing our other potion bottle image, very cute. I'll call this heart item, and dragging this back into our assets to make an prefab variant. So a variant of our original item. I can delete this from the hierarchy, go to our game controller tab, and now I'll add another item and drag in our heart item into these item prefabs. I'll click play. Now if I press tab and go to our inventory, you can see our 2 items. Now I can test them swapping, and they're not swapping. Okay, 1 second. Aha, okay, I see. Brain activate. I did it. Okay, cool. So when we were dropping this, it was first raycasting onto our item that was below, and we were trying to grab the slot straight from the item. We don't have a slot on our item, that's the parent. So in our script, I quickly just added this little section. So we do our drop slot. If our drop slot equals null, so we didn't find a slot there, we're going to see if we have an item here instead that we're dropping onto. So I grab the game object that we're dropping onto, and if the item is not null, we're going to grab the slot off of that item. So really I could call this drop item for better clarity. Cool, cool, cool. And now we've got our drop slot underneath that item we've dropped on top of. Sorry about the back and forth, I hate doing that. This is an annoying script, so I'll put this up for free. I'll link it below. So you're welcome. But cool, now when we press play, press tab and go to our inventory, we can now move our items around and also drag them on top of each other and they'll swap places. Very cool. We're going to continue working on our inventory in the next video, where we're going to add saving our inventory state into our save system. Then we'll add our items to in-game, so our little frog will be able to see it in our game, walk over it, pick it up, and it'll appear in our inventory. Then I'm going to add a hotbar, so you can consume and use your items. There's so much we could do, and so little time. If you also have so little time, and you want to save some time, you can grab my whole project for this on my Patreon, as well as every other video I've ever made, for only £5. Come on, that's really good. So cheap. But if not, I hope you enjoyed the video. Like and subscribe. Thank you. And I'll see you in the next one. Bye! By the end of this video, we're going to be able to open up our menu, go to our inventory, move our items around into whatever slot we want, go to our settings, click save, shut down our whole game. What? Open it back up, please. I miss my items and their slots. When we press play again, open our menu, go to our inventory, and they've saved their positions. That's right, we're adding inventory save states. So when we check out our save data, we'll have inventory save data with item IDs and slot indexes. Very cool, very fancy. So first of all, we've got a couple prefabs sitting in our assets folder. I'm just going to right click and go create folder and create a new one for our prefabs. Hold down control on 3 of these and drag them in, just so it's nice and tidy. Now that's out of the way, let's look at our plan. So getting started, first of all, what we're going to do is create an item class to add to our existing item prefabs. In our nice prefab folder that I just made, we have our item and our heart item. If you didn't see how to make these, you can check it out in our previous video. And then carry on from there as we click on our base item, scroll down to the bottom and click add component. We'll click new script, name this item, click create and add. Then we can double click on this script to open it up, and inside here we're going to keep it real simple for now and add more later on, where all we'll need is a public int called ID. Cool, easy so far, let's keep going. So back in Unity you can see our ID is set to 0. We're going to keep it at 0 as we're going to add auto incrementing to make sure these IDs are unique for each item. If we check back in our prefabs folder, my heart item I created as a variant of this base item. So you can see this item script was also attached. So cool, let's go back to our plan and see that next in our list we're going to make an item dictionary. We're going to use this to store our item prefabs, auto increment our IDs like I said, and use it for item retrieval so other scripts can grab our items based on the ID. Cool, so to keep all our management stuff under a clean place, I'm going to put our item dictionary underneath our game controller. So I'm going to right click on game controller and go create empty and call this item dictionary. Then on our item dictionary, I'm going to click add component, new script, and call it item dictionary. Double click on this to open it up. And in here, we're going to want a public list of items, which I'll call our item prefabs. This list will manually populate and include all items that we want in our game. Then to have these stored by their unique IDs, I'm going to create a private dictionary, and in the triangle brackets, type int, comma, game object, and name this item dictionary. If you haven't used a dictionary before, basically it's a list of whatever you want in the second field to be stored by the key of the first field. So we're going to store our item prefabs game objects by their ID. So cool, instead of using start, I'm going to switch this to use awake. And as you can see, this is called when the script instance is being loaded. Awake is called sooner than start, and really we'll want our dictionary to run before anything else. So next, let's initialize a new item dictionary by going item dictionary equals new dictionary int game object. Then we're going to auto increment our IDs. We're going to type for int I equals 0, semicolon, I is less than item prefabs dot count, semicolon I++, and say if item prefabs square brackets I does not equal null, then item prefabs square brackets I dot ID equals I plus 1. So our IDs will always start as 1 and increment up. Now we can populate our item dictionary. So we'll go for each item, in item prefabs. We'll set our item dictionary, square brackets item.id. So we're setting the key to be the item's ID and set this to be equal to our item.gameObject. Next, we're not going to want this update function, but we are going to want to write an item retrieval function. So let's go public gameObject, get item prefab, and we'll pass in the item ID. Now you may think I'm about to write this. This is how you grab the ID. But what if someone passes in 78 and 78 doesn't exist in here? This is going to crash. And we don't want crashes. So instead we can use item dictionary dot try get value, pass in the item ID that we're trying to get, then type comma out gameObject prefab. This way it won't crash and will instead give us a null gameObject. So we can say if our prefab equals null. We can handle this by logging out a warning and say item with ID, item ID was not found in the dictionary. Now I'll teach you something else cool. To get this parameter to appear in the middle of this string, you could do this, which is quite ugly, and compound it with pluses, or you can do it the cool way and at the beginning of your string, outside the quote mark, put a $, then put curly braces around your parameter. Now whatever we pass in this parameter will appear in our log message. Very cool. Last thing to do at the very bottom, just return our prefab. So cool, our item dictionary is all done. If we go back to Unity, you can see we've got an empty list of item prefabs on our item dictionary script. I'm going to open up my prefab folder, click back on my item dictionary and drag my base item into this list and our heart item. Great. Next, we're going to want to write a class for our inventory save data. What we're going to need to want to know is our item ID and our slot index. So in my scripts folder where we have our save data, I'm going to right click in here and go create C# script, call it inventory save data. Double click on this. Then like with our save data, we're going to want this to be system serializable. So at the top, add square brackets and type system serializable, delete, update and start. And like I said, we'll want a public int for our item ID and a public int for our slot index. This slot index is going to be the index of the slot where the item is placed within our inventory. So for example, if I save this now, our heart potion would be in number 2 and our normal potion would be in number 1. And that's it for our save data. So cool, very simple. What's next? Why, of course, we have to add our inventory save data to our normal save data class. So back in Unity, inside our scripts folder, we'll find our save data script. Double click on it, and as we have our player position, our map boundary, we also want our public inventory save data. We'll name this inventory save data. Cool, very easy step. Let's check what's next. So next up, we're going to want to add to our inventory controller, our existing one that we wrote in our last video. We're going to need to add some functions for getting the inventory items and seeing what slot they're in when we save, and then setting our inventory items into certain slots for loading. So back in Unity, we select our game controller. This is where I've placed my inventory controller script. I'm going to double click on this to open it up. And in here, I'm going to want a private reference to our item dictionary. I'm keeping this private so we can't accidentally edit our item dictionary. We want this to always stay the same. And at the top of our start, I'm going to go item dictionary equals find object of type and pass in item dictionary. So we can grab our existing item dictionary from our scene. Now below our start, I'm going to write a public function where we're going to get a list of inventory save data. Now call this get inventory items. So this is what our save controller is going to call to get the data needed for saving. Now that I've written this, I realized if you just go back to our save data, I messed up and this should be a list of inventory save data. As our inventory save data is item IDs and slot indexes, we want many of them, not just one. Silly me. Cool. So save data needs a list of inventory save data. Okay. Back to inventory controller. Let's create our list of inventory save data. I'll simply call this our inv data, so it's not too long. We'll have this equal a new list of inventory save data. Next, we're going to want to say for each transform slot transform in our inventory panel dot transform. So for every slot in our inventory panel, I want to grab the slot game object. So slot equals slot transform dot get component and pass in slot. And we want to grab this slot because inside our slot we can say if slot.current item does not equal null. So we have an item in an inventory slot. We can grab the item. So item equals slot dot current item dot get component item. Now we can finally set our inventory data by typing dot add brackets new inventory save data curly braces and set the item ID to equal our item dot ID, of course, and our slot index to equal our slot transform dot get sibling index. Now you may be thinking, what does get sibling index mean? As always, Unity documentation is much better at explaining than I am. So get sibling index gets the index of a game object in conjunction to other game objects on the same level. So if they all share a parent, it's where they sit in the sibling hierarchy. And if that still doesn't make sense, in our UI, if I show you on our inventory page, you can see we've got all these different slots. They are all parented to the inventory page object. So this will be slot number 3, 4, 5, 6. So cool. That is what get sibling index does. Very handy. And now we need to return our inventory data at the very bottom. Great. So that's what we need for saving. Now for loading, we're going to need a public void set inventory items. And in here we pass in our list of inventory save data. So in here, first what we're going to do is actually destroy. So first what we're going to do is clear out our game objects entirely. So first what we're going to do is clear out our inventory panel, slots and all. So we're going to say for each transform child in inventory panel dot transform destroy child dot game object. Then I'm going to create some new slots by going for brackets int I equals 0. I is less than slot count, which we initialized above in the previous video, then I++. In here, all we want to say is instantiate slot prefab, comma, inventory panel dot transform, which sets the inventory panel to the parent of these slot prefabs. And then we want to populate our slots with saved items. So we're going to go for each inventory save data in, oops, I haven't named our parameter. Call this inventory save data. So for each data in inventory save data, we'll say if data.slotIndex is less than our slot count, so it can actually fit inside our inventory slots, and we haven't saved something silly, we'll go slot equals inventory panel dot transform dot get child, and we can pass in our data.slotIndex to grab the correct child and the correct slot, and type dot get component slot to grab this object. Next, we want to get the game object of our item prefab out of our item dictionary. So equals item dictionary dot get item prefab and pass in our data dot item ID. See, it's all coming together now, right? It's all making sense. Cool. So if our item prefab is not equal null, then another game object of item equals instantiate item prefab, comma, slot.transform. So we're creating a new object of this item prefab from the item dictionary and sticking it inside one of our slots, because of course you could have multiple of one item. Next, to make sure this is positioned correctly in our slot, we'll go item.getComponent rect_transform.anchoredPosition equals vector2.0. And finally set our slot.currentItem to equal our item. Amazing! So now, of course, because when we load our game, we are now creating our slots and populating them. Up the top of this inventory controller, we used to do this in our start. So if you're brave enough, you can delete this, or if you want to keep a hold of this code just in case, you can click this little button at the top, which says comment out selected lines. I'll leave it commented out for now. So great, that was a lot of business. Don't worry, we're almost done. Back in our plan, finally, we want to add to our existing save controller. Of course, we need to add to our saving and our loading. So in Unity, on my game controller, I have my save controller script. I'm going to double click on this, and at the top underneath save location, I'm going to want a private inventory controller, which I'll call inventory controller. And in our start, we're going to want to set our inventory controller to equals find object of type inventory controller. Cool, so nice and easy. Just watch how easy this is in our save data. After our map boundary line, I'm going to go comma inventory save data equals inventory controller dot get inventory items brackets. And that's it. That's your inventory save data done. Easy, right? Now get ready for the next bit. Even easier. Well, it's about the same. In our load game, at the bottom inside the if braces, I'm going to go inventory controller dot set inventory items, and inside the brackets, I'm going to pass in save data dot inventory save data. And we're done. that's it. It like comes out of nowhere, right? You do all this setup and then suddenly you use it and it's like, oh, that was so easy. That was worth the effort. Cool. Nice. Let's go into Unity and test it out. So all the setup we need here is our item dictionary with our 2 items, and make sure your prefabs have the item scripts assigned to them. You can see now our items have auto-incremented from the last time I played my game. So cool, let's press play. And if I press tab and open my inventory, you can now see we've got no items in here because we clear this out. To be able to test this, as I have no way of picking up items or getting them yet, I'll add that soon in our game. If we open our UI and open your inventory page, you can see all your slots here. To test this, you can drag your items from your prefab folder straight into one of these slots and they should appear nicely in your screen. So I'll drag these into some random slots and they become fully interactable just as always. So let's place our item somewhere we'll be able to remember. Hard in the bottom left. Cool. Save this in our settings. Oh, and you can see we've got an error on the side here. It says you're trying to create a mono behavior using the new keyword. I have messed up. A handy way I'll show you how I debug this. Double click on this error message. It'll show you it's saying I'm creating a new inventory save data and it's saying it's a mono behavior. If we go to our inventory save data, you can see this is of type mono behavior. We don't need this to be mono behavior. We want it just to be a class. My bad. Easy fix. Back in Unity. Let's close this back down, press play again, and restart our test. So I'll open our inventory again, drag in our items, 1 heart, 1 green potion, drag them to our nice spots. In fact, I'll go to different spots now. So go to settings, click save. We got no error this time. Of course, our items are still there if we open and close the tab, but we want to actually quit out of our game. So unplay your game, then click play again, press tab, inventory, okay, and they're gone. I was expecting this, don't worry. We've got an error. Object reference is not set to an instance. So what this is saying is our item dictionary is null. Now this is happening because our save controller loads up faster than our item dictionary, calls set inventory items, and then our item dictionary is null. So we need to make sure our scripts run in the right order. If we go back to Unity, in the top left you can click on Edit, Project Settings, and in your project settings list here there's one called Script Execution Order. In here what's currently listed is all the Unity business that we don't really care about too much, and none of our own scripts. So down the bottom right you can see there's a plus. If we click on this, what we want is item dictionary to load first. Next we want our inventory controller to be able to initialize this item dictionary and have it in its file. And then we want our save controller to run, as they're dependent on one another. This is a very important screen when you get into more complex games, as execution orders can make everything break, just like this. So if we click apply, close this down, and now if I press tab and open our inventory, our items are finally there and we have no error messages. Cool, let's move them around. Tab, tab, they're still there. Click save, close debug, press play again, tab, inventory, and there's our items. It's working. I want to take a look at our save data in its file and see the JSON formatting of our saving. So I'm going to put a breakpoint just below our save location and then press play in our game. So when this hits this breakpoint, I can hover over our save location, copy the value, and paste it into the header bar, removing that save data.json so I can see where it's saved. Now I can open this in Notepad and take a look inside. So we can see our player position, our map boundary, and now our inventory save data. We can see we've got our 2 item IDs and our 2 slot indexes. Very cool. And that's how I save inventory states. And speaking of saving, if you also want to save yourself some time, you can go onto my Patreon and grab all these scripts for just £5. And yes, that includes every other script I've ever written on this channel. You're right, that is a good deal. Otherwise, don't forget to like and subscribe, and I'll see you in the next video, where we'll finally be placing items on the ground for our little frog to be able to pick up. That way we don't have to hard code and fake our inventory anymore. And after that, I'll make the hotbar, and then we can use the items. Ooh, so exciting, so cool. Cool, thanks, see you in the next one. Bye. By the end of this video, when we pick up these items, ooh, don't get ahead of yourself, we check our inventory. We can see we've currently got 2 items in here. I expect it to appear in this slot. Let's see. Green item, yes, added. Next, heart item, yes, added. We're going to be able to pick up items in our game and see them added to our inventory. Let's check it out. So if we click on our player, we can see we've got a player movement script. Let's add a new script by clicking add component, new script. And I'm going to call this player item collector. I'll double click on this to open it up. Now, as we pick up these items, I'm going to want to add them to my inventory, which we made in a previous video. So you can check that out if you haven't seen it already. But we made this inventory controller script. So in our player item collector, I'm going to want a private inventory controller. In our start, we'll find our inventory controller in the game by going inventory controller, find object of type inventory controller. Now we're not going to need this update function, but what we are going to want is an on trigger enter 2D. So we're going to be walking into our items in game, colliding with them, and then we want to pick them up. So the first thing we want to do is check if this is an item we've collided with. So I'm going to say if collision.compare tag in brackets and pass in item. When we go back to Unity, I'm going to make sure I add that item tag to our item prefabs. And then if we have walked into an item, we're going to go item equals collision.getComponent and get the item script from our items game object. Now let's check we did get an item script from this by saying if item is not null, then we're going to want to add our item to our inventory. So we're going to need to add a function to our inventory controller to add items to it. So if we go back to Unity, and for me, my inventory script is on my game controller. So I'll click on my game controller, double click on inventory controller, and then at the top underneath start, I'm going to add a new public bool add item. In the parameters, we're going to want a game object, which will be our item prefab that we're passing in from when we pick it up. And the first thing we're going to want to do is look for an empty slot in our inventory. So let's go for each transform, slot transform in inventory panel dot transform. So what this is saying is for every slot inside our inventory panel, we're going to go slot equals get component, pass in slot, and say if our slot is not null and our slot dot current item equals null. So do we have our slot and is there no item in this slot? Then we're going to go game object new item equals instantiate item prefab, comma slot.transform. To get this centered, we're going to go new item dot get component rect transform and go brackets dot anchored position and set this to vector 2.0. Just make sure it's centered in the middle of our slot, and then set our slot dot current item to equal our new item. Because this was all successful, we'll be able to return true. And if this fails and we haven't been able to return true, so none of our slots were empty, we'll debug out so we know what's going on, just in case you try to pick up an item and it doesn't get picked up. And we'll say inventory is full. In future, anywhere you add in these debug logs, obviously you can add a little animation or a little message in game so the player knows that the inventory is full, and then we'll simply just return false. Oh, and actually we're not using the slot transform here, but we are meant to use it over here in the slot.transform so we don't grab it twice. Oh, and I messed up somewhere else. Slot transform, we want to go slot transform dot get component slot. Cool, now if we go back to player item collector, now to add our item, we can use that function by going bool item added equals inventory controller dot add item, and we'll pass in our collision dot game object. Now, if our item was added, so if item added, we will destroy our collision dot game object. So it looks like we're picking this item up. Cool, and that's all we need. If we go back to Unity, if you remember what I said, I want to go to our prefabs, go to our item prefab, so we can remember to add the tag for item. So at the top, there's a tag drop down. We're going to go add tag, add a new one and call it item by clicking that plus button, item, then save. Go back to our prefabs again, click on item, and in the drop down, now select item. Let's check our heart item. As it's a variant, it does use this tag as well automatically. If you didn't make your prefabs variants of each other, you'll have to do this manually to each of them, or select them multiply by holding down shift and then change them all at once. Then next for our items, there's some more we need to add. Right now they're just UI images and they don't have any colliders on them. So if I close these down so we can see some more, I'm going to click add component and add a sprite renderer to our item, then go to tilesets since this is where I'm getting my images from. I'm going to scroll down to find the same image I have in my UI. You could make your UI a different image than your in-game image, but for now I'm just going to use the same for both. So cool, for sorting layer, I'm going to put it on the same as the player. And then this time on our prefabs, of course, we don't want our heart item to look the same as our item in-game. So I'll go to tilesets and find our heart item as well. Of course, when you set up more items now, it'd be much quicker as you'll set up both your image and your sprite at the same time. Next, on our item, I'm going to add a new component and add a circle collider 2D so that our player can collide with them. We don't want to actually bump our heads on it, so you can set this to is trigger. This just means you can walk through the object. So it triggers a collision, but doesn't act as a physical collider. Cool, so as it's a variant, this is added to my heart item as well, and we can now drag these to in our game so we can test them out. Cool, so if we press play, now if I check in our inventory, we've got 2 items in here already. That's fine. Now if I walk into this item, I expect it to go into that first slot. So let's pick it up. Green item first slot. Yeah, green item first slot. Okay, cool. I'm going to keep that in that first slot so that we can see this heart item hopefully appear in our second slot. So let's pick it up. Check, and yeah, it's working. Cool, very nice. Now we've got our inventory and item pickup working. Oh, isn't that satisfying? Pick up the item, check the inventory. Oh, it's in there. Look, we can just trust it's working. Oh, beautiful, beautiful. But you know what? It's missing something. In our next video, we're going to set up some pop-ups in our UI that'll appear when we pick up our items, so we can keep an eye on what we've collected. Be sure to subscribe so you don't miss out. And as always, this code is up on my Patreon, as well as every other script I've ever written. And also, if you want to grab this template, as well as access to all the future features at half price before it's finished, you can get the early access to this game template if you're watching this soon enough. But cool, otherwise I'll see you in the next one. Bye! By the end of this video, when you pick up an item, it's going to appear in the bottom left of our screen in a nice little pop-up, and it'll fade away just like that. When you pick up multiple items, they'll stack on top of each other and be queued. They'll also dequeue and keep stacking and fading away. This will work even if you didn't follow our previous tutorials. You should be able to fit this nicely into your game, but if you did follow the tutorials, you'll see them in our inventory. Very cool, very exciting. Let's check it out. Cool, so in our previous video, we got our items set up. If you haven't followed the tutorial up until now, that's fine. If you have items that you can collect, this should be able to work for you. So I have a UI canvas, which we're going to add a new panel to. So let's right click and go UI panel. I'm going to call this item pop-up container. So we obviously don't want this to be this big. If you open up the reg transform on this anchor presets on the side here where it says stretch, I'm going to anchor it to the bottom left, then change its width to be 300 and its height to be 500. So each of my pop-ups are going to have a width of 300 and they're going to be 100 in height. So I'm going to have a maximum of 5 pop-ups being able to fit in this slot. If you want this to be bigger, you know, I want 10. Obviously, make this 1,000 high. If you want it to be smaller and only show maximum 3 pop-ups, make it 300 high. It's up to you. I'm going to leave this image for now, just so we can see the pop-ups appearing, but obviously if you don't want a background on this, you can just untick it. Then you can see this positioned in the middle of our screen. We don't want that. I'm going to double click on our item pop-up controller and scroll out. You can see this is the camera for our view. I'm just going to click on the move tool and drag this into the bottom left of our screen. Cool, next on our item pop-up container, I'm going to right click and add a UI image, and I'm going to call this our item pop-up. This is going to be the background. I'm going to set the width, like I said, to 300 and keep the height at 100. In my sprites, I've got this little dialog box image, which I'm going to drag into my image on my item pop-up. So we've got a nice little background. Then on item pop-up, I'm going to right click again, go UI image, and I'm going to rename this our item icon, which is going to display a picture of our item that we've picked up. So I'm going to set the width and height to something a bit smaller so it fits within the borders. 75 to 75 works. And the position to be -100, so it fits nicely in the corner, like so. Next, I'm going to have the name of our item appear on the side next to the icon. So I'm going to right click on item pop-up again, go UI text, and call this item text. I'm just going to set the position of this to be 40 and scroll down to the vertex color, our text color, set this to be black. And I've got a custom font that I've imported. So I'm going to drag that in and set the alignment to be centered. Cool, very nice. Now we're going to have multiple pop-ups appear in here. If I copy and paste this one, you can see nothing's happening. They're all just stacking one on top of the other. So an easy way to make these stack for us nicely is to click on our item pop-up container, click add component, and add a vertical layout group. I'm going to untick child force expand on height, and I'm going to set the child alignment to be lower left. Now, if I copy and paste some item pop-ups, you'll see they appear one on top of the other. Very nice. Cool, now we're going to want our item pop-ups to be a prefab. So if you click and drag from the hierarchy into your assets folder, you can then delete this item pop-up and click on item pop-up container, and we'll add a script. We're going to add component, new script, and I'll name this item pickup UI controller. It's quite long, but at least it's descriptive. Double click on this, and in here we're actually going to make an instance of the script. So we'll go public static item pickup UI controller instance, then brackets get semicolon private set. An instance means that any other script in our game can access this script without having to set a reference to it. I'm doing this so that our items will be able to access this when they're picked up, and every single item in our game doesn't have to grab a reference of this script. Instead, this one script calls out to all. So cool, hopefully that makes sense. You'll see how we use it later in our item, but otherwise we're also going to want a public game object of our pop-up prefab, public int of our max pop-ups. I'm going to set mine to a default of 5, and a public float for our pop-up duration. Next, we're going to want a private read-only queue of game objects, and I'm going to call this active pop-ups and set it to be equals new. So instead of start, we're going to want to use awake, as we want this to happen first, and go if this instance equals null. So we've never run this script before. We want to set this instance to equal this. So we're storing a reference to the script. Else, so if there is already an instance and we've somehow created another one of these scripts, we're going to destroy this game object because something's gone wrong. It shouldn't really happen, but just in case it does, we'll add a debug log error. Now we're not going to want this update function, but we are going to want a public void show item pickup. And in here, as we want it to appear on our pop-up, we're going to want a string of our item name to go in the text, and a sprite of our item icon to go on the icon. Cool, so we're going to want a game object called new popup to equal instantiate popup prefab, comma, transform. Passing in this transform means it will appear inside our panel. Now let's set our new popups dot get component in children and pass in tmp underscore text. Grab the text, it's going to have a red underline, so we go show potential fixes and add using text mesh pro, TMP pro at the top, then brackets dot text and set this to equal item name. Now to get the image, it's not quite as simple as just saying get component in children and passing in image, because if we take a look at our item pop-up, we've got an image for our background, which is our dialog box symbol, and an item icon image. So to grab that specific item icon image in our script, we're going to go image and add using Unity Engine UI item image equals new popup dot transform dot find and pass in item icon. Now this is the name of the game object of my item icon. So make sure you're using whatever name you put in for this item icon object. Cool, so then I'm going to say question mark to check if it's null or not, and say dot get component image. I'm going to go if item image, then item image dot sprite equals item icon. Cool, next we want to queue this up. So we'll go active popups dot in queue and pass in our new popup, and then say we've got 5 items picked up and we're about to pick up number 6. We're going to want to destroy the bottom one and add the top one. To do that, we go if active popups dot count is greater than max popups. So we've just added this new popup and now it's hit 6. We're going to destroy active popups.dequeue. So it'll grab the oldest object in that list. Cool, and of course we don't want these pop-ups to stay around forever, so we want them to fade out on their own and be destroyed. So to do this, as you do with anything over time, we're going to write a new private I enumerator, and I'll call this fade out and destroy. And we're going to pass in our game object of our pop-up. Then inside here we'll go yield, return, new, wait for seconds, and pass in our pop-up duration. So when we call this, it's going to wait for our pop-up's duration length, and then to make sure if it has been dequeued and destroyed, it doesn't crash, we're going to say if our pop-up equals null, we'll yield break. And if our pop-up hasn't been destroyed and it's going to fade out on its own, we're going to go canvas group equals pop-up dot get component canvas group, and we'll say for float time passed equals 0. Time passed is less than 1, and time passed plus equals time dot delta time. So as time ticks on, we're going to check again if our pop-up is null. In fact, I'll just copy this line. If pop-up equals null, yield break, as it may have been destroyed again from dequeuing. Otherwise, canvas group dot alpha equals 1f minus time passed. Then we'll yield return null. What this will do is slowly fade out our image's alpha. The alpha is what makes it either opaque or transparent, so it will slowly fade away. Cool, then outside here, once it's faded out, we're going to go destroy, Popup. Cool, and now that's written, we can grab our fade out and destroy, and at the bottom under our comment, we're going to want to go start coroutine, fade out and destroy, and pass in our new pop-up. And that's it for this script. Cool, the next thing we want to do is back in Unity, on our item, we have, if I scroll down, an item script. In here, if I double click, all we have right now is an ID. So we're going to want to add a public string name. So we can put that in the text on our pop-ups. And we also want to add a function for when this item gets picked up. So we're going to go public virtual void pickup. I've made this virtual, so if you pick up an item and want something different to happen, you'll be able to extend from this and change it as you like. But right now, all of them are going to act the same and go Sprite item icon equals get component image, add in Unity engine UI dot sprite. Then we'll say if our item pickup UI controller dot instance is not null, just in case. Then we'll go item pickup UI controller dot instance dot show item pickup and pass in our name and our item icon. Cool, and that's all we need for that little function. Now we're going to want to call this pickup when we pick up an item. In Unity, on my player is where I handle my item collecting. So I have this player item collector script. If I double click on this, you can see I have an on trigger enter 2D. When I grab this item, I add it to my inventory. And here, if the item is added successfully to our inventory, is where I'm going to want to go item.pickup. And that's all I need. Very cool. Now let's go back to Unity and check out our scripts. So I'm going to delete this prefab again. On our item pop-up container, we have our item pickup UI controller script. We're going to need a pop-up prefab inside this game object slot. So I'll grab mine from my assets and stick it in there. Oh, it looks like I didn't set a pop-up duration. I'm just going to go back to my script. And yeah, this pop-up duration I'm going to set to a default of free_f. My bad. What you can also do, if I go back to Unity, is set this in the inspector anyway, which I'm going to reset back to free. So our pop-up should appear for 3 seconds and then slowly fade away. Next, I need to go to my item prefabs, scroll down, and our item script now has a name slot. So I'm going to name this one Potion, and then I'm going to go to my heart item and call this Heart. Next, on our item pop-up, if I click on this prefab, we're also going to want to add our canvas group, and this is what makes our pop-up be able to fade away with this alpha. So cool, that should be all the setup we need. We've got our items here ready to test. Let's press play and pray. So if I check my inventory, we've got some empty slots ready to get these new items in. If I walk on over, keep your eye on the bottom left, ready? Haha, potion. Very nice. Let's see, it's fading away. Heart potion. Let's watch it fade away. Nice, very nice. I'm going to go to my prefabs and drag some more into the game so we can see them queuing and dequeuing. And let's go. Heart, normal, normal, heart. Very cool. Oh, I can't pick them up fast enough to see the dequeuing. Let me up our player's movement speed. Player movement. He's going to be so fast. 10 from 2. This guy got some speed boots on or something. Whoa, oh my god, okay, whatever. You can see how it's just... Okay, that was too fast. Ta-da! You can see they're getting destroyed and replaced with the newest one at the top. Ooh, let's check out our inventory. Now that's a lot of potions. Cool, as always, this will all be on my Patreon, as well as every other script I've ever written. The base template is also up for sale if you want to grab that. Get it at a discount and get all the future features and updates as they come out for free. And be sure to subscribe for next time, where we're going to be adding a hotbar to our inventory. So you'll be able to drag them down to the hotbar and use your items. Very cool. See you in the next one. Bye. By the end of this video, we're going to add a hotbar to our game, where when we go to our inventory, we'll be able to drag items into the hotbar, press the corresponding key. So I'm going to press key number 1. In our console, we'll see using item potion, as that's our green potion we picked up. If I press number 2, you can see using item heart, since that's our heart potion name. We're also going to be able to save our game, so when we close it and reload, our hotbar items will be where we left them, as well as our inventory. Now just a warning, this video heavily relies on you doing the previous inventory tutorial, as we're reusing the prefabs and scripts from those tutorials. So I'm going to link those below, but cool, let's check it out. So first of all, let's do the UI for our hotbar. I've got a UI game object, which holds our canvas for our UI. And if we expand this, we can see all our UI within this. I'm going to right click on UI and go UI panel. and rename this Hotbar. Now we're going to want our hotbar down the bottom, but to the left of our item pop-up container. So I'm going to go left 350, top 980, and right 150. In a previous video, we made slots for our inventory so we can drag and drop items around. We're going to reuse these slot prefabs inside my prefab folder for our hotbar slots. So if I drag and drop a couple of these onto our hotbar, you can see they're all just stacking. Like we've done with our other UI pieces, I'm going to click on our hotbar, add a new component, and add a horizontal layout group. I'm going to child align to middle center. And now when we add some more slots to our hotbar, these will automatically space out nicely. If we press play, I can show you if we drag this item now down, these slots already work. Very cool. I'm going to delete these slots now, as we're going to write a script to dynamically add these in. So back on our hotbar object, let's click add component, new script, and call this hotbar controller. Inside here, we're going to want a public game object for our hotbar panel, a public game object for our slot prefab, a public int for our slot count, and I'm going to default this to 10, since for our hotbar I'm going to be using 1 to 0 on the keyboard, which is 10 numbers. And to get this working with our saving, we're also going to want a private item dictionary, which I'll call item dictionary. And so we can use our items in our hotbar, we're going to want private key array, so square brackets, which I'll call hotbar keys. So this is going to store our 1 to 0 keybinds on the keyboard. If we hover over key and do show potential fixes, we're going to want to be using Unity Engine.input system. If you haven't followed the tutorial fully and this doesn't work for you, you may need to install the package in the package manager, looking for Unity Engine input system. But cool, we're not going to want this start, but we are going to want an awake. Well, we'll first set up our item dictionary and go item dictionary equals find object of type item dictionary, and then we'll go hotbar keys equals new key, and pass in our slot count to make the array the size that we want. Then we'll go for int I. Can you hear that fire engine? Equals 0. I is less than slot count, I++, and say hotbar keys, square brackets I equals I is less than 9, question mark, brackets key, then outside the brackets, another brackets, and another inside that. Pass in int, so we're passing key.digit 1 plus I. Then outside the brackets again, you want colon key.digit 0. What this is basically saying is if our slot is less than 9, we're going to store a key of the number of our slot plus 1. And then on our final slot, we're defaulting to our digit 0. Cool, hopefully that makes sense. Cool, next in our update, we want to check for key presses. So I'm going to copy this for loop from above, paste it down below, and go squiggly brackets. If keyboard.current and pass in our hotbar keys, square brackets, I, then type dot was pressed this frame, then we'll go squiggly brackets, and this is where we'll call a function to use our item that's stored in our hotbar slot. So let's write that function. We're going to want to go void use item in slot. We'll take in a parameter of the index so we know which slot we want to check. So int index in the parameters. Then we'll go slot equals hotbar panel dot transform dot get child brackets index dot get component, pass in slot and brackets. So we're going to get the child that matches the index that we're passing in that has been pressed, and then grab the slot of that object, then say if slot.current item does not equal null, so there is an item in that slot, we'll go item equals slot.current item dot get component item, and then we can call our item dot use item. Red squiggly underline, this does not exist yet. So let's go back to Unity, go to our scripts folder, and go to our item script. In here, let's add a new function. So public virtual void use item. For now, I'm just going to go debug.log brackets using item plus pass in our name. I've made this virtual, so derived or inherited classes can override this function and make it do whatever it needs to do. Say if it's a health item, you'd want it to be consumed and then destroyed. If it was a weapon, you'd want it to do the attack animation and not be destroyed. So with virtual, you're setting up that these items can be used, but obviously they might be used in different ways. Cool, we'll leave it at that for now. Back in our hotbar controller script, let's finish off this using item section by copying use item in slot and putting it up in our if statement in the update. We'll go use item in slot brackets I semicolon. Cool, very easy. Next, hopefully you followed the inventory tutorials because I'm going to cheat here to set up the saving for our hotbar. So on our inventory controller script, I'm going to copy the get inventory items and the set inventory items functions. So highlight these and press Ctrl C to copy. Back to our hotbar controller script, we'll go to the bottom and paste these in. I'm going to rename this to be get hotbar items and set hotbar items. We're going to want to change inventory panel to be hotbar panel in both places. Scroll down, we've got a couple more hotbar panels we need to replace into inventory panels, or the other way around, inventory panel into hotbar panel. And anywhere it says inventory, I'm just going to change to say hotbar. Cool. So now we're going to need to go to our save data, and I'm going to hold down Control and D to duplicate this line, change it from inventory save data to hotbar save data. Go to our save controller, and at the top we're going to duplicate this inventory controller, change that to hotbar controller, rename this hotbar controller, duplicate this line again. You see how you can reuse code. Hotbar controller, very nice. In our save game, we'll go comma, hotbar save data equals hotbar controller dot get hotbar items. And in our load game, we'll duplicate, go hotbar controller, set hotbar items to be our hotbar save data. Now that's all we need to add saving in. So let's go back to Unity, go to our hotbar, and in the hotbar panel, drag in our hotbar. And in the slot prefab, go to our prefabs folder and drag in our slot. If I press play, we can now open our menu, go to our inventory, drag a heart potion into the second slot. If I press number 2, you can see in our console using heart item. Very cool. If I drag this green potion into the first slot using item potion. Very cool. I'll pick up another item just so we've got a bit more. Let's move these around somewhere funky. Cool. Let's go to our settings and press save. Now if I exit out our game, load back in, our items are in their slots. We can use them still using heart, using potion. Very cool. And that's our hotbar all working. So hopefully this works for you. If you do want to make a hotbar and you didn't follow the tutorial, then you can check out the inventory videos. I'll link those below. Or if you don't have the time, you can grab this whole template for half price right now, as we've got only like half the features in. And after purchasing, you will get all the future updates for free. So everything in this coming soon and anything else I do think of. And there is a lot to come still. Very exciting. I hope you enjoyed, and I'll see you in the next one. Bye! By the end of this video, when we open our inventory and drag our items around, they'll still be able to snap back to and go into their slots, but if we drag them off of our menu, they'll drop onto the floor. They'll do this nice little bounce, which is customizable, so you can make your items look either quite heavy or quite light, and they'll drop in this nice circle around your player. Then you'll be able to pick your items back up and throw them around all over again. We'll be using our inventory script from a previous video, so I'll link that below. Cool, let's check it out. Right now, if we go to our inventory page and drag these off of the inventory window, when we let go, they snap back to the slot that they were in before. So we'll keep it like this for anywhere on our menu, but otherwise we're going to edit our drag handler so that when we drop it outside our menu frame, it'll appear in our game on the floor. I'm going to go to our prefabs folder and go to our main item prefab, which is this green potion. I know that's the main one and not a variant because the variants have that hashed out icon on them. So if we scroll down in our item, we can find our item drag handler script. You can also find this inside scripts and then item drag handler, and double click on this to open it up. Now in here, if we go and look at our on-end drag function that we wrote in our inventory UI video, which I'll link below, we have this if statement that checks if we're dropping on top of a slot. If we're not dropping on top of a slot, this is where we snap back to that original parent. So inside this else is where we're going to write if where we're dropping is not within the inventory, then we'll drop our item. Then we'll add an else and snap back to the original parent. So first let's write a function that'll check if we're within our inventory. So below here, we'll want a function that returns true or false, which is a boolean or bool. And I'll name this is within inventory. We're going to want a parameter passed in here for the position of our cursor when we let go of our item. If we scroll up to see this function, you can see we get this event data passed in, which gives us the information of our mouser. I meant mouse and pointer and I said mouser. So if we take a look inside event data by going event data dot, you can see there's lots of information given. Scrolling down, I can see we've got a position. So this is what we're going to want to use, event data position. And if I hover over position, you can see that's of type vector2. So I'll delete this. Back down to our function. In the parameters, we now know we want a vector 2, and this will be our mouse position. Cool, now I turn on our menu and then turn on the inventory page. This inventory page is what I'm going to use to check if we're within these bounds. When we play our game, we can see the slots are children of this inventory page, so keep that in mind as we go back to our script. As we currently have the original parent set as a variable in our game, this original parent is the slot that our item was originally in. It doesn't really matter what slot it is, I just want to use it by going original parent dot parent. So if we remember, the parent of any slot is the menu page. So we're getting the menu page, and I'll be able to go get component and pass in rect transform so we can get the shape of our inventory panel. I'll set this inside a variable called inventory rect. And then here is where we'll call a function which will return a boolean. So we can go return rect transform utility, which is a Unity helper class, then go dot rectangle contains screen point, which you can probably guess what it does. We're checking if what we pass in, which is going to be our inventory rect, if it contains our mouse position. So is our mouse inside this transform? Cool, now we've got this function. We'll be able to go if, and we want this to be if it's not within the inventory, so we do exclamation mark to say not, then is within inventory, brackets, and remember we found that event data dot position. Cool. And in our braces is where we're going to want our drop our item, and then like we said, we're going to want an else where we're going to put our transform set original parent. So this else is going to snap back to OG slot. Next, let's write a function to drop our item. So I'll scroll down to the bottom and go void drop item. And for this parameter, we're going to want to pass in the slot that is our original slot, as it contains all the data we need for our item. And so we can reset this slot to contain no item inside it anymore. So we can go original slot dot current item equals null to make sure that gets emptied out. Then let's break this up with comments again. First, what we're going to do is find the player, so we can drop the item near our player's position so that it's not just static and they all stack up. I'm going to find a random drop position, which is going to drop near our player. Then I'm going to instantiate a new version of our dropped item and then destroy the UI one. Now I tried just moving this item from the inventory instead of instantiating a new one, but the game kept breaking. So this is the easy hacky way, and really your player shouldn't be able to drop that many items all at once, so this should be fine. So cool, first we want to find the transform of our player, so let's go transform, player transform equals game object dot find game object with tag, pass in player, and we can go question mark dot transform. The question mark checks if it's null before we grab this transform. So if it is null, it won't crash here. And in case this is null, we're going to want to know in our game, even if it doesn't crash. So let's go if player transform equals null, debug.log error, and I'll pass in missing player tag. And then we'll return out so nothing else crashes. Next, we're going to want some variables. Next, we're going to want to add some variables for the drop distance from our player that our items will be able to scatter around. So I'm going to scroll to the top. I'm going to go public float min drop distance, and I'll set this to a default of 2f. And I'll hold down Control D to duplicate this and change this to max drop distance and set this to a maximum of 3f. So it's far enough away that we don't automatically pick it back up. It's not too far, so if we do want to pick it back up, it's not too annoying. Cool, with those I'll scroll back down. We'll want a vector 2 called drop offset, which will equal a random dot inside unit circle, which as you can see this says it returns a random point inside or on a circle within a radius of 1, blah blah blah, dot normalized times random dot range, and pass in our min drop distance and our max drop distance. So this is going to pick a random position in a circle for us, and then we're going to times that by our distances randomly. So it should drop randomly in a circle around our player. Very cool little bit of code there. Now to get this near our player, we go vector 2 drop position, and that'll equal our player transform dot position plus our drop offset. This has got a red underline because our player transform dot position is a vector 3. To turn this into a vector 2, to make this work, at the beginning of player transform you go brackets vector 2 brackets. Cool, now we can use these positions and go instantiate game object, which is the game object this script is on, which is actually our item, since that's what we're dragging. Then drop position and comma quaternion, I'll learn how to say that properly one day, identity, which just means that it'll have a normal rotation. Great, so we've made a new version of this game object, which is going to appear in our game scene. Now we can destroy the UI game object, even though they are the same thing. But yeah, I tried just moving the position. If you can get that working, please show me. So great, let's get our drop item function and scroll up to where we say if this is not within our inventory where we're dropping this, drop item, and we want that original slot. Very cool. Let's go back to Unity, and when we press play, I'll pick up these items as our inventory is empty, open our inventory, and now if we drag this item on the menu, we see it still snaps back to the original parent, goes to other slots. But if I drag this off our menu, it's gone from the UI and it's appeared in our scene just around our froggy. If I drag this heart item down to our hotbar, our dragging functionality is actually still active on our hotbar. So if we drag this off, you can see it appears up the top. Amazing. Now with these, we can still pick them up and they're back in our inventory. Very cool. Now, you may agree that when I drop these and they just plop down very statically, it looked weird. So I was like, I need to add some cool effect to this. I know you've seen it in the intro, so you know what I'm talking about. Let's add that in. Now I'm actually going to write a new script for our bounce effect that we're going to be able to attach to our items. This is supposed to be our green potion. I have said before I'm not an artist. And not only just our items, but the way I'm going to write this bounce effect script is going to work even for if we add like a little slime enemy. Maybe he wants to bounce around. Or what else bounces? Flowers? Maybe flowers want to do some bouncing. This is where you need to think about your scripts and not attach them too tightly to just like items, because things like this can be reused. So cool, in my assets, I'm going to right click and go create C# script. I'm going to name this bounce effect. Let's double click on this to open it up. And in here, we're not going to need start or update, but we are going to want a public float for our bounce height, which I'm going to set to 0.3f. I'm going to go Control D to duplicate this, and this will be our bounce duration, which I'll set to 0.4f, and then a public int for our bounce count, which I'll set to 2. This is my second attempt at my potion, it's not getting better. The reason we have the bounce count is because the way I imagine this is our item is going to drop out and go boom, boom. So it's going to move it up and down with decreasing height with each bounce. It gives a nice effect, you'll see. Well, you saw it at the beginning, so whatever. So cool, we're going to want a function. So go public void start bounce. So our other scripts can call this, like when an item is dropped, we can call start bounce. Then we're going to call a coroutine, which we're going to write now. So let's go private enumerator. I'll call this bounce handler. And in here, we're going to want transform of the object that we're bouncing, so we can manipulate that. We need to store the vector free of the start position of our object, so we make sure it's not bouncing and then ending up somewhere weird. So we'll store object transform.position. We also want to add a float locally, so I'm going to go local for the height and set this to be bounce height, and then another float for local duration equals bounce duration. This is because we're going to be decreasing the amount with each bounce, so we need some variables to be able to actually change and manipulate without changing our stored ones at the top here. So now to get this bouncing, we're going to do a for loop and go for int I equals 0 semicolon, I is less than bounce count, semicolon, I++. And this is where we're going to call a new coroutine where we're going to bounce, and after each one of those bounces, we're going to set our local height be times equal 0.5f, so that'll half the height that it will bounce the next time, and then set our local duration to times equal 0.8f. So it won't bounce as fast, but I don't want to completely half it, otherwise it will like move in slow motion. And then at the bottom here, we'll go object transform dot position equals the start position. Because if this was an enemy, you wouldn't want it going up and down and actually moving on the map. We want it to bounce and then come back to where it was. So cool, let's write this other coroutine for bouncing. So let's go private enumerator bounce. And we're going to want a transform for the object transform, a vector free for the start position, a float for the height, and a float for the duration. First, we'll decide where the peak will be of our bounce. So let's go vector free peak equals the start plus vector free dot up. So we know we're going in the up direction times height. Then let's set a float, which will store our elapsed time. I'm just going to call this elapsed. Oh, and we'll set it to a default of 0f. So every time this starts, we're starting back at 0 for our timer. Cool, so now we're gonna do some loops to move upwards and then another loop to move back downwards to complete our bounce. So firstly we'll go while elapsed is less than duration that we've got passed in. Our object transform dot position is going to equal a vector free, and we're going to be using lerp, which if you didn't know interlopes between 2 points. So we're going to want to move from our start position to our peak, and the amount of time we want that to do that over is our elapsed divided by our duration. We'll then go elapsed plus equals time dot delta time, then yield return null. So that once we reach this point, it'll keep going around this while. Cool, so that'll move us up to our peak. And once this while is finished, we're gonna wanna set our elapsed time back to 0, as now we wanna move downwards. And guess what we can do for this? Copy this move upwards code, paste it to the move downwards. And this time in the lerp, we're gonna wanna start at our peak and end at our start. So you just switch these two values around. And that's what you need to be able to bounce. Cool. If we scroll back up in our bounce handler, we need to now call our bounce. So let's go yield, return, bounce, pass in our object transform, our start position, our local height, and our local duration. Now with this local duration, you actually want a slash to divide this by 2. As this is going to be called multiple times, we don't actually want it to run for that long. It'll be very slow. Dividing this by 2 gives you a pretty good bounce length. So cool, now up in this start bounce, all we have to do is go start coroutine, brackets, bounce handler, and pass in our transform. And I've just realized this transform is always accessible. So anywhere we have objects transform, we're actually just using our own transform. You can tell I wrote this and didn't double check it through. Duh. Okay, so bounce handler. We don't need to pass in this object transform. I'm going to remove this parameter and we'll be able to see that everywhere we use objects transform, you can just use transform because it's the object that we are attaching the script to. So of course, you just use the transform. Bounce doesn't need transform passed in because we're still in the same script. Oh, I'm silly. As the code gets more complex, I make more mistakes. And you know, that's fair. This is game development. So cool. Now with this bounce script, we'll be able to go to our item drag handler script and look back on our drop item function. When we instantiate our dropped item, we're also going to make it bounce. So we're going to need to store this game object in a variable when we instantiate it. So I'll call this drop item. Now on our item prefabs, we're going to be attaching that bounce script in a moment. So we'll be able to go drop item dot get component and grab the bounce effect, go brackets dot start bounce. And that's all you need. Very cool. Let's go back to Unity and add that script. So in your prefabs folder, again, go to your main item there. I'm going to scroll down to the bottom, find our bounce effect script in your assets. I'll drag this into our script folder in a moment. For now, I'm going to drag this straight onto our item object in the inspector. And you'll see our bounce effect is there with all the bouncy variables. Back in my prefabs, I have these two different items. A fun thing you can do, which I found through testing, is actually making these bounce with different values here. So this green item is bouncing twice. Let's go to our heart item, and I'm going to make this bounce 3 times. Set the bounce duration to 0.3 and the bounce height to 0.4. So cool, let's press play and test this out. We'll pick up our items. I'll go to our inventory and drag these into our hotbar so we can see the bouncy effect. First, we've got our 2 bounce green item. Bounce, bounce. Very nice, very cool. Heart item. Bounce, bounce, bounce. Okay, so did you see how they look kind of different? To me, I feel like it looks like the heart item is lighter because it bounces more times and goes a bit higher. And the green item now looks heavier because it bounces slow and like only twice. It's like boom, boom. And even when you drop these items inside the inventory window, you will see it's bouncing. You just have to tab out of the inventory really fast to see it. But cool, it's all working. In our next video, this is my test project, so you're getting a little sneak peek here. I've actually written 2 types of map systems, the first being this one I'm showing you now, based on hand-placed images. And coming after that will be our dynamic map, which will be generated automatically based on the areas of your game. Very cool, very exciting. Be sure to like and subscribe to see that. And another reminder, our top-down template is still on sale for half price, where you get all our finished features and any of the future features for free. So once all these features are out, it's going to be double the price. If you buy it now, you get all those features for half price. It's a really good deal. It's way too cheap. I might even increase that final price because the stuff I'm adding is getting quite detailed. But cool, I'll see you in the next one. Bye! By the end of this video, when we move areas in our game, we are now going to have a map in our menu which depicts the areas that we're moving to. We're going to have a little froggy icon which also moves as we move in our map. The areas we're not in are going to be dimmed out and the area we are in is going to be highlighted. So cool, let's go check it out. So right now in our UI we have our menu screen, and if I open this in our pages we have a map page. This is currently empty aside from our title text. So what I'll first do is right click and create an empty game object which I'm going to call map_manual, as we're going to be manually placing our images inside. Then with map manual selected, I'm going to right click and go UI image, and this image is going to represent one of the zones in our map. Right now, if I double click on my map bounds object, you can see I've got two areas in our game. One I've called T1 for the town and another called F1 for our forest area up above. So I'm going to name these images to match these unique map boundaries. So the first one I'm going to call T1, and I'm going to go in my assets to my tile sets, then open up my tile set house and select an image that can represent our town. This one kind of looks towny, so I'm going to drag it in. Obviously for your game, you can create something a bit better by drawing a little mini town and placing this in here. It can be whatever you want. Then if I double click on this T1 again, we can go back to our canvas in the scene. And with the move tool selected, or by pressing W, we can move this around our map. So I'm just going to lower this down a bit. Then I'll right click on map manual again, go UI image, and this one will be for F1, our forest area. So I'm going to go in my tile set floor to find an image for this. Now just look for something grassy. Cool, now I'm going to move that up just a bit so there's a bit of room between them. And next, as we saw in the beginning, we had a little icon for our player. I'm going to store that in the map page, not the map manual area, by right clicking and going UI image and naming this player icon. In my sprites, I have my frog's idle, so I'm going to grab one of these and stick it in there. It's a bit big, so I'm going to set the width and height to 75. And as you can see, as he's on the green, it's a bit hard to see him since they're both green, and it's kind of nice to highlight our player a bit more. So instead of using this frog idle, I'm going to click on the source image on this little circle on the side and search for KNOB for a knob. This gives a little white circle image. I'm going to click on the color and set the alpha down to about 100. Then I'll right click on player icon and add another image, which is a child to this player icon. I'll call this player sprite. And now I'll drag in my idle image and make his width 50 by 50. You can see he's a bit off center as our sprite has a bit of headroom. I'm just going to drag him up and center him in the middle of this knob. Very nice, we got a little player icon on our map location. So cool. Next, on our game controller, I'm going to right click on here and go create empty and call this map controller _manual. I'm going to use this object to hold our script for our controller. Let's go add component, new script, and call it map controller _manual. And I'm calling everything _manual instead of just map controller, as in the next video I'm going to be doing a different type of map which is going to be dynamically made based on these boundaries. But for now, let's go inside our script by double clicking on this. Now in here we're not going to be using start or update, so we'll delete these, but we are going to want our script to be a public static map controller manual instance. You can type brackets get set. Now by making this an instance, you can call any method in this script from other scripts without having to pass over references. And as this is going to be used in quite a few places, I've decided to make it an instance. So cool, next we're going to want a public game object of our map parent. The map parent will be this map manual, as this has the children of our different map images. And then we'll want a private list of image for all our map images. And we'll want to get rid of this red squiggle by using unityengine.ui. Now actually, if you don't include private or public before your variables here, it will be private. So we can just get rid of that private. And next, let's have some colors for highlighting our map. So let's go public color highlight color equals color dot yellow. You can make this whatever you want. And then we'll make a public color dimmed color brackets 1F 1F 1F, which is the color code for white. And then for the alpha, which means the transparency, I'm going to set it to 0.5F. So any area we're not in, we're going to be dimming it to half transparency, and the place we are in, we'll highlight it in yellow. And finally, we're going to want a public rect transform, which is going to store our player icon transform. and we'll use this to move our player icon around to whatever location we're currently in. So cool, to set up this instance, first of all, we're going to want an awake, and inside here, we're going to go if instance is not equal to null and instance is not this. So is there a duplicate script running? We only want one version of it. If there is a duplicate, we're going to destroy this game object. Else, if there is no instance, so it is equal to null, we want instance to be set to this. This is a reference to this script on this game object. Then also in the awake, we're going to want to get all the map images that are the children of our map parent. It's easier this way to pass in the parent and grab all its children, rather than remembering to drag in each one of the children, because if you keep expanding your map, you don't want to have to remember, oh, now I need to go back to the map script and keep dragging it in, blah, blah, blah. So let's go map images equals map parent dot get components in children. Make sure you've got the plural components so we get multiple. Then you pass in the type, which is image, brackets, dot to list, bracket. The reason we want to use to list is because this get components gets an array. And I want it to be a list, as lists have functions in them which help you find the right object. To use this to list, we want to hover over, go show potential fixes, and using system link. Cool, next let's write a new function to go public void, and this will be for highlighting an area on our map. So I'll just call it highlight area. To select which area, I'm going to pass in string area name, and then in here, and first what we're going to do is dim all of our map images and then highlight just the one we've passed in. So first let's dim them all by going for each image area in map images, area.color equals dimmed color. Now we're going to find the corresponding area by the name passed in. So this is going to be the current area we've moved to by going image current area equals map images dot find. Now this find function is why I wanted it to be a list. And with this, we can go x equals greater than x dot name equals area name. So basically we're searching through this list, and for each object we're searching to find where the name value matches the area name we've passed in. If I quickly go to Unity, you can see in our map bounds I've matched the name of our boundary to the name of our image. When we were making these map boundaries, we decided to make sure these were always unique as we use them for saving our data. We're going to reuse this method for our map, so make sure these names match. So cool, we've found our image that we want to highlight. So let's make sure we did find an area with a matching name by going if current area is not null. Then we can go ahead and set current area dot color to equal the highlighted color. Else we can debug out and go debug dot log warning and say area not found and pass in our area name. Cool. Now the last bit we want to do is move our player's icon to our current area. So to do this, let's write a new function and go private void move player icon and pass in the image that we want to move to. So I'll go image area, and in here we're going to want to go vector free position equals area dot get component rect transform brackets dot position. Now with this position we can go player icon transform dot position equals position. Now that I see how short this code is and that we could just cut this off and stick it here, it's currently a one-line function. So instead of doing it here, we just need to move this one line to where we have the area we want highlighted, which is inside this if. So let's cut this player icon transform by going Control X and paste it with Control V up in this current area, and we'll get rid of that function. Just change this area to be current area, and cool, our map controller script is done. Let's go back to Unity, and under our game controller object, I'm going to click on map controller manual. You can see we need our map parent passed in, which is this map underscore manual, the parent that holds your images, and then our player icon transform. So that'll be our player icon. Cool, now we're going to want this to change whenever we move area on our map. There's two times this happens. One is when we walk into one of our waypoints and switch to the next location, and another is when we load in our game. As when we go to our settings and click save, we store the location we were in, and when we close our game and press play again, we're going to be changing location, so we're going to want our map to correlate this. So first off, I go to our scripts folder. We have a script called map transition. This map transition, if we click on our map bounds, is inside each one of our areas we have waypoints. So this is where I walk into and it triggers me to go to the next place. This one triggers me to come down into the town with our scripts attached. So cool, let's double click on this map transition script. And don't worry, this is going to be very easy. In our onTrigger Enter2D, when our player walks through, we'll update our player's position. We can go map controller underscore manual dot instance and then go question mark to check if it's null or not. So we make sure this instance has been created. Then go dot highlight area brackets and pass in our map boundary, which you already have attached, dot name. And that's all we need there. Next, back in Unity, on our game controller, we have our save controller script. We can double click on this to open it up, and we want to find where we load our game. So let's go to the load game function. And here we set our map boundary shape to track which area we need to be in. So under here, I'm going to go map controller manual dot instance question mark to check if it's null dot highlight area and pass in our save data dot map boundary. And that's all we need. If we go back to Unity, we can now press play and we'll see we're in the forest area. So cool, let's check our map. You can see this has been highlighted in yellow, our town has been grayed out, and our froggy is standing in the middle. Let's walk down, and now our town is highlighted in yellow, and our froggy has been moved. We can actually move with the inventory open, so you can see this switching between the two. Let's save now down in the town, close our game, then reopen it. And when we open our menu and go to our map, we can see this is save the location. Cool, and our map is all working. Obviously, you can feel free to customize this map any way you want. Like in maps like Mario, where they have this background image with these set locations that it'll highlight. So you can draw something out like this, and all you'd have to do in Unity is go to your map page again, and you could actually make this map manual an image instead of an empty game object, which could be the background for your map, or you could just straight up add another image, call it background, drag this above your map manual so it's behind your images, and then customize it to be however you like. But cool, that's all we need for this episode. If you wanted to grab all the source code for this whole project, you can grab it on my Patreon for £5. Very cheap. Or you can grab the template, which is still half price, and with that one-off payment you'll get all the future features as well. But otherwise, make sure to like and subscribe, because in the next episode we're going to be adding a dynamic map where you don't manually place your images but will instead be created dynamically based on the areas in your game. Very handy for roguelites or randomly generated zones. Or if you're like me and not very good at design, it's kind of cool just having the shapes drawn out for you. I hope you enjoyed, and I'll see you in the next one. Bye! By the end of this video, when we open up our menu and go to our map, we'll be able to see a dynamically generated map view, where when we change to a new room, it'll update our current location by highlighting it and moving this player icon. These dynamic areas will be based on our predefined map bounds. We'll go into more detail on that, so let's get started. So in our previous video, we made this simple map. We can find it inside our UI, inside menu, and inside our map page. It's called map underscore manual. I'm going to leave this in this project, but so it doesn't appear and we can make our other option for a map, I'm going to untick in the inspector this map manual. I'll leave the player icon here so we can reuse this, which is basically just a white circle image and another image of our player's sprite. And inside our game controller, we've got our map controller underscore manual. I'll also untick this. Unticking these keeps them in the game, but they're deactivated, so these scripts won't run. Now, as we've unticked this map manual, I'm going to click on our map page, right click and go create empty, and name this map underscore dynamic. We'll use this object as the parent for our dynamically made map objects. Next, in our game controller, I'm going to right click and go create empty and make a map controller underscore dynamic. On our map controller, I'm going to click add component and scroll down to add a new script, which I'll name the same as map controller underscore dynamic. I'll double click on this to open it up. Now this is very code based as it's dynamically generated, so get ready to write some code. So we're not going to want start or update, but what we will want are some variables. I'm going to add some headers in to organize our variables out a bit better. So the first one is going to be our UI references, which will include a public rect transform for our map parent, which is what we just created under our map UI, a public game object for our area prefab, which we're going to create after we've done the script, which will be reused as what displays on our map, and a public rect transform for our player icon, which we saw is the little sprite of our player, which will show on our map. Next, I'm going to add another header for our colors. So I'm going to add a public color, which is going to be our default color, and I'll set this to a default of gray. So this is going to be areas on our map that we're not currently in, and then we'll want a public color for our current area color, which I'm going to set to a default of green, which you can guess is our active area color. Cool. Next, I'll write another header for our map settings. On here, we'll want a public game object for our map bounds, which will be the parent of our area's colliders. So if I go to Unity and show you, in our game, we have this map bounds game object, and you can see I have these polygon colliders on our individual areas, which map out the bounds of our rooms. So our player can't leave these bounds. We're reusing these polygon colliders to map out the shapes that will display in our map. So this map bounds is the parent we're going to be passing in. We'll want a public polygon collider 2D for our initial area. So if we've never played the game before, we'll want to pass in the initial starting area that our player starts in, as we won't have save data to load in. So we'll need something to point to. And then we'll want a public float for map scale. And I'm going to set this to a default of 10F. We'll use this to adjust the scale of our map size on our UI. Depending on how big your game ends up, you can change this by editing the scale. Next, I'm going to want some private variables. So I'll want a private polygon collider 2D and make this an array, which is going to hold our map areas. This is going to hold the children of the map bounds. Then we're going to want a private dictionary, do triangle brackets to pass in string and rect transform, as this is going to hold our UI areas. And from the beginning, we'll set this to be a new dictionary, a string transform, brackets, semicolon. And we'll use this dictionary to map each polygon collider 2D to its corresponding rect transform in the UI. As we're going to be creating images from our polygon collider 2D, we need to know which polygon collider maps to which image. Cool. And lastly, we're going to add a public static map controller dynamic instance so that we can access this script with ease from other scripts. We'll go brackets get set, and now we can set up this instance inside an awake. So private void awake, we'll go if instance equals null, and this instance equals this, else destroy this game object, making sure there's only one instance of this script in this scene. And inside this awake also, we're going to go map areas, which needs to hold the children of map bounds, equals map bounds. Oh, I've done it with a capital M. Let's make it camel case and keep it consistent. Map bounds dot get components in children and pass in polygon collider 2D. Also, now I'm going to make a plan using comments of the methods we're going to need. So first of all, we're going to want a function that we can call from loading our game where we generate our map. In case you have a game that randomly generates new areas, instead of just generating the map, we're also going to want to be able to clear our map. When we move locations on our map, we're going to want to update our current area. And to move our player icon around, we'll just want a simple move player icon. So cool, first, let's write a public void generate map. If we're loading this game and calling this function, we may have saved our game in an area that's different to our initial area. If this is the case, we're going to want to pass in polygon collider 2D of our new current area. As this may be a new game and we may have nothing to pass in, we can set this to a default within our parameters by typing equals null. So now we can say polygon collider 2D current area equals, and here we're going to do a ternary check, which is basically saying we're going to do a short version of an if statement by saying if new current area does not equal null. And to make this an if, we go question mark. And so if this is true, it's not null, we're going to set current area to be new current area. And to say else, you do a colon. So else if it is null, we'll set it to the initial area passed in. So we didn't have a save file. So our current area is our initial area. Then to make sure our map is all clean, we'll clear the map. So let's write our clear map function by going private void clear map. We can go for each transform child in map parent. We'll destroy the child dot game object. So this will be any of the images we may have created from generating a map previously. Maybe your maps will change now and you've done some random generation for your areas. Who knows? And then we'll go UI areas dot clear, as we need to clear out the dictionary that holds references to the UI elements of these areas. Cool. So I'll replace this comment here with our function by going clear map. Now, as we've got our map areas set up in our awake, we can loop through these by going for each polygon collider 2D area in map areas. We'll be able to create the area's UI. So let's keep this tidy and write a new function. I'll write this below our clear map and go private void create area UI, and we'll want to pass in our polygon collider 2D of our area, and we'll also want a boolean to know, is this the current area? So is current. So I'll again write out a plan in comments, as this is the main bit of code. So first we'll instantiate our prefab for our image. Then we'll want to get the bounds of our area passed in, so we can then use those bounds to scale our UI image to fit the map scale and the bounds of our area. We'll then set the color based on if it's the current area or not. and then we'll add it to our dictionary. Cool. So let's go at the top, game object, area image equals instantiate area prefab, and the parent will be our map parent. We're also going to want a rect transform, which I'll just call rect transform, of our area image dot get component rect transform, as we're going to be accessing and using this quite a bit, so it's best to store this now. Next we want to get the bounds, which I'll just call bounds, of the area dot bounds. Very easy. Bounds is used in Unity, which you can see represents an axis aligned with the bounding box. So basically just the bounds of our polygon collider 2D. Now to scale this image we've made, we can go rect transform dot size delta equals new vector 2 bounds dot size dot x times map scale, comma bounds dot size dot y times map scale, and then we'll want to set our rect transform dot anchored position to equal bounds dot center times map scale. So this positions it in the correct place on our map. Cool. Next we'll set the color by going area image dot get component and pass in image. We'll have to fix the squiggles by hovering over and using Unity engine.ui. Then we'll go dot color equals, and here we'll use that ternary again by going is current question mark. So if it is current, we'll use the current area color, colon else we'll use the default color. Cool. And then all we have to do is add it to our dictionary. So we'll go UI areas square brackets area.name, so that's going to be the key for our dictionary entry, equals, and we'll store the rect transform. So I've got the position of our image. Cool, now we got this function all finished. We can go back up to our generate map, and in our for each go create area UI, pass in our area, and for is current, we're going to go area is equal to, so equals equals, current area. So do these Polygon Collider 2Ds match? Once we've created all these areas, we can then move our player's icon. So let's go down to that function. We've got that at the bottom. Down here I'll go private void move player icon. For this I'm actually going to use a string, and we'll see why later, for our new current area. So we're going to go if our UI areas, so our dictionary, dot try get value, and we'll pass in our new current area. So we're looking for the key that matches this new current area's name, and then we'll pass out our rect transform, which should be our area UI. So if our area was found, we'll set our icon's position to the center of this area by going player icon dot anchored position equals area UI dot anchored position. That's all we need to move our player's icon. So we can go back up now to our generate map and go move player icon and pass in current area dot name. We're passing this in as a string as we save our locations as a string, so when it comes to loading our game, it's easier to update our current area. Speaking of updating our current area, ta-da, we are still missing one function. So when we move from area to area, we're going to update our current area. So let's go public void update current area, and in here we're just going to want to update the color and then move the player icon. So for this we'll go for each key value pair, the key being our string in our dictionary and the value being the rect transform. Now call this area. In our UI areas we'll want the area dot value dot get component of the image dot color to equal, now here I've actually missed out in our parameters, we're going to want a string of our new current area to know what we're passing in, so we can now check this against our area dot key. So if this area we're checking has the same key as our new current area, then we'll set the color to be our current area color, else it'll be our default color. Then we just need to go move player icon, new current area. Cool, now I've talked a lot about how this is all going to be used when we load our game. So let's go back to Unity and we'll go to our game controller. And on my game controller, I have my save controller. This is where I handle saving and loading of our game. If I double click on this, we can scroll down to our load game function. And in here, you can already see we've got our map controller manual. In the same place, we can also call our map controller dynamic, go dot instance, question mark to make sure it's not null, and go dot generate map. For our generate map, we're going to pass in our Polygon Collider 2D of our current new area. You can see above, we're grabbing the Polygon Collider 2D from our saved map boundary. And so we don't do this find twice. Let's create a new variable inside here by going Polygon Collider 2D. We'll call it our saved map boundary. We can set this to equal this find here. So highlight this code where we do game object.find save map boundary blah blah blah. cut that out and paste it into our saved map boundary. Now we can reuse this saved map boundary both for our bounding shape 2D, and also we can stick it down inside our generate map. Cool, now this is only called if our save data exists. So you can see we have an else here for save game if this doesn't exist. So inside here, we can copy this generate map line, paste it down in our else, and just remove that saved map boundary. As if it's null, we'll use that initial area that we pass in. Cool, next up, back in Unity. Cool, so as we said, we have our map bounds, which holds these areas that we have planned out. Inside each of these areas, we also have waypoints. These waypoints move our player from one area to the other using this map transition script. So I'm going to double click on our map transition script, and in here we can see as we're updating our player position when we move into this waypoint, you can see our old map controller manual. So we know exactly where to call our map controller dynamic .instance .update current area. And in here we can go map boundary .name. Cool, and that's all we need for scripts. So let's go back to Unity. Let's click on our map controller dynamic and let's set up our variables for our script. So for the map parent, we created this map underscore dynamic. I'm going to drag this into the map parent slot. Also just noticed our map dynamic object needs to be on top of our player icon in this hierarchy to make sure the player icon appears on top of our map and isn't hidden behind the images. Back to our map controller dynamic object, we're going to need an area prefab for our script to use and initialize as an image. For this, it's very easy. I'm just going to right click on my map dynamic object, go UI image, and I'll call this map area image. And guess what? That's all you need. So in my assets, I'm just going to drag this map area image into the assets folder, delete it from our game view hierarchy, go to map controller dynamic and drag this map area image into our area prefab. Cool, next up we can see we've got our player icon needs its rect transform, so let's drag player icon into the rect transform. That's the player icon on our map UI. Next you can see your colors. You can change these to be whatever you want them to be. I'll leave them as these default gray and green for now. Map bounds, we're going to want these T1 F1 map boundaries that contain the polygon collider 2Ds. So drag the parent map bounds into the map bounds slot. Initial area, you're going to want to be wherever your player starts off. If I close down my menu, you can see our player is inside my T1 area as default. So he's in my town to start with. So on map controller, I'm going to drag T1 into initial area, and I'm going to leave the map scale at 10. You can change this to be whatever you want. You can play around with the values, see how it appears. But for now, that should be all we need. I'm going to click play and pray. So cool, here's our froggy. I'm going to open up our menu, go to our map, and you can see we've got our 2 locations on the screen. If I close this down, walk into our top area, check the map, check it out, we've been moved. Hooray, isn't that fun? Just as an example, I'm going to create a couple more areas. So I'll click on F1 and duplicate it, drag it over to the right, and I'll rename this to F2. Maybe I'll do another for T1, duplicate it, rename it to T2, drag this down below. Now when I press play, if I open up our menu, you can see on a map these are being positioned out automatically. Now there's gaps between these ones as I didn't position them exactly to make sure the colliders were lined up, and I don't have waypoints to be able to move to these, so I can't show you those activating, but you get the idea. If you set up your waypoints correctly now, to have some moving down here, I'd be able to go into this zone down here. But cool, very nice. We've got a dynamic map. Now if you're thinking, how do I now turn this into a randomly generating map? Well, when I move to a new location, it keeps growing the map out, like a roguelike or a dungeon crawler. What I do is when I walk through one of these waypoints, inside your map transition script, you should create a new function that generates a new area on your map and then moves you to it. So as you go inside this waypoint, it will grab some values between min and max to create a new polygon collider 2D. You could then recall that generate map function we wrote, and your map will update with your new polygon collider areas. I'll make a video for this in the future, but for now I'll continue with this base template. But if you want to go off and do this yourself, by all means feel free. I just thought I'd mention it. So you get the kind of idea how this base template can be used to expand upon. If that script was a bit too long for you to write, you can check out all the scripts as well as all source code I've ever written on my Patreon for only $7 a month, which is £5 a month. Or if you want to grab this whole template, it's still half price, where you'll get all finished features and also any features that I'm going to implement in the future. You'll be able to grab the updates to that for free. So check it out. Otherwise, like and subscribe. Thank you very much for watching, and I'll see you in the next one. Bye! By the end of this video, when we walk up to an interactable object, an icon is going to appear above our player's head to show that it's interactable. And when we press our interact button, we'll be able to interact with the object, where then it'll do its interaction event, like dropping an item. Of course, if we left it there when we restarted our game, the chest will be closed again, and you'll be able to grab more and more items. That's silly, that's infinite potions, our game will be broken. So what we're going to do is add in our chest state to our save feature. So when we save the game and close it down and load it back up, our chest will be opened and we can no longer get more potions. No, I'm stuck with just the one. It'll have to do. So first of all, let's get something to interact with. So we'll right click in our hierarchy and go 2D object sprites square, and we'll call this our chest. In our sprites renderer, I'm going to move this sorting layer to be on the collision layer, as we will have a collider on our chest. I'm just going to move this down in our game. Now to get an image for our chest, I'm going to go to the Ninja Adventure Asset Pack, which I have linked in the description. I'll go to Items and then Treasure, and I'm going to use the little treasure chest. So I'll drag this into our Assets folder into Sprites, select this in Unity, set the pixels per unit to be 16, the sprite mode to be multiple, the filter mode to be point no filter, and the compression to be none. Click Apply, then go to the Sprite Editor. Click on the slice drop down, set this to be grid by cell size, and set this to be 16 by 16. Click slice, then click apply. Cool, now with that sliced up, we can now open up our little chest with this arrow. Click on our chest game object and drag the first top one with the chest is closed into the sprite slot. So now we have a nice little sprite for our chest. Next, our chest will want a collider, so we can check when our player is nearby it. So I'm going to click Add Component and add a Box Collider 2D. And I'm just going to edit this collider by clicking this Edit Collider button and drag it down so it fits around the box. Next, back in the root of our assets folder, I'm going to create a new script by right-clicking and going Create, C# script, and I'm going to name this Interactable. I'm going to double click on this to open it up, and in here I'm going to delete everything and start again by writing public interface interactable. So what is an interface and why am I making an interactable interface? So in our game, we're going to have things we want to interact with, not just chests, but we might also want to interact with NPCs. So we'll have an NPC script which goes off and does things like displaying the dialogue, and chests will go off and be able to spawn items. But both of these we want to be able to interact with by pressing a button like pressing E and displaying an icon over our player's head. So in this interface, we want to define the generic functions of an interactable object. One of these will be avoid, interact, and we'll also want to know, is this object interactable? So we'll do a bool called can interact. This is all we'll need in this interactable, and you may think it seems a bit pointless, but it comes in handy once you see how it's used. So back in Unity and back on our chest game object, I'm going to scroll down and go Add Component, New Script, and call this chest. And double click on this to open out, and at the top here, to make this chest an interactable, we're going to go comma interactable. Now we'll see this gets a red underline. If we hover over, we can see it's asking us to implement the interface members of interact and can interact. There's two functions we set up inside our interface. If we go on show potential fixes, we can click implement interface, and it'll add these two functions in for us, which is very nice and handy. I'm just going to cut these and move them down to the bottom, and we'll leave those there for now and get back to them later. But first, let's go to our variables, as we're going to want a public bool called isOpened, which I'm actually going to set using a getter and setter, which is where we do our curly braces and go get semicolon. And for the set, it's going to be a private set. So we can only set this within this script, but you can get it publicly from other scripts. Next, we're going to want a public string, which is going to be our chest ID, which we'll use for saving our chest's states, which we're going to again use a curly brace and go get private set. Next, we're going to want a public game object for our item prefab, which will be used for the item that the chest drops, and a public sprite, which is going to be for our opened sprite. So when the chest is opened, we'll switch the sprite over to an open chest look. So cool, we're not going to use this update, and in our start, the first thing I'm going to want to do is set our chest ID to equal a unique ID. Generating a unique ID is something handy that we could use in other scripts in the future for saving their state. We could have used it for our map areas or for our item IDs where we were generating unique IDs so that we don't create another unique ID function just for this chest. I'm going to go back to Unity. In our assets, right click and go create script, C# script, and I'm going to create a global helper class called global helper, which I'll double click and open up. And at the top, we're going to want this to be a public static class and remove mono behavior. By this being static, this is going to be accessible from all our other scripts. So we'll put in here functions that can be used generically to do things like generate a unique ID. So let's go public static string generate unique ID, and we'll pass in a game object, which I'll call obj. And this game object will be the unique thing we're trying to create an ID for when we save. So in here, I'm going to go return $, quotes, curly braces, follow with me here, obj.scene.name, then outside the curly braces, I'm going to go underscore, then another curly braces, obj.transform.position, .x, outside the curly brace, underscore, curly braces, obj.transform.position.y. So the unique ID, for example, would be something like chest underscore position x, let's say it's 3, and the position y, maybe it was 4. So this is going to be the unique ID for our chest and for any other objects of states we want to save. So using this, we can go back to our chest script, and on our chest ID, if it isn't currently null, which we can check in a cheeky way by going != equals, set this to our global helper.generate unique ID and pass in game object. Cool, next for can interact, we can do something very simple and just return not is opened. So if it isn't opened, you can interact with it. If it was opened and this was true, we don't want to be able to interact with it anymore because the chest is empty. That was an easy one. Next, when we interact with our chest, we want to say if we can interact, it's all very backwards, then we'll return. Otherwise, if we've got past that if check, we are going to open our chest. So let's write a private void open chest. And what we're first going to want to do is set this to be opened and then drop our item. I'm first going to write a new function, which will be a public void set opened, and I'll pass in a boolean of if we want it to be opened or not. Now that might seem strange, but when we load our game, we're going to go through and set the state of all our chests so we can reuse this function in our save controller later on. So what we could do is go is opened equals opened and then check if is opened. Then we'll change our sprite. So let's write that get component sprite renderer brackets dot sprite equals our open sprite. Now a shorter way to do this, you don't actually have to set this beforehand. Instead, you can go is opened equals opened inside this if statement, and it'll complete this assignment before then checking the result of is opened. So a handy little tip for you there. With that done, we can now use this set opened when we're opening our chest. So set opened, obviously we want this to be true as we're opening our chest, and now we want to drop our item. So we'll say if item prefab, just saying is item prefab does the same thing as checking if it's null or not. Then we'll create a game object, which will be our dropped item, and equal this to instantiate, pass in item prefab, position, I'm going to set to transform dot position, so that's the chest's position, plus vector free dot down. So if you hover over this, that's a shorthand way of writing vector free and then -1 on the y axis. So it's going to appear 1 down from our chest's position, and then quaternion dot identity, which is just the rotation that you have to pass in. Now the reason I've set this to a dropped item is so we can add a bounce effect, same as when we're dropping our items from our hotbar. Our items do a little bounce when it appears from our chest. I'm going to add the same bounce effect. So with our dropped item, we can go dropped item dot get component and pass in bounce effect because this is on our item prefab, and then go dot start bounce. Very easy. So with this open chest script finished, up in our interact, we can now just go open chest bracket, and we're done with our chest. Cool, next up, let's get our player interacting with this interactable. So back in Unity, on our player, I'm going to right click and go create empty, and I'm going to call this an interaction detector. On our interaction detector, I'm going to add a component and add a circle collider 2D. And if we zoom in on our player, we can see we've got a tiny radius around our player. I'm going to set the radius on our circle collider collider to be 1, so that if our player is this close to anything, we're going to be able to interact with it. I also want that icon to appear above his head, so on the interaction detector I'm going to right click and go 2D object sprite square and call this our interaction icon. I'm going to set this sorting layer to be decor, and I'm going to set its position to be on the Y 1. So it sits just above our player's head. Cool, so back in our Ninja Adventures asset pack, I'm going to go to UI, which this is new if you haven't got the latest Ninja Adventure asset pack. It's been updated to include this emote. In this emote, I'm going to pick emote 22 and drag this into our sprites folder. Click on this and set it up again by going pixels per unit to 16, filter mode to point no filter and compression to none. Click apply. Then interaction icon I will click on and then drag in our emote 22. And check it out, he's got a cute little emote above his head. Very nice. Now back to our interaction detector. Let's add a new component, new script. And I'll call this interaction detector. We can double click on this to open it up. And at the top, we're going to want a private interactable, which is going to store our interactable that's in range. And I'm going to set this as a default to equal null. This is going to track the closest interactable to our player. Then we're also going to want a public game object for our interaction icon. Cool, in our start, I'm going to set our interaction icon to .setActive and set this to be false. So this isn't above our player's head as soon as we start. We're not going to need this update, but we are going to want a onTriggerEnter2D, which, speaking of which, let me go back to Unity, and on our interaction detector, yep, it's going to want to be a trigger, so tick is trigger. Since we're using onTriggerEnter2D, we don't want this big circle colliding with anything. So cool. Is trigger ticked? Let's go back to our script. And in our onTriggerEnter2D, we're going to say if our collision.tryGetComponent. So here we're going to check if it has an interactable script on our collision object by going out interactable. I'll just call this interactable. And if we do have an interactable component, I'm going to go double ampersands and interactable.canInteract. So can we interact with this? If so, we're going to set our interactable in range to equal this interactable, and then we'll set our interactable icon to set active brackets true. So now once this enters, our icon will appear above our head. Same thing on trigger exit 2D. Let's copy this if statement because we're going to want to do the same thing, except from if we're exiting the collision of an interactable. We don't want to know if we can interact or not, but we do want to know if this interactable is equal to the interactable that we've got selected, so the one that was in range. If it is that same interactable, we can set interactable in range to be null because we've now moved away from that interactable, and we'll set our icon to be false. So it's no longer above our false. So it's no longer above our player's head. Cool, one last thing we want to add below our start. I'm going to want to add a public void on interact. This is going to be an input action, which if we hover over, we need to add in using Unity input system, as I'm using the new Unity input system for the inputs of our game. You can see this in our movement video, and we'll want this to be .callbackContext, and I'll just call this context. Then inside here, we'll go if context.performed. Do we have an interactable in range? We can check by going question mark, and if so, we'll call the interact that's on that interactable. So this won't matter if it's an NPC, a chest, whatever you want to interact with, it'll know it's something we can interact with, and then it'll call this interact function. So cool, let's go back to Unity. On our interaction detector, you can see we need our interaction icon. So let's drag that in. Cool, all set up. I'll disable the interaction icon and I'll go down to our chest. And in here, we need to add an item prefab. So what is our chest going to drop? So let's go to prefabs, and I've got my potion here, which I'll click on our chest again and drag this into the item prefab slot to assign what it drops. Then go to our sprites, and for our open sprite, I've got this other open little treasure chest, which I'll drag on in. Very cool. So let's test out our chest opening up and dropping us an item. If we click play, walk down to our chest, haha, it's interactable. Now let's press, oh, I said let's press. We haven't set up our player actions. So in your assets folder, I have my top-down template input action asset. If you double click on this, you can see I've got move, which we're currently using, and we have look and fire, which we're not using. So I'm going to delete those, get them out of my face. So on actions, there's a little plus on the side, which you can click and add a new action. I'm going to call this interact. And on no binding, I'm going to click on this, and on path, click on that drop down, and then I'm going to type E on my keyboard, because E is going to be my interact button. You can make this whatever you want. If you wanted this to be for both controllers and keyboards, you could click on this again, click add binding, and then on the path, select maybe gamepad and click button east. So whatever's on the right hand side, what's that, like X or something? B? B for interact, sure. That's how you can add both controller and keyboard support very easily with input actions. Let's click save asset. Close this down and click on our player, where we can see, if I close these, we've got our player input component. Inside here you can go to events and then player, and you can see we've got our move one set up, and now we've got our interact. Let's click on the plus. We can drag in our interaction detector to this little slot, and on no function we'll go interaction detector on interact. Very cool. So now when I press E, we're going to call that on interact function. Let's press play. So I'm going to approach from behind, press E, and there's our cute little item. Amazing. You can see after opening it, I can no longer interact. There's no, oh, I picked up the potion. There's no icon appearing above our head. Cool, but oh no, I'm going to click save. I'm going to close down our game. When I press play again, our chest is closed. And I've still got that potion that we picked up. I could just open it, get it again. Now I've got 2 potions. Unlimited potions. Don't mind if I do. Okay, but that's not right. So let's add the chest's save state to our save data and save controller. So on my game controller, I have my save controller script. I'm going to double click on this, and in here we use our save data class. An easy way to get to this script without going through our asset folder is to hold down control and then click on save data. This opens it up in a little temporary tab. I'm going to right click and go keep tab open so it stays in our little top bit here with us. So for our chest, we're going to want to know 2 things: the ID and is it opened. So I'm actually going to add a new system.serializable just below here of a public class chest save data. In here I'm going to add a public string of our chest ID and a public bool of is opened. Then below our hotbar save data, I'm going to go public list and pass in our chest save data and call this chest save data. Cool. Let's go back to our save controller, and at the top I'm going to want a private chest array of chests, which we're going to use to track all the chests in our scene. We can get this in our start by going chests equals find objects of type chest. Cool. To tidy this up just a little bit, as that's getting quite long in our start, I'm going to go private void initialize components, and I'm going to cut these from our start and paste them down in this initialize components. Oh, I forgot the brackets. Let's tidy this up and then call initialize components in our start function. So cool, down in our save game, here we set up all our save data. So we're going to want to go comma chest save data, and then we're going to want to get our chest save. So let's write a function which will be a private list of chest, and I'll call this get chests state. At the top we'll have a new list of chest by going list chest states equals new list chest. Then we'll go for each brackets chest in chests, very repetitive. We'll create a new chest save data, we'll call chest save data equal new chest save data. Chest doesn't sound like a real word anymore. We're going to want chest ID to equals our chest dot chest ID, comma is opened equals our chest dot is opened, and semicolon at the end. And then we'll want to add this to our list. So chest states dot add and pass in this new chest save data. Oh, we want this to be a list of chest save data, not a list of chests. That's why this is breaking. And we're returning a list of chest save data. Okay, cool. And then we'll return our chest states. That was very chesty. So up in our save, we can now call that get chest state, and that'll be used to save our game. Now, if we go down to where we load our game, at the bottom, we're going to have a new function to load chest state. So let's write a new function and go private void load chest states. and pass in list chest save data. Yes, I'm doing it right this time. Call this chest states. Then we'll go for each chest in chests. So our ones at the top that we've loaded from our game, we're going to go around them and we're going to want to get the chest save data. So chest save data from our list of chest states, which we'll search for by using a dot first or default. There's a red underline, so let's hover over and use system.link. Then go brackets C for chest equals greater than C.chestID equals, so is equal to chest.chestID. So we're going to match on chest ID and grab that save data. And then we'll say if chest save data is not null, then we'll go chest.setOpened to chest save data is opened. Cool, so that'll set up if it's opened or not. It'll set the right icon and make it interactable or not. Very nice. So let's copy this load chest states and paste it up in our load game, and in the brackets we'll pass in our save data .chest save data. Very nice. Let's go back to Unity, press play, and now we can see our chest is closed as we haven't saved anything yet. We've got one item in our inventory. Let's press E, open it up, got the potion. Now I've got 2 items in my inventory and this has been opened. Let's go to our settings, press save, close down our game, open it back up. Haha, and now with our save state, our chest is opened. I can't get any more potions. I've only got these 2. Damn it. Very cool. Now a reminder, if you think, oh, I want this to be closed again, I need to reset that state. But my game's saved now, what do I do? You can stick a breakpoint one below on our initialized components so we can take a look at our save location, then attach to Unity, the debugger. Then when we press play, it'll hit this breakpoint. You can hover over save location. I click on the little eyeglass so it's easier, but you can copy your text here, go to your Explorer, and paste this in. If you remove that save.json and then press enter, you can see where our save data is saved. So now if I delete these, and I'll stop the debugger, now when I restart my game, we'll have no save data in our folder anymore. Now if I press play, this is going to break, but don't worry. Inventory's got no slots. That's weird, but hey, our chest is closed at least. If I try and pick up this item, well, it says inventory's full. We don't have any slots. What's going on? Okay. Our script is broken for our inventory. Let's take a look at our save controller. And when we load our game, you can see we set our inventory items for both our inventory controller and our hotbar. If I take a look at this, this is where we clear our inventory panel and create the slots for our inventory, just in case you have different slots depending on upgrades of bags. So backing our saving controller, you can see if we don't have a file for our save location to load in, we create a new one. We also generate our dynamic map here. So what's the answer of what to do? I'm going to copy and paste this inventory controller, set inventory items. As this is a new save, we're going to have no items. So I'm just going to pass in a new list of inventory save data. Copy this new list and paste and do the same down in the hotbar controller, set hotbar items. Now if I go to our folder again, I'll delete this save data, go back to our game. So this is the first ever load. I've never played this game before. Looks kind of cool though. Now when we load up, you can see we've got our hotbar there and our inventory slots are there. So that's a bug fix. Open up our thing, get a potion, and there he is. Now actually I just noticed something that I hadn't before in my plan. So this is another fix. I just deleted my save data again. I'm going to play again because when we open our chest, I'll walk up and we've got the icon there. I'll open it and our icon stays until we walk away. I think I'd like that to disappear as soon as we've opened our chest. So let's go back to our script. So on interact, after we've interacted, I'm going to want to go if interactable in range dot can interact, and I want to say if not interactable in range actually, so exclamation mark at the front. Then I want to set our interaction icon dot set active back to false, so it disappears straight after we can't interact anymore. Let's go test this out. Back in Unity, I'll press play. Our chest is closed. I'll walk up, there's our interaction icon. Get ready, I'll press E and it's gone. Okay, cool, that works. Now I'm happy. We're all done. That was quite a cool episode where we used some past things like our item bouncing, our save controller, and added some new cool things like our global helper. Yeah, very cool. If you enjoyed that and you want to support me or grab those scripts yourself so you don't have to write them, you can join my Patreon for just $7 a month, which is £5 a month, where you can grab every script I've ever written on this channel. Or you can grab this whole template, this whole project for half price right now, where you'll get all our previous finished features, as well as any of the future updates updates for free. But if not, I hope you enjoyed that. I hope you like and subscribe, and I'll see you in the next one where we'll be adding NPCs to our game with a simple dialogue system. So that's very exciting. Hope you enjoyed and have a nice day. Bye! Previously in our game, I could open our menu and still move around our character. You can see the backgrounds moving around. I can even move to new areas in our map. In most games, you can't normally do this, and we currently don't have a pause system implemented in our game. But by the end of this video, when I open the menu, you won't be able to move anymore. I know you can't tell, but can you hear that? I'm pressing the keys and he's not moving. Cool, let's add a pause system. So first of all, I'm going to write our pause controller script. I'm going to put this on my game controller where I store my other types of controllers that are globally used across our game, and click add component, new script, call this pause controller, and open this up. And inside here, we don't need start or update, but we will want a public static bool, which I'll call is game paused. I'm going to use curly braces and go get semicolon private set. So we can get this publicly from any other script, but we can only set it within our script and set this to equal false. So the game starts not paused. Now to be able to pause our game, I'm going to write a public static void, which I'll call set pause. And we'll pass in a bool, which I'll call pause. And we'll simply go is game paused equals pause. So all we'll have to do is pass in true or false to pause our game. True being it'll pause the game, and false being it'll unpause our game. And we'll be able to use this variable from our other scripts to check if our game is paused and then edit our functionality. So if I jump back to Unity, and we know we want our player to pause when our menu is open. So let's first make the game pause when our menu opens. I have my menu controller on my UI canvas, since this is the parent above our menu. So I'm going to double click on my menu controller script. So in here, you can see when we press tab, we toggle the active status of our menu. So if it's open, we'll close it. And if it's closed, we'll open it using this menu canvas active self. So is the menu active in the hierarchy? We can reuse this by going pause controller, set pause, and passing in menu canvas.active self. Since if the menu is open and this is true, we want it to pause. So we'll set pause to true. Now, if for any reason our game is paused by something else and not our menu, say an NPC dialog box open, we don't want to be able to open our menu as well and confuse this pausing logic. So I'm going to say if not my menu canvas dot active self, so is the menu closed, and pause controller dot is game paused. So if our game is paused, I'm going to return. So we won't continue with this menu functionality. Cool. So let's go back to Unity. Now I'm going to click on our player, and now we can use this pause to stop our player from moving. I'm going to click on our player, and you can see we've got our player movement script. I'm going to double click on this to open it up, and now I'm going to use our pause controller to stop our player's movement. So if I scroll down a bit, at the top of our update, I'm going to say if pause controller dot is game paused, then I'm going to set our rb.velocity to equal vect2 .0, which will stop our player's movement. And you can see when we're moving, we set our is walking in our animator to be true. And when we let go of our movement, we set is walking to be false. Since we're stopping our movement, I'm going to copy this animator set ball line and paste it so our frog doesn't run on the spot. And then I'm going to return. Now you might think, okay, great, that's all we need. I'm going to show you what it looks like right now. As if we left it like this, our frog looks a bit strange, and it's a bit hard to explain without showing it. So if I press play, now I'm walking. I'm going to keep holding down the walking button, open my menu. Okay, I can see in the background we're not moving, but if I now close my menu, okay, we're sliding. That doesn't look right, does it? You see that we were idling and sliding down. Let's do that again. I'm going to walk up, open the menu, and then keep holding it. Yeah, that looks strange. So yeah, you can see it's broken. So what's happening is we're setting is walking to false, and because I'm holding down the move input, this is walking isn't getting set to true again, since it wasn't a new input action. It was a continuous one, but since before we paused the game, is walking was set to false, and then it kept moving again using our RB velocity update. So to fix this, I'm going to remove this animator is walking true from our move function, and instead put it in our update function underneath where we set our RB velocity. And instead of setting is walking to be true, I'm going to set it to rb.velocity.magnitude and check if that is greater than 0. The magnitude is the overall speed that our character is moving. So if it's greater than 0, that means he's moving and he should be set to is walking. So cool. Now if we go back to Unity and press play, okay, so he's moving around all good. That's good. We didn't break any of that. If I now walk down, open our menu, then close it while still holding down, you can see he walks correctly with the right animation. I'll walk to the right, open it up, and now move to the left. So let's switch it up. He's moving to the left. Cool, we've got a functioning pause system. I know in the previous video I said we'd be adding NPCs, but as I also said, this is handy for NPC behavior as well. When the dialog box opens, I'm going to pause the game. So I slipped this one in quickly. Something else I'm also wanting to use for our NPCs is sound effects. So guess what? Our next video, we're going to be adding a sound effect system, which is very fun and will make our game feel much more alive. As always, you can grab all my scripts on our Patreon for $7 a month or £5 a month. That's all code files on the whole channel. And final chance to get this template half price, unless I do a sale later. You know, the amount of features we have is now getting so big that this sale is not viable anymore. So grab the template, which includes all our finished features right now, and you'll get all future updates for free. So check it out. If not, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, we'll have sound effects in our game, like when our frog walks. We'll have a nice, randomized sound where the pitch changes so it doesn't get annoying. Also, when we open our chests, we'll get a nice little jingle. We're also going to have a volume slider in our game, so your sounds can go from loud to quieter. Cute! So in our previous series where we made a platformer, we had a video where we added in a sound effect manager to our game, where I said, we're going to be adding sound effects to our game like this. Or this. If you've completed this video, you'll have the scripts. Or if you're on my Patreon, you can grab the scripts on our Sound Effect Manager's post. I'll link both the video and the Patreon below. But for these, I'm going to be looking at the Sound Effect Library script and the Sound Effect Manager script. So if I started from scratch, I'm going to be repeating a 10-minute video for you. So I'm going to drag in the Sound Effect Library and Manager scripts from our other project into our Assets folder of our project. To set up our Sound Effect Manager, I'm going to go inside our game controller, right-click on our game controller, and create an empty game object called Sound Effect Manager. On this Sound Effect Manager, I'm going to drag on both of these sound effect scripts. On here, we're also going to want an audio source, so we're able to play our sound effects. Cool, now you can see on our Sound Effect Manager, we have a slot here for a sound effect slider. In our UI, in our hierarchy, under our menu, under Pages, I have a Settings page. I'll turn on my menu so we can take a look and activate our Settings page. In here, we have our Save button. I'm going to right-click and go UI, Slider, call this SFX Slider, double click on it so I can see it in my scene view and drag this down below our save. I'm going to open this up, go to open the fill area and go to the fill and set this to a color I can see better. So when I go back to the sound effects slider and set the value to be 1, so our sound will be turned up, I can see the background a bit better. So cool, we'll click back on our sound effect manager, drag this sound effect slider into the slot, and if by magic, this will now work for us. So cool, I'll turn our menu back off. And first of all, for an example in our game, I'm going to add a sound effect to our chest. Inside the Ninja Adventure asset pack that we've been using, there's some sound effects and music provided. So inside sounds, and then inside game, there is a sound effect called Success 1. You can pick whatever you want, obviously, for your chest opening sound effect, but this is what I'm going to use. So cool, I'm going to drag this into our assets, then right click and go create folder and call this sounds and drag that success into the sounds folder. Now in my sound effect manager, I'll show you how to use the sound effect library. This will be a script to store all our different sound effects for us. So if I open up sound effects groups and click this plus, we get a new element in here. If we open up this element, we can give this a name. So I'll call this chest. And then we have a slot for our audio clips. So I can drag success inside this audio clip slot. And if you wanted this to play different random sounds, this is where you'd be able to drag in a different sound effect. So randomly it will go between 2 different chest opening sounds, or 3 or 4, however many you want to add in here. You just keep dragging them in. I'll just use the one for now for the chest, and we'll look at multiple sounds in a bit. Now to call this chest sound effect, when our chest opens, we'll go to our chest object and open up our chest script. Chest, chest, chest. So in our chest script, when we interact, we open our chest. So where we set open to be true, we can also go sound effect manager, which we can call, because this is a static instance script, and then go dot play brackets, and we pass in the name that we made inside our sound effect library. In this case, this will be chest. Let's go inside our sound effect manager and take a look at this play script. You can see we pass in our sound name, so we're passing in chest. We go to our sound effects library to grab one of the audio clips that we passed in that list of audio clips. We only had one, so it will just be that one. And then we play this audio clip. So cool, back to our chest. We now know what this line is doing, and that is all you need. Let's go and test this out. So now if I press play, or as I press play, we can see this don't destroy and load game error comes up in our console. This is from our previous game where we had changing scenes, so we didn't want this sound effect manager to disappear as we moved scenes. To fix this error, you can just drag your sound effect manager to the top of your hierarchy so it's not inside your game controller. Or if you don't plan to move scenes inside your sound effect manager script, you can remove this don't destroy on load line. I'm going to comment this out for now so that in future, if we do want to change scenes, we can just add this back in. So cool, since I commented that out, I'm going to put it back in my game controller, and now I'll press play. Now when we walk up to our chest, we can press E, and you heard a nice little sound effect. Now this repeated sound effect is quite nice for chests, as it doesn't get that repetitive, opening up and hearing that nice jingle. But for something like footsteps, it would get a bit tiring hearing the same thing over and over again. So you might want a randomized pitch or multiple clips passed in. So let's add some footstep sounds to our player so we can check out how to do those things I just said. So first let's set up our sound effect library with a new sound effect group. So we'll click the plus at the bottom and we'll call this footstep. Now we'll need some new audio clips, put in our sound folder, and I'm going to create a new folder inside our sound folder called footsteps, as I'm going to be using multiple. Now there is no footsteps in our Ninja Adventure asset pack, so I looked online, and the ones I liked the best were these free ones from Dryoma on itch.io, which I'll link below for you, and I grabbed the dirt sounds, since most of our ground is dirt looking, and inside we get 21 sound effects for footsteps. So in my new footsteps folder, I'm going to select all of these sound effects and drag them in to our game. Now on our sound effect manager, I'm going to click the little padlock at the top here to keep our inspector from moving when I click on other things, so that I can select all of our footsteps and drag them in. You can drag them onto where it says audio clips, so they all go inside this array. Now when we call play footstep, it's going to play one of these 21 sound effects so that our footstep sounds don't feel repetitive. I'm going to unlock this padlock again so we can go to our player and go to our player movement script to add in the footstep sounds. So at the top, I'm going to want a private ball to know, are we playing footsteps currently? And I'll set this to equal false by default. And then we'll also want a public float, which I'll call footstep speed. And I'll set to a default of 0.5f, which will be the time we use between playing each footstep sound. So basically how fast your player walks. You'll have to play around with this variable a bit to get it to match your animations and player's speed. So cool, if we take a look at our script, we can see whenever we basically set this is walking to true or false, we're also going to want to stop our footsteps when our walking is false, or start our footsteps if our walking is true, like when our magnitude is greater than 0. So I'm going to scroll down the bottom and write two new functions, one being avoid stop footsteps, where we'll say playing footsteps equals false, and then another on top of avoid start footsteps, where we'll say playing footsteps equals true. Cool, so of course if we just went sound effect manager dot play and passed in footstep, we'd call start footsteps and this would play once. That won't work, so of course we want this to keep repeating until we stop moving. Luckily, Unity has a handy function called invoke repeating, where you can pass in a method name by going name of, passing in your method here, then going comma, 0, which is just the time, which we don't really need for this, and then we'll pass in footstep speed, which will say how often this will be repeated. Now to get invoke repeating to work, we can't just pass in sound effect manager here, it needs to be its own method. So I'm going to write another void play footstep, which we can move the sound effect manager dot play footstep into, and in this name of invoke repeating, we can go play footstep. Now when we call start footsteps, we'll set this to true and invoke repeating every footstep speed to play this sound effect. Cool, cool, cool. When we stop footsteps, simply, we just need to say cancel invoke, name of, pass in play footstep, and semicolon at the end. There's our functions all set up. Let's go on above and call these. So when we pause our game, we want to stop our footsteps. So we can call stop footsteps here. Now here to start our footsteps, we want to say if, and we can copy this RB velocity, magnitude greater than 0, and use it down here as well, since this shows if our player is moving. And if we're not, so exclamation mark, playing footsteps, so the sound effect isn't already running, then we'll start our footsteps. Else, if our RB velocity dot magnitude equals 0, so we've stopped moving, we will stop our footsteps. Very cool. Let's go back to Unity and test this out. So once again, in our sound effect manager, we've got 21 options for our library to go through as our player walks. So let's press play. Now when we walk, we can hear all these different sound effects. Very cool. Now I don't know about you, but to me this sounds quite realistic for a 2D game, and I feel like it just doesn't suit our little froggy vibes. I'm going to remove all these audio clips by typing 0 in the amount, and in our footsteps sound folder, you can see on the icons of these audio clips the size of the audio waves. So I'm going to pick this one because it looks quite nice and quiet and drag it into our audio clips. Let's take a listen to see what that sounds like with one repeating clip on its own. To me that sounds a bit better, but after a long time, that repeating sound gets a little annoying. So on audio source components, you have this pitch slider. Changing this slows down or speeds up the sound. I'm going to edit this pitch to randomly change each time we take a step. However, I also use this audio source for our opening the chest, but I don't want my chest sound to change randomly. So what you can actually do is add another audio source. So we've got 2 on our sound effect manager, and one we'll use for randomly pitched sounds, and the other we'll use for our normal sound effects that we don't want to change the pitch of. To do this, I'm going to go inside our sound effect manager script, and I'm going to duplicate this line where we have this audio source. So we have 2 here. Then call this second one random pitch audio source. Underneath where we set up the instance and get our component for the audio source, I'm going to go audio source, square brackets, audio sources, equals get components with an S, and pass in audio source. So we can get both audio sources on our game object. Then for our first audio source, I'll set this to equal audio sources, square brackets 0, which just means it'll be the first in the list. Then we can set random pitch audio source to equal audio sources, square brackets 1. Next, down where we have our play function, we pass in sound name. I'm going to go comma, bool, random pitch, and set this to a default of false, so that by default most of our sound effects won't have a random pitch. So now inside our if audio clip does not equal null statement, we'll go if we do want a random pitch, we'll set our random pitch audio source dot pitch to equal random dot range and pass in 1f, which is your normal sound effects pitch, and 1.5f, so we're pitching it up by half before we then go random pitch audio source dot play one shot and pass in our audio clip. You can change this range even lower to 0.5 if you want, so you get some deep bassy footsteps and then some high pitch ones, but I'm just going to keep mine at 1F for now. Test it out if you like. And then we'll simply say else and move our normal play one shot to our normal audio source. So cool, that's a nice little upgrade to our script. Let's go to player movement and scroll down to where we play our footstep. In here we can now type comma true, so that we set our random pitch boolean to be true, then go back to Unity. Now when we press play, when I move now, you can hear it's going up and down pitches. It's very subtle, but I think it makes quite a big difference in not getting too annoying on the player's ears. And as before, we can go up to our chests, and these will all be the same, without their pitch affected. Very cool. Oh, and I almost forgot we didn't test out the slider in our settings. So of course by default this is to the max. So let's take a listen again. We'll listen to this on max volume. Go to our settings and put this on half. Go to our next chest. That's a bit quieter. And now let's go to our final chest. Turn the settings all the way down to 0. Open our chest. It didn't make a sound. But wait a minute. My player's footsteps are still making sounds. We've forgotten something in our script. In your sound effect manager script, of course, we have our audio source volume being set when we change our slider. Let's duplicate this line and add in our random pitch audio source as well. Silly me. Okay, one final quick test. Footsteps. Audible. Turn that sound down. It's silent. No chest sound. Oh no, let's turn that back up. I missed that little jingle. Beautiful. Rap, rap, rap. Nice. So cool, we've got sound effects now. I slipped this one in as well just before our next video, which is going to be adding in NPCs and their NPC dialogue. So be sure to like and subscribe so you don't miss out on that. And as you saw in this video, it's very handy to be a member of our Patreon so you have access to all our previous scripts. Or as always, you can grab this whole template with all the finished features as well as any future updates that you'll get for free. So check it out if you haven't already. Otherwise, like and subscribe. Thank you for watching, and I'll see you in the next one. Bye! By the end of this video, we're going to add some NPCs to our game, where when you walk up to them and press your interact button, they'll talk to you. We'll be using scriptable objects to add in the dialogue lines and different options, like speed and sound of the voice. You'll be able to auto-progress your lines or not, very customizable. So cool, let's check it out. So first, let's get our NPC's game object set up. So let's right-click in the hierarchy and go 2D object, sprites, square, and I'll call this NPC. If I open up the sprite renderer here, I'm going to add the sorting layer to be on the same layer as player, so that when we move our NPC around, it can stand in front of these collision objects and go behind our walk behind layers. On our NPC, we're going to want to add a component, and I'm going to add a box collider 2D so that our player can collide with this and not walk through our NPC, but also be able to check if it's an interactable object, which it will be once we add the script. So cool, let's add some sprites in for our NPC, so we're not just looking at a white box. I'm actually going to right click in our assets and create a new folder, which I'm going to call NPC, and I'm going to organize our NPCs out into their own folders here. So I'll create another one, and the first NPC I'm going to make is an old man. So cool, in our Ninja Adventure asset pack, I'm going to go inside actor, and in here, I'm going to select old man number 3. You can see we get this face set PNG of a little portrait of the old man as well. I'm going to drag that into our folder so we can use that on our dialog box. Then I'm going to go into separate animations, and I'm going to drag in his idle animation, since that's all we'll need for now. So cool, let's get the details for these set up. For this face set, the pixels per unit should match what the size of the image is. So if I show you, we can go back to this face set in the folder, right click and go properties. And if you go to details, you can see it's 38 by 38. So we can set our pixels per unit to be 38, set filter mode to be point no filter and compression to be none. These are all 16 by 16, so pixels per unit is going to be 16. Filter mode, point no filter, compression to be none. And then up the top, we want sprite mode to be multiple, as we have multiple sprites within this image. If we click apply, then go to the sprite editor, grid by cell size, 16 by 16, click slice, and then click apply. Now we can open this up, and we've got all our separate little sprites. So now I can click on my NPC, drag my old man sprite into our sprite renderer, and there he is. Lovely. Cool, now there's one more thing I'm going to want to create within each NPC folder. First of all, I'm going to go back to my assets, right click and go create C# script and call this NPC Dialogue. Let's double click on this to open it up. And what we're going to create here, instead of this being a mono behavior, is going to be our first scriptable object. A scriptable object is basically a class that you can create as a new object, which will hold different types of data for you. At the top, so we can create this in our assets when we right click, we can go create asset menu, brackets, file name equals, so when you create a new file, what pops up, I'm just going to type new NPC dialogue, then comma menu name, so I'm just going to call this NPC dialogue. Cool, we're not going to want this start or update, and instead we're going to want everything we're going to need for our NPC's dialogue system. So let's add in a public string for our NPC name, public sprite for the NPC portrait, public string array for our dialogue lines, public float for the typing speed, so how fast does our character speak. I'm going to set this to a default of 0.0f, a public audio clip for our voice sound, that's a weird name for it, and a public float for our voice pitch. I'm going to set this to a default of 1f, which is the normal pitch of an audio clip. Now there's two bonus ones I want to add in at the bottom, since I wanted to cover everything I could think of to do with NPCs and dialogue. And these are a public bool array for auto progress lines, which is going to match our dialogue lines. So will the next line auto progress and start without you having to press the interact button to skip to the next line? And then a public float for auto progress delay, which I'll set to a default of 1.5f. So after 1.5 seconds, if our line had finished typing, he'll start speaking the next line. You'll see some examples of this once we get the functionality in. But for now, that's all we need. We can go back to Unity, and back in our NPC folder inside Old Man, I'm going to right click and go create, and you can see at the top here we've got NPC Dialogue. So I'll select this, call this Old Man Dialogue, and now you can see in our inspector we've got all these slots for our data. So name, Old Man, Sprite, is our portrait, so that's the face set we passed in. Our dialogue lines, as they're an array, you can add as many as you want. You could go on talking forever, just keep pressing this plus. I'll do 2 just for now, and you can type in here whatever you want. I'm now going to skip down to this auto progress lines. In fact, I don't like this being separate from the dialogue lines, so I'm going to go back to our script, cut these out and stick them underneath the dialogue lines, just so our 2 arrays are right next to each other. There, that's updated back in Unity. So now if I add 2 elements on here, these would then sync up with these lines. So let's say I want the first line to auto progress. So he'll say, "Hello there, young man." And then the second line, which is his final line, I'll make it so the player has to interact to close this dialog box, so it doesn't close on its own. Cool, I'll leave the rest of these as they are, but for voice sound, we're going to need an audio clip. So I've taken a look through the Ninja Venture asset pack inside sounds. Inside game, there is 4 different options for voices, but I didn't really like the sound of any of them. But you can check them out, of course, and decide what you want for yours. Instead, I went inside menu and I used menu number 4. I'm not going to keep this sound inside our old man folder because we might want to use it for other NPCs. So I'm just going to move it into sounds and then drag it from sounds into our voice sound slot. Cool, so now we've got all our data set up for our old man to get talking. Now we need to make him talk by writing the NPC script. So let's click on our NPC game object in our hierarchy, click add component, new script, and I'll call this NPC. Let's double click on this to open it up, and we're not going to need this start and update, but we are going to want some references to our UI for our dialog box, and of course a public NPC dialog for our dialog data, which will be the data we just created. For the UI, we'll want a public game object for our dialog panel, a public TMP underscore text, hover over and add using TMP Pro, which is Text Mesh Pro, for our dialog text. And if you do comma, because we're also going to want our name text to pass in the name of our NPC. And finally, we'll also want our public image, hover over and using unityengine.ui for our portrait image. Cool, so that's all our public variables. We're also going to want a private int for our dialog index, just to know what line of our dialog we're on. And we'll want a private bool for is typing, and then comma, we want to know is our dialog active. Cool, so that's all our variables. Now hopefully you followed our previous tutorial and added in interactables in an interaction system to your game. If not, of course you can do this however you like, or you can go back and follow that tutorial, as I'm about to set up how we interact with our NPC by after mono behavior going interactable. And of course this is red because if you hover over, we're not implementing our interact and can interact. So if we go over and go implement interface, we can set up can interact here to say return exclamation mark to say not is dialog active. So if our dialog box isn't active, we can interact with our NPC. Cool, now inside interact, we'll say if our dialog data equals null, so say we have no dialog data, or brackets, if our pause controller, we added a pause system in our game, so if our game is paused and not is dialogue active, so if our game is paused and our dialogue is not active, then I'm going to want to return, say our menu's open and you're trying to talk to an NPC. We don't want the dialog box to pop up over the top of our menu. Cool, so next we want to check if our dialog is active, and we press that interact button. We'll want to go next line in our text, else if the dialog isn't currently active and we press that interact button next to an NPC, we're going to start the dialog. Cool, so let's first write the start dialog by going void start dialog, and in here we'll go is dialog active equals true. Dialog index will set to be 0. Our name text, we can go dot set text, and in the brackets pass in our dialog data dot name. So this will be old man like we typed into our scriptable object. Then we'll set up our portrait image dot sprite to equal our dialog data dot NPC portrait. We'll set our dialog panel to set active true, and we'll call our pause controller set pause to be true. So we pause our game. This will make it so our player can't walk around and leave our NPC behind as they're talking. That would be very rude. And then of course I want to start typing out the text from our dialogue lines. So I'm going to add a comment where I'm going to type the line of our dialogue, and now we can write the function for that. So as this is typing out over time, we're actually going to use a coroutine. So for a coroutine, we're going to want an enumerator, which I'll call type line. And here we'll set is typing to be true. We'll set our dialog text dot set text to be empty, just so we clean that out. And then for the typing effect, we're going to go for each char letter in dialog data dot dialog lines and pass in our dialog index. We set this to be 0 at the top as we started talking, so this will be the first line. Then inside this for each we'll go dialog text dot text plus equals letter. So we're going to go around every single letter in our dialog lines. This will include any punctuation like spaces or full stops. And as it goes around, it'll add this letter to the text. Of course, if we left it like this, for each would run so fast that it'll just type out the whole line. So we're going to go yield, return new, wait for seconds, and pass in dialog data dot typing speed, so that after every letter it takes a pause, which is going to be quite short. Our default is 0.05, then types out the next letter. Once this for each is finished, we're going to go is typing equals false, so we know that the line is complete. And then if you remember, I added in that auto progression. So this is where the auto progression goes, where we say if dialog data dot auto progress lines dot length is greater than the dialog index, so we're not going to try and grab a value that doesn't exist, and our dialog data dot auto progress lines square brackets dialog index. So have we ticked this index to say we want it to auto progress? If we have, we're going to yield return new wait for seconds, and we'll pass in our dialog data dot auto progress delay. So we're going to wait however long we've passed in. I think by default it's 1.5, so it's going to wait 1.5 seconds before it auto progresses, and then it'll display the next line, which is the function we're also going to want up in our interact. So cool, we'll get a double whammy there. But in start dialog, we can now call this type line by going start coroutine, passing in type line, brackets, semicolon. So cool, that's our start dialog done. Let's call this up in our interact, start dialog, brackets. Next we can do our next line function. So I'm going to go below start dialog and I'll call this void next line, and we'll say if is typing, and we've called to get the next line. We're going to stop all coroutines, so we want to stop this from skipping around this for each and auto progressing, anything like that. I'm going to go dialog text dot set text to be dialog data dot dialog lines and pass in the dialog index. So instead of typing letter by letter, this is going to autocomplete that full line into our text box, and we'll set is typing to equal false, else if our dialog index plus 1 is still less than our dialog data dot dialog lines dot length. And a better way of doing this dialog index plus 1 would be going plus plus dialog index. So if we add 1 to the index, do we have another dialog line to go to? If yes, we'll start our coroutine, which will start typing out the next line in our dialog data line. Cool, and then finally, if there are no more lines, or we're not currently typing to autocomplete, and we're either set to auto progress, we're calling this next line, but there's no lines to go to, we want to end the dialog, which is another function we'll write. But that's all we'll need for next line. So we can take this, stick it up in our interact, next line, and also down in our type line. So if we want to auto progress, this will automatically call next line for us. Cool. Now, like I said, we want a final function to end the dialog. So at the bottom, we're actually going to make this a public void end dialog, and we're making this public so I can attach this also to a button in our game, which will be a little close button, so you can click with your mouse on the UI, just so you have lots more options for your game. In here we're going to want to stop all our coroutines, so stop typing. We'll set is dialog active to be false. We'll set our dialog text to be an empty string, our dialog panel dot set active to be false, and our pause controller dot set pause to be false, so our game is no longer paused. Cool, very easy. That's all we need to end the dialog. Let's copy this, scroll back up to next line, and paste it in this else. So when we run out of dialogue to show, we'll end the dialogue. And that's our complete script. Very cool. So let's go back to Unity, and if we click on our NPC, we can see we have a slot for our dialog data. So let's go to our old man, and we've got this scriptable object here with all the data on it. You can drag this scriptable object into your dialog data slot. So that's all good and set up. Next, we're going to need all the UI for our dialog box to pop up at the bottom. So I've got my UI object in my hierarchy. I'm going to open this up and right click on UI, call this the dialog panel, which will hold all our other objects. I'm going to open up that rect transform. I'm going to click on this box on the side that says stretch and anchor this to the bottom middle. So that's this one at the bottom here. Then I'm going to set the Y position to be 200, the width to be 800, and the height to be 200. I'm also going to set the background of our image to be black and the transparency, so this alpha, the A, to be something like 175, maybe even 200. Let's make it darker. Cool, so that's our panel. Let's now right click and go UI image, and I'll call this our dialogue portrait. I'm going to position this to be minus 310, so it's just off to the side here. The width to be 128 and the height to be 128. Cool, this sprite is going to be set as we pass in different ones for different NPCs, so we don't have to worry about changing the sprite. In the dialog panel, I'm going to right click, go UI. Next, I'll do the NPC name text. Obviously you can position these wherever you want, but for me I'm going to go minus 125. Keep the width and height the same. I'll just change this to be NPC name. Change the font size down to be about 20. Oh, and sorry, back up the top. The position for the Y I'm going to set to 40. So it's just at the top in line with our image. Next we'll right click on the panel, go UI, text again, and I'll go dialogue text. This is the main text for all our dialogue lines. I'm going to position this on the X 75 and on the Y minus 25. And for the width, we want this to be wider, so I'm going to set it to 600 by 100 on the height. If you double click on your UI, you can see this in the scene view. So you can see how this fits nicely inside our dialog box. Add some default text. And for the font size, I'm going to set this to be 24. So cool. And finally, what I'm going to add is a UI button, which I'm going to call close button. So we can click to end our dialogue. For the X, I'm going to set this to be 350 and the Y to be 60. The width and height, I'm going to set to be 40 by 40. And if you open up this close button, I'm going to change this text from button to just be an X. I'm going to set the font to be bold, and I'm going to set the font size to be something bigger, like 36. So cool, we've got a cool little close button there. To set up this close button, it's very easy. If you select close button in the hierarchy, scroll on down, we've got this on click. If you press the plus, drag in your NPC, and then that no function drop down, if you click on here, hover over NPC, we can call end dialogue, which will close down our dialog box for us. So cool, that's all our UI set up. Let's click on our NPC for dialog panel. Let's drag in dialog panel, dialog text, name text, dialog portrait, portrait image. Very cool. Of course, we don't want this dialog panel to be open when we start our game. So if you click on dialog panel and just untick it in the inspector, this will be deactivated by default, same as our menu. And now with that all set up, we can finally do a test. So here's our froggy with his little footsteps going. Let's walk up to our NPC. You can see we get this interaction icon appear above our head, so we know it's an interactable. His dialogue appears and types out on its own. Oh, and I didn't press a button, it auto-progressed, great. Now when he's finished typing, it shouldn't auto-progress on this last one as we didn't tick that final line. Very cool. You can see here I've messed up. It says old man dialogue. I think I set this to be the wrong text. So back in our script, when we start our dialogue, we do name text, set text to dialogue data name. That is the name of our dialogue data, not our NPC name. Silly me, I was going too fast. We can test this again now. As we walk up to our NPC, let me auto-complete that line. Yeah, I haven't got time for you. Haha, it works. We also see his name is Old Man. If I press the close button, it closes on down. Very cool. We can talk to him again, and there it goes. Great. Now, you may remember we added in that sound for him to be able to make a sound as he talks. We haven't got that activated yet, so let's go look at our sound effect manager. Inside our game controller object, we have a sound effect manager. You can complete the previous video, so you have this inside your game as well, but we're also going to add to this to add on our NPC's voice. We currently have two audio sources on our sound effect manager, one for randomized pitches and one for playing normal pitch one-shot sound effects. To be safe, in case we have other sound effects playing in the background, I'm going to add another audio source, which is going to be just for our NPC's voices. So to set that up in our sound effect manager, you can see we've got our audio source and then our random pitch audio source. Let's duplicate this line by pressing Ctrl D, and I'll call this our voice audio source. Next, anywhere we've got this random pitch audio source, we can duplicate this line, replace it with voice audio source, and then for audio sources, we'll want to do audio source 2. So we select the third one in that list. Cool, let's scroll down. Now we've got a play function that calls from our sound effect library, but we've got our sound clip inside our scriptable object. So we're going to write a new function specifically for playing our voices. Let's make sure we add down the bottom our voice audio source dot volume to equal volume in our set volume function so that we can edit the volume of voices too. And then underneath play, don't worry, this is very short. We're going to add a new public static void play voice, where we're going to pass in an audio clip from our scriptable object, which I'll call audio clip, and also a float, pitch, which I'll set to equal a default of 1F. We also had a voice pitch inside our dataset, so you can edit NPCs' voices all within that scriptable object. So to do this, we're just going to go voice audio source dot pitch equals pitch, and then voice audio source dot play one shot, and pass in our audio clip. Cool, so that's all we need to be able to get our voice playing. Very easy. Now let's find somewhere we can call this inside our NPC script. Cool, so we want this to mimic our NPC talking. So if we scroll on down to type line, of course we type out each individual letter. So as we type out each letter, we can play our audio clip. So it'll be like, you know. So after each letter is added, we'll go sound effect manager dot play voice and pass in dialogue data dot voice sound and then dialogue data dot voice pitch. And guess what? That's all you need. So cool. Let's go back to Unity and press play to test this out. Let's walk up to our NPC. Oh, it's quite loud. Cool, he's yapping right at me. So cool, let's test this out again. I'm going to press the interact button this time to cut him off and skip the typing out and see how that sounds. Cool, sounds great. Of course, in our settings, we can use our slider for our sound effects and make them quieter. That's better. He ain't shouting at me anymore. So as an example, I'm going to create one more NPC by selecting up NPC in the hierarchy and holding down Control D to duplicate it. And I'll rename this to be NPC underscore girl, because I'm going to add a girl to our game. So I'm going to create a new folder, of course, call it girl, grab her icon and her idle animations, set these up, and I'll start speeding this up now so you don't have to watch everything slowly. But I'm basically doing everything we just did so you don't have to see it again. Cool, so I'm creating the new scriptable object for her. I'm going to set all of these to auto progress because she's going to be in a rush, and the auto progress delay to be something short, as well as the typing speed. We'll make it all very speedy. I'm bringing in menu 2 for her voice. Also now all I have to do is drag my girl dialogue into this data set, press play, and when I walk up to her, she's very fast at talking, everything auto progresses, and that was very easy to do. As you can see, she's very much in a rush and she's like, oh, I gotta go, but she's just standing still. Well, in our next video, I'm gonna get our NPC walking around. Our NPCs will be able to walk between waypoints, or wherever you want. I don't know, they can walk all over the place. Be sure to like and subscribe so you don't miss that. Otherwise, as always, be sure to check out our Patreon where you can grab every single piece of code I've ever written on this channel. For only $7 a month, it's a steal. Or you can grab this whole project, the whole game template, where you'll get all our finished features and also access to all our future updates for free. But if not, thank you very much for watching. Like and subscribe. And I'll see you in the next one. Bye! By the end of this video, we're going to have our NPCs running around our game all on their own, with customizable different wait times and movement speeds, and looping movement between waypoints which we can set up. When we talk to our NPCs, they'll stand still so we can have a chat until we're done speaking with them, and they'll continue moving. In the next video, we'll get them animated, don't worry, but we're going to do it in a cool and fancy way, which I'll talk about later. But cool, let's check it out. Let's start with our girl NPC. We'll set up some waypoints so we can control where she moves. If we right click in the hierarchy and create an empty game object, I'm going to call this Waypoint Parent, which we'll use to store all the waypoints inside of it. So we'll right click again, create empty, and I'll call this Waypoint. In the inspector, there's this gray cube that if you select it, you can select an icon so it appears in your scene. This won't appear in your game view. It's just a nice way to visualize where your waypoints are. So you can move this waypoint around using the move tool and clicking this blue square. So you can position this where you want your NPC to walk to, and then click on this waypoint and hold down Control D to duplicate this and move the other waypoint to the other position that you want your NPC to walk between. Now we can make as many as we want, so we could have them running around this pillar in a square by creating 4 of these waypoints, like so. Now on our NPC girl object, I'm going to select this and add a new component of a new script, which I'll call Waypoint Mover, as in we're going to move between these waypoints. You'll be able to add this to any object in your game, so you could use this in future for enemies walking around, or even animating inanimate objects. Whatever you want to be able to move in your game. We can double click on this to open it up, and at the top of our script we're going to want some public variables, so let's go public, transform, Waypoint Parent, which we'll drag in to then grab all the waypoints that are children of this parent, so we don't have to drag in each waypoint individually. A public float for move speed, which I'll set to a default of 2F, so that's how fast our NPC will walk. A public float for wait time, so once they've reached a waypoint, how long do they stand still for? I'll set this again to 2F. And a public bool for loop waypoints, which are set to default to true, just in case you want a character to walk to a waypoint and then stay there, but most of the time we'll probably want this looping. Now we'll want some private variables, so private transform array, so square brackets, for our waypoints, a private int for our current waypoint index, and a private bool for is waiting. So in our start for our waypoints array, we can go waypoints equals new transform square brackets to make it an array and pass in waypoint parent dot child count so that our array size is the same as how many waypoints we have. And then we can say for int I equals 0 semicolon I is less than waypoint parent dot child count semicolon I plus plus. And within here we can say waypoints square brackets I equals waypoint parent dot child. So this will grab all the transforms of the waypoints inside our waypoint parent. Now inside our update, we're going to want to say if our pause controller dot is game paused or our NPC is waiting, then we're going to want to return, as we don't want to make our NPC move if our game is paused or if they're currently waiting, so they just want to be standing still. So if we don't return out of here, we're going to want to move to our waypoint. So let's write a new function by going void move to waypoint, and in here we'll store a new transform for our target, so the place we want to move to, and we'll set this to equal our waypoints and pass in our current waypoint index. So this gets the waypoint we want to walk to. Now to move towards this, we simply have to go transform dot position equals vector2 dot move towards and pass in our current position, so transform dot position, our target position, so target dot position, and then this max distance delta it's asking us to pass in is basically going to be how fast you want to move towards it. So we're going to go move speed times time dot delta time. Cool, and now we need to check if we're close to our waypoint, so we'll go if vector2 dot distance and pass in our transform dot position and our target dot position is less than 0.1 f, so we're close enough. Then we're going to want to start waiting at the waypoint before we start moving again. As this elapses over time, we're going to want a coroutine, so let's go I enumerator wait at waypoint. We'll set is waiting to equal true. We'll yield return new wait for seconds and pass in our wait time. So how long are we going to wait at our waypoint before we get moving again? And once we've done waiting, we're going to go current waypoint index equals loop waypoints. So we're going to check if we do want to loop through our waypoints. And to check this, we go question mark. So if this is true, we're going to go brackets current waypoint index +1 and then type a percentage sign and write waypoints dot length. If you've never seen this before, this is going to be very confusing, but basically we're incrementing our current waypoint index by 1, that's the easy bit. The percentage sign here applies the modulus operator. The purpose of the modulus operator is to ensure that once the current waypoint index reaches the last waypoint, so the waypoint's length -1, it will wrap around to the first waypoint, so the index being 0. Basically, it loops this round for us, and then we'll go colon to say else if we're not looping our waypoints. We'll go mathf.min and pass in current waypoint index +1, comma, waypoints.length -1. So as you can see, this mathf.min is going to return the smallest of these two values we've passed in, increments our current index by 1, but ensures it doesn't exceed the last waypoint index. I'll add some comments in just so it's a bit clearer. And finally, as we've finished waiting, we can set is waiting to equal false. So cool, we've got our wait at waypoint function. We can now call this up by going start coroutine, and I'll move to waypoint, pass in wait at waypoint, and semicolon it off. Now our move to waypoint is complete. We can copy this, stick it up in our update, and guess what? We're all done. Let's go back to Unity, and if we click on our NPC girl, we can see our waypoint mover script. We need our waypoint parent passed in, so we'll drag that on in. I'm going to set the wait time to something a bit lower, like 1, so she can move around a bit faster here. And to tidy up the hierarchy, just before we test this out, I'm going to create a new empty object. I'm going to call this NPC girl again, same as our other object, and drag in both our main NPC object and our waypoint parent, just so this tidies up our NPC objects. waypoints. So cool, let's press play and test this out. As you can see, she's not animating, but we can see her moving around her waypoints. Very cool. She's looping and continuing round and round and waiting for a second at each stop. I'm going to up our movement speed a bit more and set the wait time to be something even lower. And then also I'm going to get our old man moving just for fun to show how easy this is. Let's drag on our waypoint mover script, and we're going to need to create some waypoint parents for him as well. So I'll create a new empty object for him, NPC old man. Inside this, we'll add our waypoint parent and add a waypoint. I'll add an icon for him, and we can do a different color so we can see it clearer. And we'll get him walking between 2 points over here. Cool, let's drag his NPC object in as well, and then drag this waypoint parent onto his waypoint parent slot. Again, his move speed being quite slow and his wait time can stay at 2 there. Now when we press play, there's going to be a lot going on. We can see our girls running very fast around. Maybe that's too fast. And our old man is very gently walking side to side. Oh, and also if we talk to our NPCs, the NPC's movement is paused, so they don't keep running around in the background. And then when we press play, they'll keep moving. Very cool. Obviously this looks a bit weird because they're not animated, but don't worry, sneak peek, this is my test project, but I'm going to show you something cool by setting up sprite libraries and sprite resolvers, which when used will only need one animator setup and one set of animations that'll be used for all our different NPCs. It's very cool and very exciting, so subscribe so you don't miss out. I didn't want to overload you with too much information, so I split them into 2 videos. As always, you can grab all my scripts on my Patreon for just $7 a month. That's everything I've ever made, getting close to 100 videos now, very exciting. Or you can grab this whole template for yourself, including all finished features and also future features for free. I keep coming up with more and more ideas, so you're going to be getting more and more updates to this. Otherwise, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, we're going to get our NPCs animated, but this won't be any simple animation video, oh no! We're going to be using one animation controller and set of animations for our NPCs and our froggy player. Why do that, you ask? Because it's easier. And also, say you don't want to play as a frog anymore and you quite like the look of that princess girl, we can drag one simple asset into our sprite library slot, and now we're playing as a princess. Hello? That's so cool. Fully animated. I didn't have to do anything. Oh hey, that old man's looking kind of cool. Let's switch to him. Well, that was easy. That's so customizable. Get excited and let's check it out. So right now our player is animated. He has a walking animation and he idles in these different directions. But our NPCs are not animated. If I go to Window, Animation, then Animator, and click on our player, we can see he has an idle and walking animation set in this controller. Now we could copy and paste this out for each one of our NPCs and recreate these blend trees, which is very tedious and would take up a lot of our time. So I'm going to show you a cool way to reuse our player's blend tree. So we're going to use a sprite resolver component on our player and our NPCs, which as you can see pulls information from the sprite library asset set in the sprite library component. So inside my sprites folder, I'm going to create a new folder, which I'll call Sprite Library. And inside this folder, I'm going to go create 2D sprite library asset. I'll name our first one player, so we can first set up our player to see how this is done, and then be able to easily make some for our NPCs to reuse our animator. So if we click on open in sprite library editor, here we want to add categories. So we'll add a new one and call it idle, and another one, call it walk. From here, what I want to do is in idle, drag in our idling frog sprites, so I have those set up here, and for walk we'll drag in our walk sprites. Very easy. If we click save, our sprite library is now set up for our player. So if I click on my player now, I can add a component of a sprite library, drag in my player sprite library, and we can see these all appear. Then I'll add another component, which is a sprite resolver. And we can see these idle and walking sprites all set up inside here too. So now we want to set up our animations to use references to the sprite library. So let's go Window, Animation, Animation. I'm going to drag this down the bottom in our game view. And for each one of these, we're going to go through each animation and reset up our clips. But basically, instead of the sprite, you're going to want to delete this. Click Add Property, right click on Sprite Resolver, and click Add Properties. If we zoom out at the 1 minute mark, this automatically adds in some details for us. I just want to delete those. click back on this first frame. Now, as I have in my sprite resolver this first icon selected for idle down, he's facing downwards. If you clicked these other ones, it would change his sprite. So if I press play and test it, yep, he's facing down. Let's go to walk down so I can show you how to add multiple frames using this sprite resolver. So we're going to want to change our sprite resolver to be walk. And just before I delete these sprite frames, we'll take a look and see we place these every 15 milliseconds. So I'm going to recreate that. So now I'll press Ctrl A and delete these, click Add Property, right click on Sprite Resolver and click Add Properties. Delete this one, automatically put in at 1 second. And now we've got our first frame, which is fine, him facing downwards. For our second frame, I want to go to 15 milliseconds, click the record button, and then click on my next walking frame in my sprite resolver. Move to the next 15 seconds, so that will be 30, and click the next sprite in my sprite resolver. Go to 45, next sprite, and then at the 1 second mark, so 60, I'll go back to my first sprite again. So we've got a nice little loop. If I press play, you can see he's doing his walk and it's using this sprite resolver. So I can unclick this record button now. Now the next step will be going through all of these animations and setting them all up, which we will do. But to show you an example really quick, I'm going to go to our sprite libraries, right click and create a new 2D sprite library asset and make one for our old man. If I go in Open Sprite Editor, we'll do the same where we go idle and walk. Then in my old man sprites folder, for idle, I'll drag in idle, and for walk, I'll drag in my walk. Click save. Now if I go to my player and drag in my old man sprite library, you'll see this automatically changes all of our walk animations. So if I now press play on our walk down, our old man is magically walking, and this is automatically selecting the correct sprites for our old man's walk animation. It's magic, so easy. So all these animations you'll only have to set up once. So you can imagine in code, you want to switch back to your little froggy. You didn't want to be an old man anymore. You'd simply change the reference from your old man sprite library back to your player sprite library. And now all your animations change with it. So cool. Let's go through two more together. So I'll go idle left. We can delete these, add property, right click sprite resolver, add properties, zoom out so you get rid of that 1 second mark, press record, and select our frog facing left. Oh, I'm in the walk one. You don't want that. You want to be in idle and then select your froggy facing left. You can press play to test this out. Cool, looks good. We'll go to walk left now. I'll delete these. They're all spaced out at 15 still. Add property, right click sprite resolver, add properties, delete the 1 second. Go to the beginning, press record and go walk left. Click the first sprite, walk left, next frame, 30 seconds, next frame, 45, next frame, and then at the 1 second mark, I go back to the first frame. Test that out. He's walking great. Again, if I switch this to be the old man one, we can see he's walking to the left. Oh, it's magic. Isn't that fun? Cool. Now, movie magic. I'll speed this up. This one animating bit is tedious, but you'll only have to do it once now. So much better than before, right? Cool, now that's all done. Let's press play. I can test my walking still works. Yep, he's looking good. His idles are all the right way around. And just for fun, let's change to an old man. Whoa, that's a fast old man. Look at him go. But cool, that's not what we came here for. We came here to animate our NPCs. So let's put our player back. And since we've got him set up, let's do our old man first. So NPC old man, open this up and get to our NPC object. In here we want our sprite library and our sprite resolver. We'll drag in old man. This is all set up. And then we want an animator. So all we need to do is fill in this animator controller. Inside my animation folder, I've got my player controller, which we're going to be reusing. In future, if you have specific animations for just NPCs or just your player, you could simply copy and paste this controller and create one specific for your NPCs. Right now, for the sake of the tutorial, all we've got is walking and idling, but in future, I may split them out. Cool, and now of course, this wouldn't be a Unity tutorial without some coding, so we need to still set our booleans when our NPC is moving inside our animator, so that the animations actually update. So let's open up our Waypoint mover script by double-clicking on this. And at the top here, we're going to want a private animator, which I'll just call animator, so that in our start, we can go animator equals get component animator and have a reference to this off of our NPC. So of course, in our update, when our game is paused or we are waiting, we're going to want to set our animator dot set bool. and pass in is walking to be false, since we know our NPC won't be moving at this point. And down in our move to waypoint, to be able to set what direction we're moving in, we're going to need to store a vector2 direction, which will equal brackets target dot position, take away our transform dot position, and then outside the brackets type dot normalized. So we know this is the direction we're moving in, and with that direction we can go animator dot set float, pass in input x, comma, direction dot x, and then we can duplicate this line by pressing Ctrl D and change this to be input y, direction dot y. Then we're also going to want to go animator dot set ball and set our is walking again, but this time to be our direction dot magnitude greater than 0f. Cool, and then one more place down in our wait at waypoint. Underneath is waiting to be true. When we're waiting, we're not going to be walking, so we can set is walking to false. So cool, let's test this out. Back in Unity, if we press play, we can now see our old man walking left and right. When he idles, he faces the front. And in fact, this will always be the case because we haven't inputted our last input X and Y. Now I've done this on purpose in case when your NPC stops, you do want them to face the front. Otherwise, he'll default to facing to whichever way he was last facing. So he'll stand still and face right or left. I kind of like the look in a 2D game when they stop and they face the front automatically. So you can leave your script like this, or at the top of our waypoint mover, we're going to want two new variables, a private float for last input X, and duplicate this as we're also going to want a last input Y. Then down in our move to waypoint, before we call move towards, we can say if direction dot magnitude greater than 0f, our last input X equals our direction dot X, and our last input Y equals our direction dot Y. Then when we're down waiting in our waypoint, so when our NPC is idling, before we yield, we'll want to go animator dot set float last input X to be last input X, and animator set float last input Y is last input Y. Cool, and of course we also set is walking to false up when our game is paused. So let's copy and paste these two lines from below up to under the set ball walking false. Very nice. Let's go back to Unity. We'll get rid of those error messages and add our NPC girls animator too in a second. But first let's press play, and now we can see as our old man walks, he stays facing the direction he was last facing. And when we talk to him, he pauses and faces the right way too. Cool, now let's get our girl animated as well. So inside my sprites folder, inside Sprite Library, I'll right click, create 2D Sprite Library asset. I'll call this girl. Open my Sprite Library editor, idle, and walk. Click on idle, drag in idle. Now I don't have our walking sprites yet, so in Ninja Adventure Asset Pack, I'll go into the Princess folder, separate animations, drag in walk, then in Unity, sprite mode to be multiple, pixels per unit to be 16, filter mode to be point no filter, and compression to be none. I'll click apply, sprite editor, slice, grid by cell size, 16 by 16, slice, apply. Cool, very quickly set up. And now in walk, I can drag in walk and click save. I'll go to my NPC girl game object. I'll add our animator and then our sprite library and our sprite resolver. Open our sprite library and drag in our girl. Then go to animation folder and drag in player into the controller. And beep bop boom, we'll get her moving. There she goes. Oh, look at her run. Beautiful. Let's try and catch her to talk to her. There she goes. She's in a rush. See ya. And she starts walking again. Very cool. We're all animated. As with any other NPC, of course. If you thought, I want to change how they look, let's make them a frog, and our old man too. Let's make them all frogs. Why not? I'll drag in our player. When we press play, we've got frogs everywhere. That's a bit silly. Okay, let's stop being silly. What's happening in the next episode? Well, these NPCs, they just keep talking to us, and we're just standing here silently. We're not saying anything back. In fact, they're not even giving us a chance to. How about some dialogue options, huh? In the next episode, we'll be adding dialogue options. So instead of being a silent little froggy, we'll start croaking some responses back. But cool, I hope you enjoyed the video. As always, I'm going to remind you about our Patreon, which is only $7 a month. Helps support me a lot. Is very cheap for what I give, which is access to every single code file I've ever written. Or to skip all the hassle of putting those scripts together, you can grab this whole project, which will include all finished features and also all future updates. So grab it while it's on sale. Otherwise, thank you very much for watching, and I'll see you in the next one. Bye! By the end of this video, when we talk to our NPCs, hello there young man, they'll be able to ask us questions. Can you help? But not only that, we'll be able to answer. Yes, I can help you, old man. Thanks. I knew you'd help. Oh, what a nice guy. Let's try talking to this girl. Hi, do you need something? No. Are you sure? I don't know. Well, I'm too busy. Bye. Kind of rude, push me out of the way as well. Let's get talking to our NPCs and adding dialogue options. So right now, the UI for our dialogue panel, being our text and dialogue portrait and NPC names that we pass in, are all held on our NPC's script. You see, we have to pass in the UI on each one of our NPCs. So every time we made one, we'd have to pass in these details. That's a bit silly, so we're going to tidy that up. I have this game controller object, which holds all our miscellaneous controllers used across our game. So on here, I'm going to right click and go create empty. I'm going to name this dialogue controller. I'm going to click add component and add a new script, which I'll also call dialogue controller. Double click on this to open it up. Now, if we go to our NPC script, we can see at the top, we've got all these UI variables. If we cut them out by pressing Ctrl X of this NPC script, then go back to our dialogue controller, we can paste these on at the top. Hover over and import using Text Mesh Pro, and also for our image, hover over and we're going to want Unity Engine UI. Cool, and above this, so we can call this dialogue controller from any script, we're going to want a public static dialogue controller instance, and go curly braces, get semicolon private set. This is called a singleton instance. To set this up in our start, we'll say if instance is equal to null, then instance equals this, else destroy brackets game object. So this makes sure there's only one instance of this dialogue controller, since we only want one in our game. And instead of start, I'm actually going to switch this to be in awake, so this happens as soon as our game starts. Cool, so we're not going to want this update function, but we're going to want to quickly write some functions that lets us set up this UI from our script. So a public void show dialogue UI, and we'll pass in a bool called show. And this will simply set our dialogue panel set active to be show, so either true or false. So we can toggle between the UI's visibility. We'll want a public void set NPC info, and we'll pass in a string of the NPC name and a sprite for the portrait. Then we'll set name text.text to equal our NPC name, and we'll set portrait image.sprite to equal portrait. Cool, and finally for now, we'll do a public void set dialogue text, pass in our text, and we'll set dialogue text.text to equal text. Cool, so now if we go to our NPC script, you can see we've got all these red underlines where we've moved our UI out. At the top, we can add a private dialogue controller, which I'll call dialogue UI, and then add a start function where we go dialogue UI equals dialogue controller.instance. Now let's go down our script and replace all our red underlines to use the new functionality. So the name text and the portrait image, we've got our dialogue UI.set NPC info, where we'll pass in this dialogue data.npc name. And you can copy and paste this from above. I'm copying where the portrait is, so dialogue data NPC portrait. Now we can remove those lines and we've got our new function. Then dialogue UI.show dialogue UI, and we'll pass in true. So we can remove this dialogue panel set active true. Cool, that looks much tidier. Let's keep going down. We've got our dialogue text being set. So let's go dialogue UI dot set dialogue text and pass in the variable text from above. Remove this line. Scroll on down. We again want this dialogue UI set dialogue text. So I'm just going to replace this here with our dialogue UI set dialogue text. We want to clear that out. To do this one, we're going to go dialogue UI set dialogue text, and inside here, we're actually going to want to call the dialogue UI dot dialogue text, since that's a public variable in there, dot text, and plus equals on that letter. Cool, that matches up. In one more spot, we're again going to want this set dialogue text, where we'll set it to empty again, and then we'll want dialogue UI, show dialogue UI to be false. Okay, very cool. Let's go to Unity. And now you can see we've got our slots for our dialogue UI that we'll only have to drag in once. So let's drag in the dialogue panel, the dialogue text, the name text, and the portrait. Cool, now if we check our NPCs, the only thing we have to pass in is our dialogue data. Cool, now it's all tidy. We can start adding our dialogue choices. So speaking of this dialogue data, let's first add some new data into this scriptable object. So inside our scripts, go NPC Dialogue, double click on this, and outside of this class, I'm going to add a new square brackets system.serializable and make a public class called dialogue choice. And we'll want a public int for our dialogue index. And this index points to the index of our dialogue lines where we're asking a question or where choices should appear. Then we'll want a public string array, so square brackets, of choices, which is our player's response options, and a public int array for our next dialogue indexes. So after the player has chosen a response, which dialogue line do we display next? Then up in our NPC dialogue, we're going to want a public dialogue choice array, which we'll call choices. Cool, so to get an idea of how this sets up, let's go back to Unity. We'll go to our old man folder and select our old man dialogue scriptable object. We can now see we've got all our original dialogue here, but we've also got our new choices section. So if we add a new one of these and open it up, I'll show you how to set this up. So let's edit one of his dialogue lines to be a question. So in element 1, I'll just get him to say, "Can you help?" So we're going to want some options to appear for our player to respond to this "can you help?" So our dialogue index here needs to match the element in this dialogue lines. So that's number 1 as its element 1. We can now add some choices. So let's keep it simple and add 1 for yes and 1 for no. And now for this next dialogue indexes, we're going to want to point at some new dialogue lines. So when I say yes, what does the old man say? And when I say no, what does he say? So let's add another element here. For when we say yes, he can say, "Thanks." And if we say no, you can say, "Oh, okay." So we're going to want to point to element number 2 when we say yes. So next dialogue indexes, element 0 will match up with element 0 here. So when we say yes, we're going to want to point to number 2, and we'll add another one for no. When we say no, we want to point to element number 3. Very cool, very easy. Now if we left it at that, it would look something like this, where our old man will say, "Can you help?" And we'll say yes, and he'll say thanks. But then if we continue, he also says, "Oh, okay," which was our reply from saying no. We don't want to see both answers. After we've responded here and said yes, and he goes to thanks, we don't want it to then continue to our next line in our dialogue, which is how our script currently flows. Once we've said yes to his question, we want it to go to thanks, but right now how our script works, it automatically runs to the next line as well. To keep this simple, all I want it to do is end after he's replied to our response. To do this, I'm going to go back to our dialogue script in NPC Dialogue. And as we've got these auto progress lines, to say when we want a line to automatically go to the next, I'm going to duplicate this with Control D and call this end dialogue lines. With this array, we'll be able to mark where our dialogue is meant to end. So if we go back to Unity and take a look, we can see we have this end dialogue lines. We're going to want 4 elements, 1, 2, 3, 4, to match our dialogue lines. And we want it to end after thanks. And we also want it to end on, "Oh, okay," which it would automatically do since it is the last one in our dialogue lines. But I'll tick it anyway, just for clarity. And in case we add another line afterwards, we don't want to forget that this would be an end to our conversation. If you didn't want the conversation to end here, so you want him to say thanks and then something else, you could say, "Thanks, I knew you'd help." Make sure this is within the same line so we don't have "oh, okay" interrupting. We then add another element on for our "oh, okay." Untick thanks, so this is no longer an end in dialogue, and then tick element 3, so he'd say, "I knew you'd help," and we wouldn't go into this "oh, okay." Then let's say we want him to say something after "oh, okay." So he says, "Maybe next time." We add another element in end dialogue lines, untick "oh, okay." So now if we say yes, he says, "Thanks, I knew you'd help," and then it would end. Or he says, "Oh, okay, maybe next time." And we'll stop that for now because there's a lot of customizable options, but hopefully you can see what I mean on how to use this end dialogue lines. But cool, let's get to the meat of adding our choices in. So of course we're going to need some UI for our choices. So in our dialogue panel, I'm going to right click and go UI panel, as we're going to add a new panel here called choices panel. Cool, I'm just going to click and center this to the middle so we can edit this position. I'm going to set its width to be 200, its height to be 120, and its position to be 360 on the X and -75 on the Y, so that it sits just below our close button here. In fact, it can go a bit higher, -50. I'll scroll down and click add component. We'll want to add a vertical layout group, and I'm going to untick child force expand and set child alignment to upper center. Cool, we're using this vertical layout group. Now when we right click on choice panel, go UI and add a button, which will represent our choice button. So let's call this choice button. If we add multiple choices in here, they'll all stack vertically. We're going to be writing the script so that our choice buttons are prefabs and will be dynamically loaded in. So maybe you'll only have one option come up, that's fine. Maybe you'll have 4 choices, these will all appear. So it'll be completely modular. The top of our choice button, I'm going to set the width to be 200 so it matches this width, and the height to be a bit bigger, so 60. Just to stylize it, I'm going to set the color to black, open our choices button and go to our text and set the color to be white, and I'll leave everything the same. Of course, you can customize this how you like. Cool, now when we add more buttons, this will expand. It looks like we can fit about 3 on here. Of course, you can make your buttons smaller. And for our choices panel, I don't actually want a background for this. I just want the buttons to appear. So I'm going to set the alpha on our choices panel to be 0. And now we just have our little buttons appear. Cool, so like I said, we want our buttons to be prefab, so I'm going to go to our prefab folder and drag our choice button into here. Then we can delete this from our hierarchy, as we'll be adding these in our script. Now, of course, since this is UI, it's going to go in our dialogue controller script, which handles all our dialogue's UI. So let's go back to our dialogue controller, and at the top, we're going to want a public transform for our choice container, which is that panel, and a public game object for our choice button. Scroll down, and at the bottom we can write a function for a public void clear choices, as we're going to want to be able to clear out those buttons, where we can say for each brackets transform child in choice container, so any children within our choice panel, we're going to destroy the child.game object. So that'll destroy all our buttons for us. And we only need one more function, which will be a public game object called create choice button. We're going to pass in the choice text, and we're also going to pass in a Unity engine .events.unity action, so we can tell it what to be in the on click. As in our NPC script, we're going to decide which is the next index to move to, but that's where we'll handle the logic of what goes in our on click. So let's create a new game object for our choice button. And of course, we've named the one at the top choice button, so let's actually rename this to be choice button prefab, so we can clarify between those two. And then back down on our choice button, we'll go instantiate choice button prefab, comma, choice container. So we're creating a new version of our choice button prefab inside our choice panel. Then on our choice button, we're going to go get component in children, and in triangle brackets pass in TextMeshPro underscore text, so we can grab the dot text from our button and set this to equal our choice text. Then we'll want choice button dot get component and pass in button, then set our dot on click dot add listener and pass in our on click. And finally, we'll return this choice button. So cool, we'll set up our button and return it back from this function. Let's go back to Unity, and on our dialog controller, we need to add our choice container, which is our choices panel, and our choice button prefab. So go to our prefab folder and drag in our choice button. Very cool, UI all set up. Let's go on one of our NPCs and open up our NPC script. So in our script, when we interact, we start our dialogue if it's not currently active, and we call a coroutine called type line. Type out our dialogue line, then we call next line. We go to our next line function, and in this next line, we're going to set up some bits for our choices. So let's take a look. We're typing out our line, and here's where we skip our typing animation and show the full line. Under here, there's a few new things we want to do. First, we're going to clear out any existing choices. We're then going to check our new end dialogue lines to see if we want to end the dialogue here. If we don't want to end the dialogue there, we're going to want to check if we have any choices for this line, and if we do, we'll display them. So cool, to clear out our choices, we can use our dialogue UI.clearChoices, which we previously wrote, so it clears out any existing button. Oh, let's remove this else from this if else. Now let's check if we want to end our dialogue here. So we'll go if dialog data dot end dialog lines dot length is greater than dialog index, and our dialog data dot end dialog lines is the dialog index, so we just pass in our dialog index. So we're going to grab the boolean of the index that we've ticked. If it is ticked, we're going to call end dialog and then return. So we exit out of this function, if I can spell it right. Oh my god, return. Cool. That's all we need for our end dialog lines. Now let's check if we have any dialog choices by going for each dialog choice in dialog data.choices if dialog choice.dialog index equals our dialog index. We're going to want to display our choices, and then we'll return out. So we're going to write a new function for displaying our choices. If we scroll on down, I'll do this above end dialog and add a void display choices, and we'll pass in a dialog choice called choice. Now we'll go for int I equals 0. I is less than choice.choices and I++. Oh, we want choice.choices.length. Then inside here we'll go int next index equals choice.next dialog index and pass in I, so we know where this choice is going to lead. And then we use our dialog UI to go dot create choice button and pass in choice.choices square brackets I, comma, and now we need to pass in the onClick event. So we actually need to create a function for this onClick event, which makes it so when we click on this button, it'll display the correct line of the next index. So below this, let's go void choose option and pass in the int next index. We're going to set dialog index to equal next index. Dialog UI will clear the choices, and then I'm actually going to write a new function here called void display current line, where we stop all coroutines and then start a coroutine for our type line. Now I'll show you all the places this goes. Inside our choose option, we're going to call display current line. So this forces everything to stop running. So all text will stop typing and we'll go to the next line. Everywhere that we call this type line, I'm going to replace this with display current line so that we stop coroutines and then start coroutine. Otherwise, we can have errors where two coroutines are running at the same time. So you'll hear like typing sound effects and text will get all muddled up. So we'll keep it clean with this display current line. And also at the very top, we've got another where we start our dialogue. Maybe you open and close one really quick. We don't want that to break, so we'll use display current line. So we stop our coroutine and then start the new one. Cool, so this choose option is the function we want to be called when we press our button. So in this create choice button, we're going to go brackets equals greater than and paste in choose option brackets and pass in our next index. So this passes the function in for us. Cool, so now we have our display choices. Let's scroll back up, and inside where we're checking if our choices are ready to be displayed, we can call display choices. Inside of parameters, add in dialog choice. And very nice, and guess what? That's all we need. Let's go back to Unity, click on our dialog panel and close this back off. And if we go to our old man's dialog one more time, let's check what we want to see. So it has to go, hello there young man, can you help? Which is going to be a question. If we say yes, it's going to go to number 2 and it'll say thanks, I knew you'd help, and it'll end on number 3. Oh, we actually didn't change this. If we say no, we want it to go to element number 4 and say, oh, okay. So let's make sure that's changed. Good thing I came to check it again. And he'll say, oh, okay, maybe next time, and we'll end on number 5. We can add in our auto progress lines as well. I think I'll have them all manually moving. Our first one can auto progress, sure, we'll leave that as it is. But the others, I'll keep waiting. So cool, let's press play. If we walk up to our old man, we can press E. Can you help? Now I get our 2 options. So let's be kind, let's say yes. And he says thanks. Oh, I pressed E too fast. I knew you'd help is the second thing that he said. Okay, we say yes, and he says thanks. I knew you'd help. And then it closes on down. Perfect, it doesn't keep going. Let's try again. Can you help? We'll say no. Oh, okay. Maybe next time. Oh, very cool. Now for another example, let's go to our NPC girl. And as she's running around and in a rush, she says, hi, do you need something? So that's a question. Let's add a choice. That's element number 1. And we'll say yes or no. And if I say yes, you can say, well, I'm too busy. Bye. And that can be the end. So let's set up number 2 to be the end. We'll also have everything auto progressing, so she'll keep the conversation moving on her own. So yes will point to, well, I'm too busy, which is number 2. If we say no, I'm going to make it another question, and she'll say, are you sure? So that's number 4. So we say no, we point to number 4. That's another question, so I'm going to add another to our choices. Let me close this one down and open this up. So number 4, she's asking a question. Oh, actually, I'll put this on element 3. Are you sure? And no needs to go to 3. Okay, so she says, do you need something? And we say no. Number 3, are you sure? So we're on dialogue number 3. Let's go number 3, and here she asks a question. Our choices, we can keep it as yes or no, or actually let's say, are you sure? Yes, I'm sure. And then maybe we say, I don't know. Like, are you sure? I don't know. I don't know if I need something or not. And now for our next dialogue indexes. If I say, yes, I'm sure, we'll add another one and she'll say, okay, bye. Very friendly, that's number 4. Yes, I'm sure. Okay, bye. If we say, I don't know, maybe we'll go back and say, well, I'm too busy. Bye. So let's send it back to element 2. For ending the dialogue lines, we don't want it to end on are you sure? But we do want it to end on okay, bye. And we'll keep it ending on well, I'm too busy. Bye. And we'll keep them all auto-progressing again. Cool, now we've got 2 questions in one conversation. Take a look and see how this works. We'll go up to our girl. She says, hi, do you need something? I'll say, yes. Well, I'm too busy. Bye. And she runs off. I didn't even press a button. I'll talk to her again. Do you need something? No. Are you sure? Yes, I'm sure. Okay, bye. Or if I say, hi, do you need something? And I'll say, no. Are you sure? I don't know. Well, I'm too busy. Bye. Haha, a branching dialogue tree. Very simple and very easy. But of course, if we go up to our old man again, he says, can you help? And I say, yes, I can. Now if I talk to him again, he keeps saying, can you help? We need our NPCs to remember our answers. Let's hope I figure out how to do that in a nice and easy way, because that's going to be our next video. At some point, that old man's going to be giving us a quest. So we'll look at conditional dialogue options, along with beginning our quest system in the next video. So like and subscribe so you don't miss out. To skip all the effort, you can grab our whole template, this whole project, which includes all our finished features, as well as any future updates for free. Or to grab all the scripts I've ever written on this whole channel, you can join our Patreon, and you can help support the channel. So thank you to all current Patreons as well. Otherwise, I'll see you in the next one. Bye! By the end of this video, when we pick up more than one item, right now we've got 1 in our slot, we pick up another, they'll stack and we'll get a number displaying how many items are in our stack. We'll pick up a couple potions. Now we've got 5 in our inventory. You can drop 1 at a time, so there we've got 4 and we've dropped another on the ground. Pick it back up, we've got 5 again. You can right click on these and they'll split the stack, and of course right click again and keep splitting our items out. You'll also be able to restack these by dragging them on top of each other and swapping them with other items in their slots. So cool, let's get stacking and splitting our items. First, let's go to our prefabs folder where I have my item prefab. I'm going to double click on this prefab to open it up, which you can see in our hierarchy. We now have our item open where we can edit our prefab and right click on our item and add a UI text. I'm going to call this QTY text for quantity text. And we use this to display our stack's quantity. So if we double click on this quantity text, we can see this better. I'm going to want this anchored on the bottom right. I'll set its width and height to be 40, its position to be -20 on the X, and the Y position to be 13. Then if I scroll down, I'm going to set its alignment to be on the right. I'm going to make it bold. I'm going to set the font size to be something bigger, like 42. And I'm going to set the alignment here to middle. Actually move that up a bit to Y position 15 so it lines up at the bottom. Of course you can customize this whatever you want, but that'll do for now. Next, if we select our item and scroll down, and I'll collapse all these because we won't need them. But on here, what we do want to look at is this item script. So I'm going to double click on this item script to open it up. And in here, we can add some new bits for our quantity. So let's go public int quantity and set this to a default of 1. And then I'm also going to want a private tmp underscore text for our quantities text. Hover over this and do using tmp pro. Now let's write an awake function, private void awake, where we can get our quantity text and set it to equal get component in children and pass in tmp underscore text. So we can grab the text from our item. Next, I'm going to write a public void function called update quantity display, where we can set our quantity text dot text to equal. Now we'll use a ternary operator to say, is our quantity greater than 1? Question mark. If it is greater than 1, we'll set our quantity dot toString, then use a colon to say else, have an empty string. So when our item stack is not greater than 1, we won't display this 1 on our item. We'll just set our text to empty, so there's no stack number. So cool, when we awake, we can call this update quantity display to make sure this is set correctly. And now we can add 2 new functions. That's going to help with our stacking. So a public void add to stack, and our parameter will be an int amount. We'll set this to a default of 1, so if we pass in nothing, it'll just up by 1. Well, we'll simply go quantity plus equals, which adds to our existing quantity, and then we'll add on amount. Then once again we can call update quantity display. Then another function will want a public int, so we can pass back what was removed for remove from stack. And once again we'll set a default of int amount to 1 for our parameter. Then we'll go int removed equals mathf.min. So as you can see, this returns the smallest of our two values, where we'll pass in amount and quantity. We'll then set our quantity to minus equals removed, then once again update quantity display, and then return our removed. Now for when we split our items, we're going to want to clone our item with a new quantity amount. So I'm going to create a public game object clone item with the parameter of int new quantity, and in here we'll create a new game object which we'll call clone, where we'll instantiate this game object. We'll grab the item script from this clone item. We're going item clone item equals clone.getComponent item. Then we'll want our clone items dot quantity to equal the new quantity that we're going to be passing in. And on this clone item, we can call dot update quantity display, then return this clone. So when we split our item, we'll copy this game object, give it its new quantity, and then return it back for our script to use. You'll see how this is used later. But first of all, let's go back to Unity. And as we've added a new piece of data to our items, we're going to want to go to our inventory save data. So we'll double click on this and add in a new public int for our quantity, which will default to 1. So now if we've got stacked items, we'll be able to save this and also load it. Cool, that's all we need to add to the save data. Back to Unity. Let's exit out of our prefab now. And back in our hierarchy, on our game controller, we have our inventory controller. We're going to need to handle some of the item stacking in our inventory controller. So let's open this up. And as you can see, when we add an item right now, we look for an empty slot and place the item inside here. So when we pick up items, they look something like this. So before looking for an empty slot, I'm first going to get the item script. So I'll call item to add, and set this to equal our item prefab that we're trying to add, .getComponent item, and I'll say if our item to add is null, we're straight up just going to return false, as what we're trying to add to our inventory doesn't have an item script. Now if we do have an item, I'm going to copy this for each loop as it's going to be similar, and paste it above. But instead of looking for an empty slot, we're going to go around and check if we have this item type in our inventory. Everything will be the same with checking for a slot. However, we want to say if our slot's current item is not null, so we do have a current item. So change this double equals to be an exclamation mark and then an equals, which makes sure we do have an item in this slot. We'll remove this middle code here, as we instead want to say item slot item equals slot.currentItem.getComponent item. So we've got the item script out of our current item. Then we'll say if the slot item is not null, to make sure we have found a script, and double ampersand slot item.id is equal to the item to add.id. So are these of the same type? If they are the same item, we're going to stack them, which we'll do by going slot item add to stack. As this has been added to our inventory, we can then return true. If we haven't currently got this item type in our inventory, it would then go on to look for an empty slot. So we can keep all this code the same. Very cool. Let's see if there's anywhere else we need to amend. So down next, we've got our get inventory items. We use this for saving our data. You can see we pass in our item ID and our slot index, which matches up with our inventory save data. Now we've got our quantity as well. So of course, inside this inventory save data, after our slot transform get sibling index, we'll go comma, quantity equals item.quantity. And I'm going to press enter a few times to tidy this up so you can visualize this a bit better. There we are, that's a little neater. So now we can save our items quantity. And of course, if we're saving this, we're also going to need to load it, which we do down in the next function, set inventory items. So before we set our slot's current item to be this item, and after we've instantiated a new item prefab, I'm going to go item component equals item.getComponent item. I've said item too many times so far. And we'll say if item component is not null, just to make sure our prefab did have an item script, and our data.quantity is greater than 1. As this defaults to 1, we only want to do this if it's greater than 1. So we can go item component.quantity equals data quantity, and then call our item component dot update quantity display. Cool, and for our inventory controller, that's all we're going to need, but there'll be one more place in our scripts that we want to change. So let's go back to Unity. If we press play and have a look at how this works right now, we've got nothing in our inventory. If we walk and pick up one of our potions, you'll see one enters our slot. It hasn't got any numbers on it as we've only got one. If we pick up our second potion and check our inventory, we've now got 2. This stacks and drags around, and when we drop our item, we can't see that there's 2 here, but when we pick it up, we can see we get 2 back. If I go and grab an item from our chest, we get our potion here. If we pick these up, it now says 2. When we dropped 2 to begin with. So of course, dropping our items is currently broken, as we haven't added anything in our item drag handler. So let's go back to Unity. If we click on one of our item prefabs, we can see our item drag handler script. Let's open this up and have a look. So all these top functions are fine, but it's on our onDrag event. We're going to want to check for stacking items. So in this top section, we're just checking our slots and grabbing them to store and use in a second. Now it's in here that we're going to want to add our stacking items. So there is a slot under where we're dropping, and we're checking if this slot has a current item. If it does have a current item, currently we're just swapping the items around. But before we swap them, instead I'm going to get our item, dragged item, to equal get component item, to get the item script off of the item that we're dragging, and then we're also going to want item target item to equal our drop slot dot current item dot get component item. So then we can check if our dragged item dot id is the same as our target item dot id. Then we can go target item dot add to stack and pass in our dragged items dot quantity. Then the slot we've dragged this from, so original slot, we're going to set the current item to equal null here, as we've dragged this item to be stacked with this new item, and then we're going to destroy this game object. As it's been combined into this stack, we no longer need this prefab. Then we can say else, if these target IDs don't match, so they're different items, we can cut this swapping items code and paste it up in our else. So cool, that'll stack our same ID items. Let's scroll on down and see what else we've got. So when we've been dropping our items, it wasn't dropping correctly. So instead of dropping our items in one big chunky stack, I'm going to have it so we drop our items one by one from the stack so it decreases slowly. So first let's get the quantity of our item by going item equals get component item. So we can grab our script. We'll go int quantity equals item.quantity. And first let's find out if this is a stack of items. By going if quantity is greater than 1, then we'll go item.remove from stack, and this defaults to 1, so we don't have to pass anything in. So we've dragged and thrown one item out of our inventory. We're going to want to snap back the remaining stack. So we'll go transform.setParent and pass in original parent. We'll go get component rect transform.anchored position to equal vector2.0, which recenters our item back to the middle of that slot. And here we're going to set our quantity to equal 1, as we're only dropping one item. Before we go down, I'm going to stick emptying out our original slot current item to null into an else, as we only want to do this if our quantity is only 1. So now we're down to where we're instantiating our drop item. So for our drop item, we're going to want to make sure our item dropped item equals our drop item dot get component item has only dropped item dot quantity of 1. So we want to make sure our dropped item only drops 1 at a time, as when we were picking it up before, we were picking up 2 as it was copying from our game object. So that's our instantiating done. Now we only want to destroy this if our quantity is less than or equal to 1 and our original slot dot current item equals null, which we set this up when our quantity is only 1. So we've dropped the final item. That's when we can destroy our game object. Cool, so now our dropping and repicking up of items should all be good. Final bit we're going to add is our item splitting. To do this, at the very top, I'm going to add a new I pointer click handler, which will go red because if we hover over, we need to do show potential fixes and implement the interface of on pointer click. We can click on this, and if we go down the bottom, you'll see this gets added in for us. I'm going to make it so when I right click on a stack of items, our stack will split and half of the stack will be moved to the next empty inventory slot. So let's go if event data dot button equals pointer event data input button right. So we've right clicked. I'm going to call a function to split our stack. You can of course make this whatever you want to split your stack. And down below I'm going to go private void split stack, and we can go item equals get component item. We'll check if our item equals null, or, which is the double lines, don't know what they're called on the keyboard, or item quantity is less than or equal to 1, then we're going to return, as we don't want to split a stack of one item or of nothing. Next we'll go int split amount equals our item dot quantity divided by 2. We could check once again. If our split amount is less than or equal to 0, we want to return, but this should have been caught by our previous check. Then we'll go item dot remove from stack and pass in our split amount. So we remove half the stack from our original item. Then we'll go game object new item equals item dot clone item and pass in our split amount. Now we need to find the slot to stick our new item in. Now we're going to need our inventory controller to find our next empty slot. Now every time we split an item, we could find our inventory controller object like this, but that'll mean every time we split a stack, we're going to do this find, which isn't very good for optimization. So instead, I'm going to go to our inventory controller script and I'm going to add a public static inventory controller called instance, which will go curly braces get private set, call an awake function, and follow the singleton pattern to make this an instance and accessible anywhere by going if instance is not null and instance is not this. We'll destroy this game object so we only have one inventory controller at a time and return. Then outside this if statement, we'll just set instance to equal this. So back in our item drag handler, instead of doing a find each time in our split stack, up the top, I'm going to set a private inventory controller, which I'll call inventory controller. And in our start, we can just set this to equal our inventory controller.instance. So cool, now we've got this down in our split stack. We can check to make sure we've got our inventory controller by checking if it's null or if the new item we tried to clone is equal null. So that didn't work. Let's return out so this doesn't break. Else let's find our slot by going for each transform, slot transform in our inventory controller dot inventory panel dot transform. So each slot inside our inventory panel, we'll go slot equals slot transform dot get component slot to grab its script. We can say if our slot is not null and our slot dot current item is null because we're looking for an empty slot, then we'll set our slots dot current item to equal our new item. Our new item dot transform will go dot set parent to equal our slot dot transform, and our new item dot get component rect transform dot anchored position will set to equal that vector 2 dot 0 so that this is centered, and then we'll return. Outside the for each, if we don't find an empty slot, we'll return this split to its original stack. So we'll go item dot add to stack and pass in the split amount, and then we can destroy that new item. Cool, now we've got that split stack function done. We can copy and paste this up into our on pointer click, and guess what? Hopefully this all works and we should be done. Let's go back to Unity. Oh, and I've got an error, object reference not set to instance. Let's double click on this. It takes us to our update quantity display. Before this gets called, let's go if quantity text is not null, then we'll set our quantity text just in case it doesn't exist on our item or if this hasn't been initialized in our awake yet. So cool, let's go back to Unity and test this again. Let's press play. Cool, I picked one up from our chest and split them out. We've got 3. Oh, and it's breaking a bit. So I'm gonna have to fix this and then come back to you. What is happening? Okay, so there's a problem in our onDrag end. Let's go to our script, and when we're dropping our items and stacking them, we still have this code outside this if-else check, which is set on anything we ever drag and drop, as well as this anchored position that we're setting to everything. Instead of doing this to everything, let's move them so they only do it where they need to be done. So when we have different items and we want to swap them, we're going to want to take these lines of code, paste them in here, as well as this anchored position. For our swapping of the item, we'll also want them in this else, these 3 lines, where we move our item to an empty slot. Now we can delete these 2, so that doesn't affect our stacking item. And when we snap back to our original slot, we'll also want to set this anchored position line and remove it from the bottom. A little bit of confusing bug fixing there, so hopefully you can copy this and make sure yours looks the same. But now if we go back to Unity and press play, we can hoover up all these potions because it's looking kind of messy on our screen. Slop, 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 hoovered up. In our inventory, we've got 5 potions. Let's stack them out. goes to 2 and 1. You can stack them back to 5. Okay, I'm just randomly testing these to make sure it works. Cool. So we got free. It goes from 2 to 1 and then out to free. We'll stack them back up. Oh my god, I'm so glad that works. I was so worried when it kept messing up. Oh, I thought it was going to be something crazy. We can swap our items, we can do a whole load of stuff, and it all works. Thank goodness. And of course, this works with our hotbar. So you can stack and drag and split items from your hotbar as well, as these are all handled with the same slot system. But cool, in the next episode we're going to be adding in the beginning of our quest system, where we'll finally be able to accept a quest from this old man instead of just saying yes we can help over and over again. Yes, I'm going to help you, old man, just wait a second. It's going to make our dialogue even deeper with conditional lines, where what our old man is saying is going to change depending on where we are in our quest. So cool, that's very exciting. Also, as we're getting quite a lot of scripts now in our game, I'll remind you to check out our Patreon, where with one payment you'll get access to all of our scripts we've ever written on my whole channel. And we've got quite a lot of videos now, so that's quite a lot of scripts. Or to save the hassle of putting it all together, you can grab this whole template with all finished features, as well as all future updates for free. So check it out. Otherwise, I'll see you in the next one. Bye! By the end of this video, when we open up our menu, we'll have a new tab, which when we click on will display our quest log. Our quest will have titles and different objectives with the required amount to complete and also our current progress. If we end up with lots of quests, we won't have to worry, as we'll have a scrollable list. And no matter the amount of objectives, our UI will be able to shrink, react, and expand. So let's start off by designing our UI. In my hierarchy, I have my UI canvas, which if I open up, you can see we've got a deactivated menu. If I activate our menu, we can now open this up and see all our different pages and different tabs at the top. I'm going to add a new tab in here by clicking on Inventory tab and pressing Ctrl D, which I'll now rename Quest tab. We can open up this Quest tab and change the text to say Quest, and then back on the Quest tab, down the bottom, we've got our event trigger. So when we click on our tab, it'll move us to our correct page. These numbers are the same as an array, so starts at 0, so player is 0, inventory is 1, and quest will now be 2. We'll go down to Map tab and set this to be 3, and Settings tab to set this to be 4. These will have to align with our pages. So let's go to Pages, press Ctrl D on our inventory page. I'll rename this Quest page and remove this grid layout group component because we won't be needing that. So now if we activate our Quest page, you can see we've got a nice blank page to put our quest content on. But our Settings tab is gone missing and has been pushed off this bar. So let's click on our tab's game object. We'll set the spacing down to 0 now, as we need some more room, and I'll set the cell size on the X to be 340, so that our tabs all fit along the top nicely. The inventory text is a bit too big, so I'm just going to change that down to 40, so it wasn't overlapping the side. Now we can also see we've got our tab controller script with all our different tabs and all our different pages slotted into here. Let's add one more on both and replace that map tab to now be our quest tab. And the same with the page, our quest page to replace our map page, and then put our map tab and map page to be element number 3. So these now all align with each other. So now if we press play, we can see we've got our new quest tab, and when we click on it, we've got our blank page ready to set up. So cool, I'll close down our tabs. And on our quest page, so that we're able to scroll down when we have lots of quests, I'm going to right click and go UI, scroll view. And I'll call this Quest Scroll View. If we open this up, we're automatically given some pieces. The bit we want to look at is the viewport. This contains content, and in this content is where we're going to build our Quest UI. We can see in the middle of our screen, this looks quite small, so if you click on Quest Scroll View, double click on this to see it in your scene view and zoom out a bit. You can drag this to fit the size you want on your screen. I'll drag mine out, leaving a gap at the top, so maybe we can add some text. Cool, now let's click on our content, right click and go UI, panel, which is going to be our quest entry. I'll right click on this quest entry, go UI and add text, and this will be our quest name, which I'll call quest name text. I'll set the color of this to black. I'll drag in the custom font we set up, and I'll just change this to be quest name for now. Cool, I'll drag this up to the top. Cool, now we're also going to want to right click on our quest entry and add a UI panel again for our objective list. So if you have multiple objectives in one quest, we'll be able to list them all out here. So right click on your objective list and we'll go UI text, and we'll call this objective text. I'll once again type in objective text, make this black, and pull in our custom font. Now you can see these are all bundled on top of each other. So let's get these to organize out in a dynamic way. If we click on content, we're going to want to add a vertical layout group. We can give a spacing of 10, then add another component called a content size fitter. We'll set vertical fit to be preferred size, and then move on down to our quest entry. On our quest entry, we're going to want to add another vertical layout group. We won't want child forced expand on height, but we do want use child scale on height. And we'll add some padding in a bit later. But for now, we'll add another component, and we're going to want another content size fitter for the vertical fit to be preferred size. Next, same on our objective list, we're going to want a vertical layout group, add a spacing of 5. All these settings can stay the same, and we'll add a content size fitter with a vertical fit, a preferred size. Cool, so now if we duplicate these quest entries, you can see these all space out. And if we add more objective text, this also spaces out automatically. So cool, obviously you can design this however you like, but to make these entries a bit prettier, I'm going into the Ninja Adventure Asset Pack, into the UI, then into Theme, and we've got this 9path5 PNG, which I'm going to drag into our assets, bring into our sprites folder, and set this up in the inspector by setting the pixels per unit to be 16, filter mode to be point no filter, and compression to be none. And I'll show you for now. Click on our quest entry and drag this now in to be our quest entry's background image. It obviously doesn't look right. We could try stretching this out, but the sprite gets really weird. So to get a sprite stretching correctly, which I didn't know about, because you can see my background looks a bit warped, and I'll probably fix that one too. If we click on our 9path image and change the mesh type from tight to full rect, then click apply and go to the sprite editor, we can set up our borders. Now to do this, we basically want to say which bit to keep the same and which bit to be able to stretch. As this has this little orange fold on the piece of paper, I'm going to make it so it's within this line and even around the outsides. So we've got this little square in the middle, which is going to be the piece that stretches. So our border is 5, 6, 5, 5, just to avoid this little top bit. If we click apply now, click on our quest entry, and drag in this image again to the source image, we can now stretch this out to be the width we want. And if we added more objectives, you'll see this grows. But obviously this still doesn't look right. We need a bit of padding around our text. So let's click on quest entry. And to get this to fit nicely, I used 50 on the left, 0 on the right, 40 on the top, and 50 on the bottom. Now this looks much nicer. And just as a personal preference, I'm going to indent in our objective test by going to objective list and setting its left padding to be 50. Cool, let's press play. And if I open up our menu and go to our quest page, we can see our nice little quest entry. We can add some more quest entries, and we'll see our scroll bar is growing, so we can scroll down and see our other quests. This also works by clicking and dragging, or with your scroll wheel, but it is quite slow on the scroll wheel. Cool, now our UI is all set up. To get these entries populated with some quest data, we're going to need to add some classes. So that's what we'll be doing in our next episode, where we'll create a scriptable object for creating our different quests in our game, and then writing a quest UI controller script in our quest log. So very cool, very exciting. Like and subscribe so you don't miss out. As always, you can grab every script I've ever written on my Patreon, also you don't have to put it together yourself. You can grab this whole template, including all finished features and any future updates, for free. Otherwise, see you in the next one. Bye! In our previous video, we added a new tab to our menu UI for our quest log. For the UI, we used test data to populate our quest entries, but by the end of this video, we're going to be able to write our own quests using scriptable objects, so we can edit them in our inspector. So we'll be able to create a quest, add new objectives, like if we say we want to collect 2 heart potions, and then this will be synced and updated in our UI. To get these entries populated with some quest data, we're going to need to add some classes. So we'll first want to add a scriptable object, so we can create new quests for our quest class, so we can create new quests. We'll want our quest objective, so we'll have a quest objective class. And we'll also need to know our quest progress, so we can display this in our quest log. So in our assets, I'm going to right click and go create C# script and call this quest. We can double click on this to open it up. And at the top, as we want this to be a scriptable object, we'll go square brackets, create asset menu, brackets, menu name equals, and inside the quotes we'll go quests/quest. Now instead of mono behavior, we want this to be scriptable object, and we'll delete this start and update. So at the top, let's add our variables, which will be a public string quest ID, a public string for our quest name, public string for our description, and we'll also want a public list, which is going to be for our quest objectives. We're going to write the class for this in a second, but we can simply call this objectives. Now when we create a new quest scriptable object, I want it to automatically generate us a quest ID to make sure this is always unique. We can do this by using a private void on enable. This method is called whenever the scriptable object is first created. In here we'll say if string dot is null or empty and pass in our quest ID. We can then set our quest ID to equal our quest name plus a GUID, which we can import by hovering over and going using system dot new GUID brackets dot to string. So this will create us a unique quest ID for us. Next, we'll make our quest objectives, and as we want this to be able to save in our system, we're going to add a system.serializable as we're saving to JSON, so this needs to be serializable, and we'll write a public class called quest objective. Oh, and up above I've got a list of quest objectives. We just want objective. Cool. So in here we're going to want our public string objective ID. And this objective ID is going to be what we use to match with our item IDs that you need to collect or enemy IDs that you need to kill. It's not like our quest ID that's a unique identifier of the quest. It's the unique identifier of what our objective is. Then we'll have a public string for our description. So that may be collect 5 potions, kill 5 slimes. To know if this is items or killing enemies or something like that, we're going to create a public objective type, which we'll call type. And this is going to be an enum, so we can create this now by going public enum objective type. And we can say maybe this is collect item, maybe you have to defeat a certain enemy, maybe you need to reach a certain location, maybe you need to talk to a specific NPC, or we can add in a custom quest in case there's something else that doesn't fit into any of these criteria. So cool, we'll know what our objective type is. Now we're also going to want to know a public int of the required amount, so how many to collect, how many to kill, and of course then a public int of our current amount. Cool, to make this easy for us, we can add a public bool called isCompleted, go equals greater than current amount greater than equals required amount to say if we've currently got more than or equal to the required amount, this will return true and say that our objective is complete. Cool, we'll leave it at that for now. We're going to add more details to this when we get more in depth with it with the next episode. But for testing's sake, we'll just add what we need for the UI. So next up will be another system.serializable and add in our public class quest progress. Inside our quest progress, we'll have a public quest, which we'll just call quest, and a public list of quest objectives, which we'll call objectives. And with these two, we'll create a constructor. So when a new one of these is made, this will be called by going quest progress brackets and passing in the quest that we're accepting. So when we accept a quest, we'll set this quest to equal quest. So we're storing the quest we're accepting into our quest slot. So we know we've got an active quest in progress. And then our objectives will set to be a new list of quest objectives. Now to explain the reason we're copying this out from our quest and not using it directly is in case you use this quest in multiple places, we don't want to edit the original. We don't change anything in our actual quest, so it's fine to reference this straight into our quest progress, but with our objectives, we're going to be changing our current amount. We don't want that to change the original. So we're going to make a deep copy to avoid modifying the original. To do this, we go for each var obj in objectives, then add to our objectives by going objectives.add and passing in new quest objective, braces, objective ID equals obj.objective ID, description equals obj.description, comma, type equals obj.type, required amount equals obj.required amount, and then finally current amount, this one's different, we'll set this to equal 0 and a semicolon at the end. So when we start our quest, we'll set this always to 0. Now we'll add a couple of handy little methods. One to check if we completed the whole quest, so all the objectives, by going public bool is completed. And same as above, we'll go equals greater than. This time it'll be objectives dot true for all. And in here we'll check O equals greater than O dot is completed, semicolon. So when all objectives are complete, the quest that holds them is complete. And then we're also going to add a public string for our quest ID that'll equals greater than our quest.quest ID, because otherwise we'd be going quest progress.quest.quest ID, and that's too many dots and quests. So this will just be quest progress.quest ID will return us this. Oh, and just before we go, there's a little mistake here in objectives, so we need that to be our quest.objectives. Otherwise, we won't find any objectives in this new list we just made, of course. So cool. Let's go back to Unity, and in our assets we can now right click and go create, and at the top we should see a section for quests. We click on this quest, it'll create us a new quest. I'm going to call this collect potions. Oh, and as I created that, I saw the quest ID appear and then disappear. I think I know how to fix this. Quickly, let's go back to our quest script. Instead of on enable, we can set this to be on validate, and this is called whenever the scriptable object is edited. So now back in Unity, we can now see we have our quest ID. Our quest name is empty. So if I call this collect potions, we now get a quest ID of collect potions and then a long GUID to make sure this is unique. Cool. For the description, I'll write, we must collect 5 potions to help. I don't know. And then for objectives, if we open this up, we can add a new objective. As I'm going to be collecting items, I want my objective ID to match with our items ID. So if I go to my item prefab and scroll down, I can see in my item script, my ID for my potions is 1. So back on my quest, my objective ID is going to be 1. The description I'll call collect 5 potions. The type will be collect item and the required amount will be 5. Cool, and that's all you'd need to set up a quest. With this data, we can now use it to test and populate our quest log. So we're going to want to write a quest UI controller to handle populating our quest logs UI. So I'm going to go to our game controller object, and you can either add this like I've done with the inventory controller directly to this object, or if I open this up, I've got another one for my dialogue as an example of how it could be its own game object. Let's make it its own game object by going create empty, and I'll call this quest UI controller. I'll add a new component, a new script, and call it Quest UI. And we can double click on this to open it up. And in here, we're going to need a public transform for our quest list content. This will be that content inside our scroll list. We'll want a public game object for our quest entry prefab, and a public game object for our objective text prefab. So those will be the UI pieces we need. For testing purposes, I'm going to want a public quest for the test quest we want to pass in. And I'll also set a public int for our test quest amount. So we can say how many of these quests we want to populate our log. And to store these, we'll want a private list of our quest progress. Oh, and it can't find it, so something's gone wrong in our quest script. Let me go check. Okay, silly me, I put our quest objective and our quest progress inside of our quest class. We want these to be their own thing, not inside the quest. So I don't know if you've done this as well, but I just need to cut these out of our quest and paste them just below that bottom brace. So they'll be accessible outside of our quest class. Now if I click on Quest UI, we can now access our quest progress, and I'll just name this test quests. And we can set this to equals new, which will just create a new list for us. Now inside start, to get our test set up, we can go for int I equals 0, I is less than, test quest amount, and I++. We'll want test quests dot add and pass in a new quest progress and pass in our test quest. So it'll be the same quest duplicated down as many times as we want to test. Very cool. Now we won't need this update function, but we will be creating our public void update quest UI, which we'll call whenever there should be a change in our quest progress. So first we're going to destroy any existing quest entries by going for each transform child in quest list content. So anything inside that content pane will destroy the child.game object. Then we'll go around and build our quest entries. So we'll go for each var quest in test quests. Obviously we're going to be replacing this for each with our active and dynamic quests, but we'll set that all up in the next episode. So in here we're going to go game object entry equals instantiate quest entry prefab, comma, quest list content. So we're going to parent quest entry to our quest list, tmp underscore text, and we'll have to import this in for using Text Mesh Pro. This will be our quest name text. We'll set this to equal our entry.transform.find and pass in the name of the text that holds our quest name. So in Unity, you can see this is quest name text. It needs to match this exactly to be able to find it. So make sure you get this right. Quest name text inside this find. We'll go .get component tmp underscore text. And we'll also want to grab the transform objective list and do the same on our entry.transform.find and pass in the name, which is objective list. So I can copy this and paste it in. Then down below we can go quest name text.text equals our quest.quest.name. So the quest that's in progress, we're getting the quest details from it and then grabbing the name. And then we can go for each var objective in quest.objectives game object obj text go for game object equals instantiate objective text prefab, comma, objective list. Now we can grab the tmp underscore text for the obj text, which will equal our obj text go dot get component tmp text, and we can now set this text to equal. Now I'm going to go $ quote curly braces so we can pass in our objective dot description. So currently this says collect 5 potions, and I'll go space brackets open bracket curly brackets objective dot current amount, and outside the curly brace I'm going to go slash curly braces objective dot required amount, and then close brackets. Oh, this had to be objective text dot text. That's why there was a red underline. So this should look something like this: collect 5 Potions, 0 out of 5. Cool, now we've got this function all done. We're going to need somewhere to call it from. Obviously we don't have this set up in the rest of our game yet, so on start I'm just going to call update quest UI. So this will populate, but nothing's going to change just yet. So let's go back to Unity. Now on our Quest UI controller, you can see we need to drag in our quest list content. So that's this content underneath our viewport. Then we're going to need an objective text prefab. So let's drag out one of our objective texts from our hierarchy into our assets to make this a prefab. And we're also going to need a quest entry prefab. So let's delete this objective text so it doesn't have this by default on here. Then drag out our quest entry from our hierarchy into our assets. So both of these are now prefabs. We can delete this from our content. Now on the Quest UI controller, drag in our objective text prefab and drag in our quest entry prefab. For our test quest, we can drag in our collect potion quest that we set up. And for the test amount, I'll type in 5. So cool, now if we press play, we can open up our menu, go to our quest page, and we can see all our test quests populating. We should have 1, 2, 3, 4, 5. Anything you need to change, you can change here so you can see our text is getting cut off. We need this box to be longer. So if we unplay this, to edit that, we can go to our prefab, double click on it, click on our quest name text, and now we can drag this out. So that'll fit any quest name we need. Then back on out, I'll edit our objective text just to check it, and we can drag this out wider too. So cool, I'll add in a bunch more quests so we can test this amount. And let's even edit our quest itself and add in some more objectives. Maybe it'll be collect 5 hearts and collect 10 potions. That doesn't really make much sense for a quest, but it's just to get an idea of how it looks. If we press play now, go to our quest panel, we can see this all spaces out nicely and we can see all of our objectives. Amazing! In the next episode, instead of manually forcing these quests into our log, we're going to be able to finally go up to our old man and say, hello, yes, we are able to help, and accept this quest from him. So very cool, very exciting. Like and subscribe so you don't miss out. As always, you can grab every script I've ever written on my Patreon, or to avoid the effort of putting it together yourself, you can grab this whole template, including all finished features and any future updates for free. Otherwise, like and subscribe, and I'll see you in the next one. Bye! In our previous video, we set up some test data that filled in our quest log. But by the end of this video, when we talk to our NPCs, he'll ask, can we help? And we'll be able to say, yes, of course, because we're very kind. He'll say, thanks. And now if we check our quest log, a quest has been populated, given to us by that old man. Then when we talk again to our NPC, he'll say, good luck finding those potions. We're going to have conditional dialogue. He knows we're on the quest. Let's check it out. So let's get straight in there and start off by writing a script to manage holding our quests. So I'm going to click on our game controller object, and as this holds our inventory controller and our save controller, it's a bit data-y. So I'm going to use this as our holder for our new script, which I'll call our quest controller. I'll double click on this to open it up, and in here we're not going to need update or start, but we will want to make this a public static quest controller instance, which inside our brackets we can set to get private set. To set up this instance, we'll use an awake and go if instance equals null, then instance equals this, else destroy this game object, so that we only have one quest controller in our game. By making this a static instance, we'll be able to use this script from any of our other scripts. So cool, next at the top, we'll want a public list of our quest progress, the class we set up in our previous video, which holds our active quest progress. So I'll name this active quests, and we'll set this to equal new. Cool, and last of all, for now, we're going to want a private Quest UI for our Quest UI, so we'll be able to talk to the UI script, which we also set up in our previous video. So if you haven't done those, I'll link them below. So cool, to grab this Quest UI inside our awake, we'll go Quest UI equals find object of type and passing Quest UI, so we can grab that script and use it in our next function, where we'll go public void accept quest. Here our NPC will pass in the quest that he's holding and that he's giving to us. So when we get a quest, we'll go active quests.add and pass in a new quest progress, then brackets, pass in the quest. So this will construct a new active quest for us based on this template of a quest. We use quest progress instead of just quest so that we can up our current amounts without editing that existing quest, in case you want to reuse it later. Maybe you have a repeatable quest or something. But anyway, now that that quest is added to our list, we'll go quest UI dot update quest UI. Now if in your game you only want one quest at a time of a certain type, which is what I think is in most games, so I'm going to add to my game a public bool of is quest active, pass in a string quest ID, then type equals greater than active quests.exists, pass in queue for quest equals greater than queue.questID double equals quest ID that we've passed in. So here we're checking, does this quest ID already exist in our active quests? And we'll pass back true or false. So before we accept this quest and add it to our list, I'm going to check if is quest active and pass in the quest.questID. And if it is already active, I'm just going to return out of this. So we never accept a new quest that already exists. Cool, so for accepting quests, this is all we're going to need for now. Let's go back to Unity. And next up, we're going to want to work on our NPCs and them giving us quests. So I'm going to go to our NPC folder and into our old man and go to our old man dialogue script. On this scriptable object, we have our dialogue lines, some options which attach to these dialogue lines, and some choices. If you haven't done our NPC script, you might want to catch up with that one too, as we're going to continue on from this and add our quest options. With these choices, you can see here he says, "Hello there, young man. Can you help?" This is dialogue index 1. Which, if you look to our choices, links to this element, dialogue index 1 here, meaning if we say, "Can you help?" it'll display either yes or no, and will then be pointed to our next lines. If you say yes, he'll say, "Thanks, I knew you'd help," and if you say number 4, no, he'll say, "Oh, okay, maybe next time." On yes, we want him to accept a quest. So we'll add a new section to these choices and add a couple more variables down the bottom for our quest lines. So inside my scripts folder, I'm going to go to NPC Dialogue and open this up. And like I said, we're going to want something that tells us which of our options from our choices makes it so we accept a quest. Let's go public bool array with the square brackets, and I'll name this gives quest, which shows if our choice gives a quest. Then up in our NPC dialog, I'm going to add some more variables. So first I'm going to add a public int, which I'll call quest in progress index. So if we're currently accepted the quest, what will our old man say when we talk to him again? Like, "Good luck finding those potions." And then a public int for our quest completed index. So when we've completed the quest and we go to talk to him again, what's he going to say? And finally, of course, we'll want a public quest of quest. Added a few comments just in case none of that's clear, but let's go to Unity and populate these so we can see how they're used. So back in my NPC folder for my old man dialogue, you can now see on our choices, we've got a new array. If I add some, you can see these are tick boxes. I'm going to add 2 to line up with our choices. So if we say yes, it gives a quest. So I'll tick element number 1. If I said no to "Can you help?" I'm not going to give us a quest, so I'm going to leave that unticked. Now for our quest in progress index, what do I want him to say while we're still on the quest and we haven't finished? I'll add a new line to our dialogue lines at the top, and let's say he says, "Good luck finding those potions." We don't want that to continue after that, so in our end dialogue lines, we're going to want to add 1 more for element 6 and have that ticked. So after he says "Good luck finding those potions," it'll end and it won't continue down our list. So that's element number 6. In our quest in progress index, I'll type number 6. For our quest completed index, I'll add a new element again, and we'll say "Thank you for the potions." Let's add another line. He'll say 2 things because he's real happy. "Maybe I'll open a shop." Ooh, foreshadowing. Cool, so that's 2 more elements there. Let's add that onto our end dialogue lines. Element number 7 we don't want to end on, but element number 8 I'll leave ticked. So he'll say "Thank you for the potions. Maybe I'll open a shop." Very cool. On our auto progress lines, I'll just add the same amount so it's consistent. And maybe I'll make our "Thank you for the potions" auto progress. Or customizable, however you like. So cool, let's close those up. Now we've got "Thank you for the potions" is what we want him to say when it's completed. So let's put number 7 in our quest completed index. And finally, we want to pass in our quest. So in my assets, I've got our collect potions quest scriptable object all set up. I can just simply drag that in to our quest slot. Very cool, that's an NPC set up with choices, dialogue lines, and the conditional dialogue lines set up, ready to be added into the script. Now that that's all ready, we can go to our NPC script and implement this. So inside scripts, I'll go to my NPC script, double click on this, and in here at the top, we're actually going to add 2 new things. The first being a private enum called quest state, since we want to know what part of the quest we're at, as this is going to affect how our NPC acts. So is the quest not started? Is the quest in progress? Or is the quest completed? Of course you can have NPCs that won't give quests. You just won't have any choices that tick the give quest button, so you can just ignore all the quest bits on an NPC scriptable object if you don't want them to give a quest. Anyway, we're going to want to store this quest state in a variable called quest state, and we'll just set this to a default of quest state dot not started. So cool, let's go down our script. All of this top bit is fine, but inside start dialog, we're going to want to sync in with our quest data. So let's say maybe we've started a quest or completed one. We're going to need to know about that from our quest controller. So we're going to write a function to do that. And once we have that quest data synced, we can set our dialog line based on that quest state. So underneath this start dialog, just so we can see it easily, I'm going to add a private void sync quest state. And in here we'll check if our dialog data dot quest is null. If it is, and we don't really care about quests, we'll return straight out. Otherwise we can go string quest ID, set this to equal our dialog data dot quest ID, as we're going to use this to check if our quest controller dot instance dot is quest active and pass in our quest ID. Then we'll set our quest state to equals quest state in progress, else we'll set our quest state to equals quest state not started. Now, as this comment says that I just added, in a future update we're going to add completing our quests and handing in, which we'll also need to add to this sync quest state. But for now we'll stick to these two, as that'll be a lot to do all in one video. But cool, now we've got this sync quest state. We can stick this up in our start dialog under where we've written that little comment, right at the top. And like I said, now we can set our dialog lines based on these quest states. So if our quest state is equal to quest state dot not started, we'll set our dialog index to equal 0, which you can see is also down below under is dialog active, which we're not going to want, so let's delete that, as we only want it done if our quest state isn't started. Else if our quest state equals quest state in progress, our dialog index will equal dialog data dot quest in progress index. And of course here we'll also go else if quest state equals quest state completed, our dialog index will equal our dialog data dot quest completed index. But we won't see this bit yet. Like I said, it'll be in a future video. At least it's set up here. So cool, let's see what happens next within our dialog system. So we set everything up at the beginning, and then we call display current line. If you hold down Control and click on this function, you can see where this goes to. So display current line starts a coroutine of type line. Let's go to type line. And in here we type our line out. That's all cool and fine. Then we call next line. Let's go into next line, and in next line we do our typing, we check if we want to end the dialogue, and then we display our choices. Okay, we're getting there. Inside display choices, this is where we're going to want to accept some quests. I did that the long way so you could see how you step through code and find where to go. So inside display choices we create our choice button. So our choice button is telling us what the next index we want to go to is. We're also going to want to tell it about a bool of gives quest. So does our choice dot give quest, and then square brackets pass in our I to grab the correct array. That'll line up with that tick of if our choice gives a quest or not. With this gives quest, we're going to want to pass this into the choose option function, which you can see is down below. Let's pass it in while we remember. So choose option needs now to accept a bool for gives quest. In choose option, in the parameters, we'll go comma bool gives quest, and we'll simply say if gives quest controller dot instance accept quest, and we'll pass in dialog data dot quest, the quest that our NPC is holding. Then we can set our quest state to equals quest state dot in progress. So cool. That's all we need for our NPC. Let's go back to Unity, and the last piece we want to do is for our UI. Right now, inside our game controller, we have a Quest UI controller script. In here, we're passing in some test data. So we're manually passing in tests and forcing those into our quest log. Now we've got some real data to play with. So let's go inside our Quest UI script by double-clicking on this, and you can see we have this test quest. You can leave this here if you like, so you can keep switching between test quests and our active quests. But to get this to access our active quests instead, it's very simple. Instead of test quests here, where we're building the quest entries, we want to go quest controller dot instance and call our active quests. And guess what? That's all you need. If you want to switch back to the test quests, of course you'd always just be able to copy and paste this in here. But if you don't want to use test quests anymore, you could delete this code. Very exciting to delete code. Oh, look, it's shorter. Wow. So cool. Now if we go to Unity, we can try pressing play, and we can take a look in our menu inside our quest tab. We've got no quests at the moment. Let's go to our old man. Okay, please work. Hello there. Can you help? Yes. Thanks. And you, oh, I pressed it too fast. I knew you'd help is what he said. If I take a look, you can see we've got 5 potions that we need to collect and 2 heart potions that we need to collect. That's so exciting! Now, if we talk to the old man, he should say, good luck finding those potions. Amazing, it's gone to our in progress instead of our normal text. That means we now have an official quest giver, and our quest log is now using active quests. Of course, if I go to grab some potions and check our inventory, we've got 2 in there, but this hasn't updated in our quest log. Well, in the next video, we're going to get picking up items, updating our quest progress. And also, when we drop our items, it'll also make it so our quest progress will go down, and when we pick it back up, it'll go back up again. But we'll split that into the next video. Of course, if you haven't been following along with this series, and that's a lot of scripts that you need to catch up on, don't worry, because you can join our Patreon. On our Patreon, you can grab every single script I've ever written. Not just this series, but the whole channel. Or to make it even easier, where you don't have to put any of this together, you can get the whole template with all finished features and future updates, which are included for free, which I'll also link below. If not, I'll see you in the next one. Bye! By the end of this video, when we talk to our NPC and get a quest from him, thanks, I knew you'd help, that's what he said. When we go to our quest log, we can see we've got this new quest. Our inventory is currently empty, but if I go to our chest, grab a potion, you can see our progress goes up on our collect potions. We got 1 out of 5. We're also going to be adding in saving our quest progress. So when we reload our game, our NPC will remember that we're on this quest, and we don't have to pick it up all over again. We're going to be using scripts that we wrote in our previous videos, so I'll link the playlist below, or you can join our Patreon where you can grab every single script, or you can grab our template where you get the whole project set up for you, all finished features and future updates. But cool, if not, let's check it out. So we're going to want our quest to update when we pick up our items. Our items are stored in our inventory. On my game controller, I have my inventory script. So I'm going to double click on this to open it up. And in here, since our quest needs to know how many items we have in our inventory of a certain type, I'm going to create a dictionary of type int and int, which is going to be our items ID and then its count amount, which I'll call items count cash. And I'll set this to equals new. We're going to update this whenever our item amounts change inside our inventory. So we keep a synced track of our item count. Then to let our quest manager know when our items have changed, so we can update that in the UI, I'm going to create a public event action, which will have a red underline. So we'll hover over this, click show potential fixes, and add using system if you don't have that already. And I'm going to name this on inventory changed. So this will be an event which will notify our quest system or any other system that needs to know. I'll show you how to use this, but basically our quest controller is going to subscribe to this event, and whenever the inventory changes, we'll send a ping to our quest controller so it knows to do some updates. Now we're going to want to create a function that builds our items count cache. So I'll do this at the top and add a public void rebuild item counts. In here we'll go item count cache dot clear, so we clear out anything we've currently got since we're going to rebuild it, and go for each transform slot transform, which is our inventory slot, in inventory panel dot transform. We want to get our slot, set this to equal our slot transform dot get component slot, so we can get the script, and then we'll check if our slot dot current item is not null. Then our item equals slot.currentItem.getComponent item. Then we'll say if our item is not null, lots of checks so nothing crashes. Our items count cache, we'll use square brackets to set the item.id as the key, and then set the value to equals items count cache.getValue or default, and pass in our item ID, then comma, and the default would be 0. Then plus item.quantity. So what we're doing here is adding this item's quantity to any existing value inside our cache. Because in our inventory, we can split our items out into different stacks, or they can be stacked in one slot. So say you had 1 in one slot and 1 in another. You'd want to add those 2 with the same ID into one single cached value for the item count. As if you've got 2 in your inventory, of course you want your quest to know that you've got 2 items here. So cool, and after caching our items, we can then go on inventory changed dot invoke. So we've told anything that's subscribed to this event that our inventory has been changed. Now so we can access this dictionary in a safe way, since our item cache we want to be private so it can only be changed within this function. Let's go public dictionary int, and we'll name this get item counts. After your brackets for the parameters, do equals greater than or arrow function to simply return our items count cache. Now we'll be able to call this when we want to check our item counts for our quests. So we're going to want to call this rebuild item counts in a couple of places in our script. First at the top we can call it just when we start our game, as we may have started with items in our inventory loaded from our save file. Let's scroll on down and see what else we got. Cool, so of course when we add an item, every time we return true is where we've added an item. We're going to want to rebuild our item counts. So before we return true, we'll paste in rebuild item counts function. And this is if we have the same item type in our inventory, so it's stacking. So we're also going to want to do it when we don't have the same item type. We've added it to a new slot and we want to rebuild our item counts before we return true. We don't want it before return false, since we're not adding this item as our inventory was full. If we scroll on down, we can also see we set our inventory items when we're loading our save data. Right down at the bottom of this function, after everything's been initialized, we can again call our rebuild item counts. And just before we close this down, I've actually made a mistake. If we scroll back up to our rebuild item counts, this on inventory changed, we only want this to invoke if this has been subscribed to and set to an event. So to check if this has been assigned to, all we have to do is put a question mark at the end of on inventory changed before our .invoke. Phew, almost made some errors for us. Now before I get synced up with our quests, there's one more place we need to call our rebuild item counts from. Because not only when we pick up our items will we want this to rebuild the cache, but also when we drop our items, we're going to want to know that we've dropped one and our item count has gone down. So in my scripts folder, I have an item drag handler script, which handles all our dragging and dropping of our items. If we double click on this and scroll on down to our drop item function, at the very bottom of here, when we've dropped our item, we can simply go inventory controller .instance .rebuild item counts. So that's at the very end of our drop item function. When everything has been finished and dropped, we'll rebuild our item counts so we know we're one less down. So cool, that's all we need in this script. Back in Unity, we can now take a look on our game controller and add our quest controller, where we'll link this up with our inventory to check for quest items. So let's double click on our quest controller script, and first of all we'll subscribe to that on inventory changed event so we can know when to update our quests. So let's go inventory controller .instance .on inventory changed and go plus equals, and here is where we'll input our function that will be triggered when our inventory is changed. So down below I'm going to quickly write a public void check inventory for quests, and I'll copy this and paste it up after our plus equals. So when inventory controller triggers that on inventory changed, we're going to call this new function. So in this new function, we can go dictionary int comma int for our item counts, which will equal our inventory controller instance .get item counts. So we can grab that cache and then go for each quest progress quest in our active quests, and then for each quest objective in our quest .objectives. So for every objective we have, we can now check if our quest objective .type is not equal to objective type .collect item. Then you can type continue, so that if our quest objective isn't to collect an item, we'll skip this objective and check the next one. Next we can check if question mark for not int.try pass quest objective ID, then comma out int item ID, then we'll continue. So if our objective ID can't be passed out to an int, this will skip this objective, as it won't be able to match with one of our integer item IDs. Now we know that's all safe to continue, so we can go int new amount. So the new amount we want to set our quest progress amount to, and by quest progress amount I mean, like, you know, we've got 4 out of 5 potions or something like that. We're setting the 4 out of the 5, which is the required amount. So our new amount will equal item counts .try get value, pass in our item ID, and we'll pass out our int of our count. This try get value returns a bool. We can check if this is successful by doing a question mark and then passing out our count. However, if we have, say, 10 potions in our inventory, but we only require 5, we don't want it to say 10 out of 5. We want it to cap out at that 5 amount for the required. So instead of just writing count, we can go mathf.min, pass in our count, and then pass in our quest objective .required amount. So this will display the lesser of the two. And then if we didn't find any items in our item count cache, we'll go :0, as there's none in there. Then we'll say if quest objective .current amount is not the new amount, so it's not the same, we'll update our quest objective .current amount to equals the new amount. And since this has changed, we want to update our quest UI, so we'll go quest UI .update quest UI. So cool, that's all we need here. Let's go back to Unity and test it out. Aha, as I press play, you can see I've got this error down in my console, saying that an object reference is not set to an instance of an object. If I double click on this, we can see this takes us to the line where we're accessing our inventory controller.instance. This can happen if our quest controller is loading in before our inventory controller. So our inventory controller's instance hasn't been set up yet. To fix this, in Unity you can go to Edit, Project Settings, and then in this list go to Script Execution Order. You can see here we've set up a couple already, where we needed our item dictionary before our inventory controller and our inventory controller before our save controller. We're now going to want to make sure our inventory controller also loads before our quest controller. So on the plus, let's add our quest controller, which you can find in this list. And this should be fine just where it is, as our inventory controller is now above our quest controller. You can click apply on this, close it on down, and now we can press play and test this out. So right now I've got no quests in here. I'm going to talk to my old man. Can I help? Yes, I can. Thanks, I knew you'd help me. Okay, now we've got a quest in here, 5 potions and 2 heart potions. Let's go to my chest because I know that I've got some potions in here. I get 1 potion. Let's go to our quest. We've got 1 out of 5. Oh, our heart potions is set to 1 out of 2. I think I've set that quest up incorrectly. Let's go check. So on my quest scriptable object, yeah, I can see my objective ID is still 1 when our heart potions objective ID is 2. So that's why that broke. Okay, let's test that again. Go to my potions, got my potion. There you go, 1 out of 5 and 0 out of 2. Let's check our dropping. So drop our item, check our quest. We got 0 out of 5. There's our potion on the floor. Pick it back up. Quest 1 out of 5. Very cool. Our quest progress is all working. Now I do have another problem though. If I press save here and then close down my game, when I open it back up and check my quest log, my quests are gone. He's saying, can I help? I already said yes before. I've got a potion in my inventory, but my quest says 0 progress. Okay, we need to fix some things. I missed a little bit in our quest script, and also we need to add this to our save controller. So first let's go to that quest controller script again, and don't worry, it's an easy fix. When we accept a quest, we're going to want to check our inventory for any quest items. So just before we update the quest UI, I'm going to call check inventory for quests. And that's all we need to fix that little bug, but now we want to get saving. So back in Unity, on my game controller, I have my save controller script. Let's double click on this. And in here you can see where we save our game. I'm going to want to add saving our active quests into our save data. To get to this save data class, you can hold down Control and click on save data here, which will snap you to our save data script. So in here, I'm going to duplicate this list of chest save data. I'll change this to be our quest progress data, and it's going to be a list of quest progress. Cool, we can go back to our save controller. And in here, it's very easy. We just want to go comma, quest progress data equals quest controller dot instance dot active quests. Now to load our game, we're going to need a nice load quest progress function in our quest controller script. So back to our quest controller, let's scroll down the bottom and add a public void load quest progress. In the parameters, we'll have a list of quest progress, which I'll call saved quests. Then we'll go active quests, which is our list in the top, equals saved quests, question mark, new. So what this does is either loads in our saved quests, or if we don't have any saved quests in our data and this is null, we'll just set it to a new empty list. Then we can call our check inventory for quests again, in case we've loaded some quests in and we have items for it in our inventory slots, and then go quest UI to update quest UI. Cool, that's a nice little function there for loading our quest progress. Let's go to our save controller, and I'll just do this at the bottom here, where we'll say quest controller dot instance dot load quest progress and pass in our save data dot quest progress data. Very cool, and guess what? We're all done. Let's go to Unity and test it out. If we press play, so cool, right now our quest log is empty, but I do have a potion in our inventory from our chest that we opened. Let's talk to our NPC. Can you help? Yes, I can. Thanks, I knew you'd help. Okay, cool. So we've got our quest in here. It has updated to know that we've got that 1 potion now. Very cool. Let's go to our settings and press save. Close this down, then press play again. And now if we open up our menu, we can check our quest log and see that our quest is still here, as well as our potion, and as well as the progress. If we talk to our NPC, good luck finding those potions. He knows that we've got the quest. Ah, it's all working. Amazing. So I need 5 potions and 2 heart potions. Okay, I've added these in to our game. If we pick these all up, our quest should be complete. How exciting. Let's go to our old man and try and hand this in. Good luck finding those potions. What? But old man, I've got the potions. Look, right here in my inventory. Yeah, so that's our next video. We're going to be adding in completing our quest. If there's anything you're missing in our scripts and in our game so far, you can always go to our Patreon, support the channel and get every single script I've ever written, or you can check out our whole top-down template with all finished features and future updates for free to download right now. So check it out. If not, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, when we go to our NPC and get a quest from him, can you help? Yes, of course I can. Thanks. I knew yeah. We can check out the quest we got. We need to collect 5 potions and 2 heart potions. Let's pick up the rest of them. There they are in our inventory. In our quest log, we can see they're all done. Let's go back to our old man. Thank you for the potions. Maybe I'll open a shop. How sweet of him. We check our quest log, it's all gone, and our inventory, he took our potions. Well, we gave them to him, so it's fine. If we talk to our NPC again, he'll remember that we've completed the quest, and repeat saying, maybe I'll open a shop. Foreshadowing. The state of our quests and our NPC remembering that we completed the quest will also be saved when we save our game. So cool, let's check it out. So first, let's set up the functions we need inside our quest controller. On my game controller, I have my quest controller script. I'll double click on this, and at the top, so we can save and know what quests have been handed in, I'm going to create a new public list of string called hand in quest IDs and set this to equal new. Now we can take a look at our script. We've got accept in our quests, knowing if our quest is active and checking our inventory for any quest items, as well as loading our quest progress. I'll keep that loading quest progress at the bottom, and in here we'll want to know a public bool for is our quest completed, and we'll pass in a string of a quest ID. We'll use this in our NPC script, so we know when to progress our dialogue for quest completion. So we'll go quest progress, quest equals active quests.find, and passing q equals greater than to make an arrow function, q.questid double equals quest ID. So we can grab the quest from our active quest and then return if our quest is not null, and double ampersands our quest.objectives.true for all, and pass in o equals greater than o dot is completed. So here, if we do have this quest in our active quests, so it's not null, and if this quest's objectives are all completed, we'll return true. Else, if either of these is not true, we'll return false. So cool, our NPC will be able to check is the quest completed, and if it is, we'll have another function for a public void hand in quest. Again, passing in the string of our quest ID. So first we'll try and remove our required items from our inventory, and once those have been removed, we'll remove our quest from our quest log. To remove our items, let's write a new function to keep this tidy, which will make a public bool, which I'll call remove required items from inventory, very long name, and pass in our quest ID. So just like above here in our is quest completed, you can copy and paste this. We want quest progressed, quest equals active quests.find to find our quest. If our quest equals null, we want to return false. So we don't have this quest in our active quests and something has gone wrong. We did find the quest. We'll create a new dictionary of int for our required items, which we can set to equals new. And first we're going to get all our item requirements from our objectives. So we'll go for each quest objective in quest.objectives, and we'll say if objective.type equals objective type collect item, since we only want to do this for when we're collecting items, and int.tryPass objective.objective ID, comma, out int item ID, as our objective ID should be our item ID. Oh, this out int item ID should be inside this try pass. So objective ID, comma, out item ID. So if this objective is collecting the item and we can pass our objective ID out to an int, we can set our required items, square brackets, key to be item ID, and set the value here for our requirement of how many of these items we need to collect to be objective.required amount. So now we know how many of the items we need to collect. For example, we had potion 5 out of 5. So this is going to be stored as 1 being the item ID and 5 being the required amount. Now we know the requirements, we can then verify that we have the items in our inventory. Of our dictionary int item counts equal inventory controller dot instance dot get item counts, as we set up in our last video. Now we can go around our required items with for each of our item in required items and check if our item counts dot get value or default, pass in our key, so that'll be our item dot key, is less than our item dot value. So what we're saying here is what we have in our inventory less than the required amount from our required items. If it is less than, we're going to return false, as we don't have enough items to complete the quest. Otherwise, if this all passes through without returning false, we can remove the required items from the inventory by going for each, var item requirement, in required items, and then we'll go through and remove the items from our inventory. And at the end, return true, saying that this has happened and we've removed the items. Now, since removing these items directly from the inventory is just inventory logic, we should put that in our inventory controller. So back in Unity, on my game controller, I also have my inventory controller script. So I'm going to double click on this, and down the very bottom of our script, just before the bottom brace, I'll add a new public void, remove items from inventory. In here, we're going to want an int for our item ID and an int for the amount to remove. Say we had 6 potions and we want to remove 5 for handing in the quest. We're going to need to know we just want 5 to remove. So then we're going to want to go for each transform, slot transform, in inventory panel dot transform. If our amount to remove is less than or equal to 0, we'll break out of this for each. So it'll go to the next slot, as nothing will need to change, just a catch in case it goes wrong. Then we'll want our slot equals slot transform dot get component slot. And we'll say if slot question mark to make sure we did get one, dot current item, question mark to make sure there is one, dot get component, and pass in item is item, lowercase item, double ampersands, and our item.id is equal to item ID that we passed in. So do we have a current item in our slot? If we do, we'll grab it out by saying is item, and does our item ID match the one that we passed in? So is this the correct item that we want to remove? If it is, then we want to start tracking how many we've removed from our inventory, as we can split our stacks of items into separate stacks and put them in different slots. So we'll want int removed, mathf.min, and pass in amount to remove, comma, item.quantity. So which is the smallest amount? Let's say we have 2 in our slot, but we want to remove 5. The minimum here will be 2, so we've only removed 2 from this slot. Now our item script actually has a function on it called remove from stack, which we can reuse here by passing in removed to know how much we want to remove from our stack. And then we'll set our amount to remove to minus equals removed. So say there was 2 in the stack, we wanted to remove 5. Our amount to remove will now be 3. So now we need to check if our item.quantity is now equal to 0. We want to destroy the slot.current item and set our slot.current item to equals null. This will then continue around checking our slots and removing as many as needed as required by our quest. After this for each, like we were doing in our previous video, we want to rebuild our item counts. So we'll call rebuild item counts at the bottom, which if we remind ourselves by holding down Control and clicking on, you can see this updates our item count cache. We'll invoke inventory changed, which in our quest controller will update any quest progress and update any quest UI. But cool, we got our items removing in our inventory controller. We scroll back down to where we were working on our remove required items for inventory in our quest controller. We can now call this in our for each loop where we want to remove our required items. So we can go inventory controller dot instance dot remove items from inventory and pass in item requirement dot key and item requirement, as that's the item ID and item requirement dot value, which is the amount we want to remove. Cool, so this remove required items from inventory is what we wanted to do when we handed in our quest. So let's call this up in our hand in quest. We'll go and remove required items from inventory and pass in that quest ID. And as this returns a boolean of true only when this was successful, we want to wrap this within an if statement by going if not remove required items from inventory. So if we couldn't get this to remove, then we're going to return out of this function as the quest couldn't be completed and we have some missing items. Else if this does go through and we remove all our required items, we want to remove our quest from our quest log. So once again, we want to do this finding our quest. So quest progress, active quest. I'm going to copy and paste this. You can even copy and paste this from above or below. And then check if our quest does not equal null, so exclamation mark equals, our active quests will dot remove and pass in our quest. And then our quest UI, we can call update quest UI. So that's the code we need for handing in our quest. If you remember at the top, we added a new list so we could save and remember which quest IDs we'd handed in. So with hand-in quest IDs, let's go back to our hand-in function. And at the top, before we remove this quest from our active quests, we can go hand-in quest IDs.add quest ID. Now with these being stored, we can add another new function of a public bool is quest handed in and pass in a string of our quest ID. Here we can simply return hand-in quest IDs dot contains quest ID. So if our quest has been handed in, it'll be within this list and this will return true. If our quest hasn't been handed in, it'll return false. Okay, very cool. Now we've got this all set up, we can get interacting with our NPC to hand in our quest. So let's go back to Unity, and in my scripts folder, I can scroll down and go to my NPC script, double click on this. Let's scroll down and check out what we've got. So down inside Start Dialogue, we've set up already for our quest state completing and have our completed quest dialogue lines. If you haven't done this, check out the previous video. However, we haven't currently got our quest state being set to completed in our function that syncs with our quest data. If we scroll on down, just below, I've got our sync quest state function. You can see we've got a comment here, future update adding completing quest and handing in. Haha, that's what we're about to do. So above this if statement here, we want to say if our quest controller.instance.isQuestCompleted and pass in our quest ID, or with these two double lines, our quest controller.instance.isQuestHandedIn and pass in our quest ID. If either of these are true, we'll set our quest state to equals questState.completed, and we can change this if below to be an else if. Cool, next up we want to be able to hand in the quest at the end of talking to our old man when our quest is completed and when our quest isn't handed in. So it'll be the first time we've talked to him since we've completed the quest and before we've handed it in. So if we scroll on down, we're looking for our end dialogue function. In here, before we close down our dialogue with this current code, we want to say if our quest state equals questState.completed and our quest controller.instance.isQuestHandedIn, and we'll pass in our dialogue data.quest.questID. Then in here, I'll do that on the same line. I don't know why they separated the lines. And in here, we'll handle our quest completion, which we'll write in a new function. So down below, I'll go void handle quest completion. So with our quest controller, we'll be able to call questController.instance.handInQuest. And in fact, let's pass in our quest, as we can grab it once from our dialogue data.quest and pass it in the function here. So then we can just go handInQuest quest.questID, which we can now call up in our end dialog, so dialog data.quest will pass in to our handle quest completion. And before we go back to Unity, when we end our dialog, we want to make sure our quest is completed but not handed in. So we need an exclamation mark in front of this quest controller.instance is quest handed in. So we complete and hand in the quest only when it's not handed in. Cool. Let's go back to Unity and test this out. So in Unity, let's press play. I'll go to our old man, pick up our quest. Thank you all. We've got 0 out of 5 potions and 0 out of 2 heart potions, which I've now picked up in our quest. We can see these are all completed. You can see them in our inventory. Let's split them out into stacks, make it a bit harder for the code. Test it works. Thank you for the potions. Maybe I'll open a shop. How lovely. Let's check. In our inventory, our items are gone and our quest is gone. Amazing. And if we talk to our old man again, he remembers that we gave him the potions and he doesn't try and give us the quest again. However, if we save our game now, close it down and open it back up, our quest is empty and he's asking us to do the quest again. We've already done this. Come on, we're going around in circles. So let's close this one down. And if you remember, in our quest controller script, we have this hand in quest IDs. So we know which quests we've handed in and have been completed. We need to add this to our save controller. So in Unity, on my game controller, I can go to my save controller script, double click on this, and in our save game, you can see we have our save data class. Hold down Control and click on this, where we can see our quest data is being stored. Below here, we can go public list string hand in quest IDs. With this in here, we can now go back to our save controller, where we set up our save data underneath active quests. Oh, I've just realized it's called activate quest. You know what I mean. We can set our hand in quest IDs to equal our quest controller.instance.hand in quest IDs. And then very easy, down in our load game, underneath our quest controller instance, we can go quest controller.instance.hand in quest IDs equals save data.hand in quest IDs. Save it out, load it in. Very easy. So cool, now let's test it out. Let's press play in Unity. I'll talk to our old man, get our quest. Thank you, I knew you'd help. Yes, 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 I've said it many times now. Got all my items, they're in my inventory. Talk to our old man. Thank you for the potions. Maybe I'll open a shop. Very nice. Inventory is empty. Quest log is empty. Let's save our game. Close it down. Open it back up. Talk to our old man. And hopefully he won't give us a quest. Thank you for the potion. Maybe I'll open a shop. He's remembered that we completed the quest. Very cool. Now I know our items are all on the floor and they keep appearing here. These are just for testing. These kind of items you'd only have, you know, popping out of a chest or dropping from an enemy or a bush that you destroy or a pot or something. They're supposed to be disappearable items. I'm just using them as a test. Sorry if it's confusing. If you want the items to disappear, you can set them up the same as we did for our chests, where as I've opened our chest, if I save my game, close it down and open it again, we'll see that our chest has stayed open. So you can save individual item states in that way. But for my game, I'm leaving these so that they keep coming back. But anyway, wait a minute, we did all that work for that old man and he didn't give us anything. What's the point of completing quests if you don't get anything? In our next video, we'll take a look at quest rewards. But cool, I hope you enjoyed. Like and subscribe so you don't miss out on the future ones. If there are any scripts you're missing out on, or these are too long to catch up with, you can join our Patreon and grab every single script I've ever written on the channel. Or you can grab this whole project, the whole top-down template with all finished features and future updates for free. So check it out. Otherwise, I'll see you in the next one. Bye! By the end of this video, when we complete our quest, okay, I need 2 more heart potions, haha, they're right here on the floor, how handy, and hand our quest back into our NPC. Thank you for the potions. Maybe I'll open a shop. Foreshadowing. When our dialogue closes, we'll get a reward. He gave me a heart potion and 2 coins. How exciting. Let's take a look. So we're going to want our NPC to give us a reward when we hand in our quest. If I go to my scripts folder, and down to my NPC script, at the very bottom of our NPC script, we have our handle quest completion function. When we hand in our quest and we do handle quest completion, I want him to give us a reward. To know what reward we get for our quest, we're going to want to add this to our quest class to customize in our quest scriptable object. So on this quest class here, you can hold down Control and click on this to open up our quest script. I'm going to scroll down to the very bottom, outside the brace, and add a new system.serializable for our public class quest reward. Outside these braces again, I'm going to write a public enum called reward type, as we may want to get an item. Maybe we'll get some gold, some experience, level your character up, or maybe you get a custom reward, maybe it's a cutscene or something like that. We'll add these in now, so it's set up for future. But for this tutorial, we'll be having item rewards as we've got those set up. So let's add to our quest reward a public reward type, which we can call type, a public int for our reward ID, same as our objective ID. This would be like our item ID. Maybe it will be an experience type ID or a cutscene ID if it's your custom cutscene reward. Just something flexible so you know what we're giving. A public int for an amount. We'll set this to a default of 1, and that's all we'll leave in our quest reward for now. Back up the top of our quest script, we'll add a public list for our quest reward, which I'll call quest rewards. We'll make it a list in case you want multiple rewards for one quest. Maybe you get experience, gold, and an item. So cool with our quest reward details. Let's go set this up in our scriptable object in Unity. So back in Unity, in my assets folder, I have my collect potions quest. We will put these in folders, don't worry. I know it looks messy for now. But anyway, on our quest scriptable object, we can see our quest rewards down here. We can click the plus on this list to add a new element, open this up, and then pick our type. So is it going to be an item, gold, experience, or something custom? I'm going to keep it as an item for now. The reward ID. So what ID matches with your item ID? Let's say number 2, he gets a heart potion. And how many is he going to be given? Let's say he gives you back 5 heart potions. You can make it so it gives them multiple rewards. Let's say it gives him another item. We'll do it item number 1, which is our green potion. And we'll say he gives you 1 green potion back. Kind of weird, you give him potions and he gives you potions back. In fact, let's make a new item prefab. So in my prefabs, I'm going to drag our item into the game and rename this coin. I'll scroll down and change our ID and I'll name it coin. Now all I have to do is change our icon. Since it's a coin, I'll drag in coin from our Ninja Adventure asset pack, which is inside Ninja Adventure items treasure. I'll drag it into our sprites folder and quickly set this up. Then on our coin item, I'll just drag in this icon into both image and sprite renderer. So in our game, we can now see we've got a coin item. I'll go back to my prefabs folder, drag our coin into our prefabs folder and make this a prefab variant. Cool, so now back on my assets, I'll go to my collect potion and I'll make the reward ID 99, and we'll say we get 5 coins. Cool. Next up, to handle receiving the rewards, I'm going to create a new controller on our game controller object. So I'll go add component, new script, and we'll add a rewards controller. By having the rewards separated out like this, you can have anything call this. So maybe you have a cutscene that wants to have a reward at the end, or walking up to maybe a bush and you talk to it and you find an item inside. Something that you want to go directly into your inventory and not pop out like our chest. So I'll double click on this. We're not going to want our start and update, but at the top, I'm going to make this a public static rewards controller instance. Then go brackets get semicolon private set. Now we'll do our instance pattern where we go if instance equals null, instance equals this, else destroy game object. Making this instance makes sure this script is accessible from all our other scripts. Next we'll want a public void give quest reward where we'll pass in our quest. First we'll check if our quest, question mark to check it's not null, dot quest rewards equals null, then we'll return. As there were no quest rewards added on this quest, then we'll go for each var reward in quest.quest rewards, do a switch case and say reward.type, and we'll want a case for reward type dot item. So if our case is of item, we'll want to give an item reward. You can then go through adding cases for all our other types like this, but for now we'll just do our item rewards. So down below, let's write a new function for when we give an item reward. Go in public void give item reward, and passing in int item ID and int amount. So up in this case, we'll call give item reward, then we can pass in the reward dot reward ID, comma, reward dot amount. And we saw how we just set those up in our scriptable object. Cool, so now in give item reward, we can go var item prefab equals find object by type, item dictionary, question mark to make sure we've found our item dictionary, dot get item prefab, and pass in our item ID. If our item prefab equals null, we'll return, as we didn't find the item to reward. Otherwise, we'll go for int I equals 0, I is less than amount, and I++. So for every item we want to reward, we'll go inventory controller, dot instance, dot add item, and pass in our item prefab. Now this add item returns a boolean. If it's true, our item was successfully added, and if it's false, our inventory may have been full, so we couldn't add the item. So if this does return false and our inventory is full, let's drop our item. So let's go if exclamation mark inventory controller add item, then say game object drop item equals instantiate item prefab, comma, transform dot position plus vector free dot down, which will just -1 to our current transform position, then pass in quaternion dot identity, which is just the rotation of the item. We just want it to be the normal one. Then with drop item, we can go dot get component bounce effect dot start bounce. So our item does that nice little bounce when it's dropped. Now else, if our item is added, I want to show the notification pop-up of when we pick up our items. See, when we pick up our item, we get these little notifications in the bottom left of our screen. This is only done on pickup. We're not triggering on pickup as it's being added directly into our inventory. So to show the pop-up for this item, back in Unity, in our scripts folder, I'm going to go to our item script. Double click on this, and in our item script we do have the function we want already called pickup, which just shows our item being picked up in that notification. I want to rename this, but first I'm going to check where this is referenced. Up above your function you can see this one reference. You can click on this and then see this is referenced inside our player item collector. I can double click on this, and first I'm going to rename it here. So I'm going to rename this to be show pop-up. So that's on player item collector. It used to be pickup. Now I'm going to make it item.showPopup, as that's more descriptive of our function. Back on our item script, I'm going to rename this to be show pop-up. You can see this is again referenced by a player item collector, so that'll still work. So cool, we can use this in our rewards controller. Let's go back to our rewards controller script. And all we have to do to show our pop-up is go item prefab dot get component item dot show pop-up. So now we'll see our items pop up on that left notification bar. Cool, now we have this set up, we'll be able to call give quest reward in our NPC script. So let's go to our NPC script where we handle our quest completion. We can now call rewards controller dot instance dot give quest reward and pass in our quest. And guess what? That's all you need. So let's go to Unity. I'm going to go to my quest again and actually lessen the amount of rewards we get. I'll get 1 heart potion, and let's say we get 2 coins, because my notification bar doesn't handle that many items being entered there. So let's press play. Thank you for the potions. Maybe I'll open a shop. And now when we close this dialogue, oh, I got 1 heart potion, but I didn't get my coins. Down in the console, you can see our item ID was not found in our dictionary. Good thing we got that debug log. Under my game controller, you can see on our item dictionary, we set up each of our items so they can be accessed anywhere in our game. Let's add another element to our heart item prefabs and drag in our coin. So cool, it was just missing in our item dictionary. Let's press play. Haha, oh, 99 is not found in the dictionary. Aha, also, we set our item ID to be 99, but ID points to order of our item dictionary, so this will always be number 3. So on our quest, we need to go back and change our item reward to be number 3 instead of 99. Cool, let's test this out. So empty quest log. Yes, I can help. Thanks, I knew you'd help. Pick up our potions. Go to our old man again. Thank you. Maybe I'll open a shop. Ready? Rewards! 2 coins and 1 heart potion. Hooray! We could take a look at them in our inventory, and here they all are. Very nice. We now get quest rewards, and we've got coins in our game. What do you do with coins? Is this a shop over here? Maybe I'll go inside this building and check if I can buy something. Huh? I can't go inside this building. A great transition, I know. In our next game, we're going to be adding entering buildings so we can transition between indoor and outdoor. How exciting! Like and subscribe so you don't miss out. And as always, if you want to catch up on your scripts, a very easy way of doing it is joining our Patreon, where you can get all our code files from the whole channel. Very cheap for everything I've ever done. Or if you don't want to put this all together, you can grab the full template on itch.io. So I'll link these both below. Otherwise, I'll see you in the next one. Bye! By the end of this video, when we walk on inside our building, we'll be able to actually walk on inside and enter the interior, a whole new place in our map. Whoa, that's so cool. It's like we teleported. We can also go back outside, of course. Otherwise, that'll be a very strange game. So now we have even more places to explore. But cool, let's get into some interiors. That was meant to be a joke on like into and inside and interiors. I don't know. Let's go. Cool, so first of all, let's draw out the interior of our building here. I'm going to go to the Ninja Adventure Asset Pack, go inside Backgrounds, Tile Sets, and then Interior to grab some new tile sets to use in our game. I'm going to drag in Tile Set Interior Floor and Tile Set Wall Simple. So I'll just drag those on into our Assets folder. Then I'll select both of these and drag them into our Tile Sets folder. You can hold down Shift and click on both of these to select them both at once, and we can set them up in the inspector. So Sprite Mode will set to multiple, Pixels per unit will make 16, Filter mode to be point no filter, and compression to be none. Click apply, then individually we'll select these, go to Sprite Editor, click slice, grid by cell size, and go 16 by 16. Click slice and then click apply. So now all our tiles are cut out into 16 by 16 pieces. Close this down and do it for the walls. So Sprite Editor, click slice, grid by cell size 16 by 16, slice and apply. Cool, now these are all sliced up. We're going to want to make a new palette for our interior. So let's go to Window, 2D, Tile Palette. This is popped out over in front of our assets. I'm just going to drag that Tile Palette tab next to our inspector. And here you can see our original houses one. I'm going to click on this drop down where it says houses and click Create New Palette. I'll name this Interior, Crocodile Alligator. Click Create. And in our Tile Sets folder, I'm going to right click and do a new folder, which I'll call Interior Palette. I'll double click on this and then click Select Folder. So now I'm going to drag in from our assets that tile set wall into the palette, which then pops up our folder selection again. So then we can click Interior Palette, Select Folder, then our tiles will load in. Now we don't need a new palette for the flooring as well. We can scroll out on this tile palette. You can hold down your middle mouse button to drag this around as well, and simply drag just below your flooring too. Select the Interior Palette folder again, and now our flooring's loaded in. Cool, so now we're going to want to paint our interior somewhere that we won't see on our main map. So I'm going to scroll out on our scene view, and since we can't exit down the bottom here, I'm going to draw our interiors just below down here. We should never be able to see outside our camera bounds. You can draw yours out anywhere on your scene, but cool, I'm going to pick this little square here and then make sure we select our correct layers. So for the ground, let's draw out our floor first. A cool thing you can do with patterns like this is drag and select the whole thing, and with the paintbrush tool selected, you can just paste that straight onto your grid. And I'll add a little section down the bottom here for our doorway. So our player will be able to walk through this bit. Otherwise, all the walls are going to be on our collision layer. So make sure you select your collision layer at the top, and then we can draw out our walls. This palette also comes with a little window. So we could switch to our decor layer and paint some windows on top of our walls. You can rotate your tiles by pressing the square brackets. So we could rotate this and even have windows on the side of our walls. Cool, you can of course decorate this as much as you want. Whatever you want to do here is of course up to you. But cool, I'll click back on our inspector so we can continue setting up our room. So of course our current areas have boundaries on them. Under my map bounds, you can see we've got T1 and F1. They each have polygon colliders, mapping out the space of our camera boundary, and a space that our player cannot leave, unless of course he goes through a waypoint. Each one of these also have waypoints inside them. In our town, T1, we have a waypoint going up to the forest, which is my F1 waypoint, since this points to forest number 1. And in our forest, we have a T1 waypoint, which points back down into our town. So inside our map bounds, let's create a new game object, which of course you can name what you like. You can say, yep, this is in town number 1 since it's this shop, and then go underscore I1 to say interior 1, B1 for building 1, or you could simply just go B1, this is building number 1. Whatever makes most sense in your mind. I think I'll go for T1 B1. Although we can't see this game object, it is in our scene. In our inspector at the top, you can select a little icon so you can see where this is in our game. And you can see that doesn't appear, it won't appear until you click this little ball with the dots on it. It toggles the view of our gizmos. So I'm going to drag my orange little diamond down to the middle of our interior so we can set up this game object. So like we know, we're going to need a polygon collider 2D. I'll open up the points and set the size to be 4 since we want this to be a square. Then click Edit Collider and drag these points out to fit around our building's interior. Cool, now the next bit we need is to create a waypoint for both entering the building, so the one in the town, and exiting the building, so one inside our shop, so we can leave the shop and get back outside. We'll go back to our town for now. I'll turn off gizmos for a bit, and we can add another waypoint under our T1. So let's go create empty T1 underscore B1 underscore waypoint, and I'll drag this over to be close to our door. We're going to want to add a component to be a box collider 2D, which we can click the Edit Collider button and line this up for where you want it to be. So when our player hits their head on this, they'll enter the building. And we're also going to want to tick this to be is trigger. The next thing we want, as we can see on our F1 waypoint, is our map transition script. So if we go to T1 B1 waypoint, click Add Component and search for our map transition script, we can add this on, and we can see we need a map boundary, so we can drag in our T1 B1 since that's where we want to go to. And for direction, we don't really have something that'll move us to somewhere completely across the map. So we're going to need to go into our map transition script. Let's double click on this. So at the top, as well as knowing the direction, we're also going to want to know what point in our map we want to move to, since we're basically teleporting across the map. I'm going to duplicate this line for our direction, change direction to be transform, and change its name to be teleport target position. So we can pass in a little transform game object that'll tell us where we want to teleport to. Next in our direction enum, at the end I'm going to go comma, teleport. So we can see in this script, there is a function called update player position. Normally we use a switch statement and add or minus from our current position in the direction we want to move, depending on where our waypoint was. Instead, at the very top, we want to say if our direction equals direction.teleport, then our player.transform.position will now equal our teleport target position.position. And if we are teleporting, we can then just return out. And guess what? That's all we need in this script. So let's go back to Unity, and on our T1 B1 waypoint, let's set our direction to be teleport. And now we want to set a transform for this teleport to point to. So let's scroll back out to our interior, and on my T1 B1 waypoint, I'm going to right click on this, create an empty game object, and call it our teleport point. Let's turn on our gizmos and pick a nice little green diamond, sure. If I zoom out, this is over by our waypoint. We want to say where it wants to teleport to, which is in our interior. So when our player teleports to here, where do you want them to go? I'll set it just in front of the front door so we don't collide and exit again. We want to be just inside. Cool, so if we click on this waypoint, we can now drag in this teleport point into this transform slot. Now we need to do the same for exiting the shop. So if you like, you can copy this T1 B1 waypoint, paste it and drag it under our T1 B1 game object. Of course, this is positioned up in our building, so let's drag this waypoint down, as this is the one we want to exit. I'll rename this to T1 waypoint, since we're exiting to T1. Edit the box collider so it fills this doorway. We want to teleport, and then we want to set our teleport point. You can double click on this if you've lost it in your scene. Mine's gone way down. And we can drag this now to be outside our building. So let's zoom on in. This green diamond is where we'll appear when we exit the building. I'll do it just down in this little square. Cool, and I just want to make sure that is pointing to the right teleport point. So I'll drag the teleport point from our waypoint into this transform slot. Very nice. Oh, and I've just noticed as I've clicked on this T1B1 that we set up, our Polygon Collider 2D is not set to is trigger. We need to make sure we tick this is trigger box so we can walk around inside this collider. Otherwise, we're going to bump our head on it and we won't be able to move. So cool, now this is all set up. Let's press play. Walk on over to our building. Walk inside. Okay, when I first entered, you may have seen me moving bumpy around there and I quickly panicked. What was happening was our camera was bumping on the edges of our collider since it was so tight and messing up. So for your interiors, you can make your polygon colliders much bigger since this is the space we want our camera to be able to move around in. If I play while focused, you can see our camera now has space to move around and slide smoothly. Very nice. You can see our background is also blue, while the edges of our interior are black. This is the background color of our main camera. So if you change this, you can see it changes the background. Make sure you unplay when you change this. I'm going to use the little eyedropper on the side and select that dark grey color that's on the outside of our interior walls, so that when we press play and walk over to our building, walk on inside, our background is now matching. Our camera is smoothly sliding around, and if we walk outside, oh, it breaks. Whoops, we missed something. On our T1 waypoint, we copied and pasted this and we didn't change our map boundary. So we were still pointing to go to the interior. This waypoint wants to point and set us back to our town. So we need this map boundary to be T1, since that's what we're trying to teleport to. Whoopsie daisy. Let's press play again. Go inside our building. Hooray. Nice and smooth, nice background. Very cool, colliding with things. I can walk behind here. Cute. Then walk outside. And we're outside our building! Hooray! How exciting! We now have interiors. Now you may think when we enter and exit a building, it's a bit wobbly. You know, the camera goes a bit weird, like whoa, as it's processing the movement to move from one boundary to the other. It'll be kind of cool to add a little transition while our scene sets itself up, like a little fade to black. I wonder what we'll do in the next video. In the next video, which I'll show you in my little test project where my frog moves much slower, when we enter a building, we'll fade to black and then exit, fading again. So you get this nice seamless transition instead of seeing the weird movement of the camera. No more spoilers. Be sure to like and subscribe so you don't miss out. To catch up on the scripts and get every piece of code I've ever written for this channel, you can join our Patreon, or you can grab this whole template set up for you with all finished features and all future updates. So check it out. Otherwise, I'll see you in the next one. Bye! By the end of this video, when we walk inside our buildings, we'll now have a nice fade to black and fade back out, so our game feels smoother and more polished. We'll pause our player's movement as he walks between transitions and have it fully customizable so you can use this in any of your games. Cool, let's check it out. So first of all, we'll want a nice black box to be able to transition to. I'm going to go to my UI canvas, which in my hierarchy is just called UI. I'll rename this to be UI canvas, so when I say I'm going to my canvas, you know what I'm talking about. If you haven't done our previous tutorials, here are my canvas settings. My render mode is screen space overlay, and our scale mode is scale with screen size, which I set to reference our target reference down here in our game. So cool, back in the hierarchy, if I open up our UI canvas, you can see we've got all our UI objects. On our UI canvas, I'm going to right click and go UI panel, and I'll name this fade panel, as this is what we're going to be fading to for our transition. On the image, we can set this color to be black, and as it's semi-transparent right now, we can go to the alpha, which is the A down here, drag this all the way so it's fully opaque. Now to target this alpha easier, for it to fade in and out, instead of doing it through the image, we're going to scroll down and add a new component called a canvas group. On here, we're going to untick block raycasts, so this panel doesn't block any of our UI. And on here you can see there's an alpha option. This is the one we're going to use to go between 1 for fully opaque and 0 for fully transparent. Cool, that's the UI set up. We can now get the script ready. So on our UI canvas, if I collapse these, since this is another script that handles UI controls, I'm going to add our script on here and go new script, screen fader. We can double click on this to open it up. And in here we don't need our start or update, so we can remove those. And first of all, at the top, I'm going to add a public static screen fader instance which by making this static means we'll be able to call this script from any other script without passing it in by making it an instance. We can set this instance up quickly inside an awake by going if instance equals null, instance equals this, else destroy game object. This just makes sure we only have one screen fader in our game so the instances don't get confused. Cool, next back up the top, we'll want a serialized field to make this accessible in our inspector of our canvas group, which we'll call canvas group, and a serialized field for our float fade duration, which we'll set to equal 0.5 f. The f makes this a float, so we can use decimals for our transition. Cool, now we're going to need an async task called fade, and we'll pass in a float called target transparency. To get rid of these red underlines, hover over task, show potential fixes, and use system threading tasks. The reason this is going to be asynchronous is we're going to wait for our screen to slowly fade from black to transparent and transparent to black. So first let's create a float named start to equal our canvas group dot alpha, comma, to create another float, t equals 0. T just stands for time. Now we'll go while t is less than fade duration, t plus equals time dot delta time, then canvas group dot alpha equals math f dot lerp, and if you haven't used lerp before, as you can see here, this will interlope between a and b by t, which you'll see a will be our start, b will be our target transparency, and t will be our t divided by fade duration. We'll set this to await task.yield, which will simply just give our program a bit of time to fade to this target transparency. And at the very end, just to make sure that the alpha does set to what we want, we'll set alpha to equal target transparency. These two little lines are just backups to make sure this works smoothly. Now to keep the logic all inside the screen fader, let's create a public async task for our fade out, where we'll await fade and pass in 1 to set our target transparency to be opaque, which means it'll fade to black. Then we can copy this function, paste it down below, call this one fade in, as we're fading back into our game, and set this to be 0 to fade to transparent. If these names are confusing, you can name them whatever you want, fade to black or fade to transparent. That's what I had it before. I switched it back to fade out and fade in as it made sense in my head. But cool, for now this is all we're gonna need to get a fade in and out working. I'm gonna add a bit more later on to fix a little bug in our game, but I'll show you that in a bit. So back in Unity, on our UI canvas, we're gonna need to pass in our canvas group, which is on our fade panel, so let's drag the fade panel into our canvas group. And for our fade duration, we'll leave this at 0.5. Now we're going to need to call this fade when we want it to fade in and out. As you know, we want that to happen when we go inside our building, which happens for me inside my map bounds, inside T1. I can check one of my waypoints. So when I hit this waypoint, I want it to fade so I can transition to the next map. That happens in our script map transition. So I'm going to double click on map transition to open it up. Inside our script, when we hit this waypoint on the onTrigger Enter2D, we update our map boundary and update our player position. Below this onTrigger Enter2D, we can write a new function of an async void fade transition. And we'll pass in the game object of our player. So we can do all our transitioning inside this new function. I'm going to grab where we update our bounding shape and our update player position. I'll cut this from this section of our script and paste it down in our fade transition. For update player position, let's pass in our player. So now we can wrap around this updating with our await screen fader .instance .fade out, which will fade us out to black. Then, once these have updated, we can await screen fader .instance .fade in. Cool, so up where we had this before in our onTrigger Enter2D, we can call fade transition and pass in our collision.game object. Since we've checked that that's our player, and we need our player game object in here. So cool, let's go back to Unity and test this out. When I walk on over to our building and walk inside, we can see it fades to black and we enter back in. If I walk out, it does the same, fades to black and comes back. It goes a bit fast, so I'll set our fade duration to be 1, so it goes a bit slower and we can test this out. We walk on over, walk in, nice slow fade, and we transition over. Now, I talked about this in the previous video, but you can see as we walk in, the screen kind of wobbles and snaps to our player. Doesn't look smooth. I was so confused about this trying to figure it out, but luckily I figured it out and you get to see the answer instantly. This might be happening for you, might not, but for me it's because on our Cinemachine camera, on the body, we use dampening on our X, Y, and Z by 1. So as our player gets teleported, our camera is a bit slow to catch up because we have dampening on, so it doesn't instantly lock to our player, it drags over and looks a bit weird. To fix this, I'm going to go back to our UI canvas and open up our screen fader script. And in here I'm going to need a serialized field to pass in our Cinemachine virtual camera, which I'll need to hover over, show potential fixes, and using Cinemachine. I'll call this our VCam because it's a virtual camera. And then down below we can have some private fields. One for our Cinemachine framing transposer, which I'll just call transposer, and one of our vector-free original damping. In our await, we can set our transposer to equal our VCam dot get Cinemachine component and pass in the Cinemachine framing transposer. And in our original dampening, we can set this to be a new vector-free, pass in our transposer dot m underscore x dampening, comma, I'm just going to copy and paste this so it's easy, but it's our transposer for our Y dampening, and comma, transposer dot Z dampening. Cool, so now down the bottom, I'm going to write a new function of a void set dampening, or damping, and we'll want to pass in a vector free, which I'll just call D for dampening. We'll check if we don't have a transposer, so exclamation mark transposer will return, so this doesn't break. In case you don't use a transposer and haven't passed one in, the script will still work. Then we'll set our transposer x dampening to equal d.x, and now I'm going to press Ctrl D twice to duplicate these and go down and set the y to equal y and the z to equal z. Cool. Now to use this in our fade out function, where we're fading to black, I'm going to set the dampening to be vector-free.0 to turn off the dampening of our camera. That way, when we move our player, our camera will immediately snap to our player. And as you might have guessed, in our fade in, we want to set dampening back to our original dampening. Very cool. Let's test this out in Unity. So we've got our VCam that we need to drag in, and let's drag our Cinemachine camera into this VCam slot. Now we can press play and test this. Let's walk on over, walk inside, and we immediately appear. We don't have that weird draggy across the screen. Let's try it outside. There we go. Very nice. Now there's one more problem I want to show you. When we walk on inside, if I hold down forwards, we keep walking. So as you can see, our player can move around even past when I'm exiting the building. He just walks off into the darkness there. So while we're transitioning, let's pause our player so he can't move. This will also be handy so our player can't move when we open our inventory up or when we talk to our NPCs. So let's go to our player and go to player movement. And on our player movement script, I'll double click on this. And to get him to stop moving, while we're paused, we'll go if pause controller dot is game paused. Then we'll check if our RB dot velocity does not equal vector2.0. So he is still moving, but we'll set his RB velocity to equals vector2.0 to stop him from physically moving. And as you can see in our move function down here, when our context is cancelled, so when we do stop moving, we need to stop our animations. We can copy these out to a new function of a void stop movement animations and paste in these. So we can replace this now down in our move, and we can also call this up where our game is paused. I'm actually going to move this function down below because that's tidier in my brain. Then outside of this check for if we're moving or not, we can just call return, as we don't want to continue and start moving again. So cool. This should pause our player now. Let's go back to Unity and test. When I open my inventory, okay, you can't tell, but I can't move. If I talk to my NPC, I can't move him. So cool, our player pausing is working. So now we need to pause while we're fading. I'm going to do this in our map transition script. So back in our script, inside fade transition, at the very top, we can go pause controller dot set pause to be true. And then at the bottom, once we're done fading, we can set pause to be false. Very cool, very easy. Let's go test this out. Cool, so now when we walk on inside our building, I'm going to hold down forwards, it waits, and then we can walk. Let's go outside, I'll hold down, it waits, and now we can move. Because our fade duration is 1 second, it looks a little slow and laggy. So I'll go back to our canvas and set the fade duration back to 0.5, press play to test this again. Otherwise it looks like my game's breaking a bit. But let's walk on inside. Yay, what a nice smooth transition. We have it so it pauses our NPC movement. Of course you can customize this however you want, by editing our scripts to fit the game and feel that you like. But cool, we now have a nice fade between any of our transitions. To grab every single script I've ever made, you can go check out our Patreon to get absolutely everything. Or to get this whole project for yourself, you can check out this template, which includes all finished features, and you'll get all future updates for free. So check it out. If not, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, we're going to have our shop UI all set up and ready for our future videos, where we'll be able to buy and sell items. This is my test project, so by the end of this video, it'll actually look something like this, where our UI is all ready for our future scripts. But cool, let's get started. So first of all, I'm going to go to my UI canvas and open this up. If we take a look at our menu by enabling that and then turn on our inventory page, I'm actually going to reuse this to create our shop menu. So I'm going to click on our menu object and hold down Control D. So now we've got a second menu. I'll disable this first one and rename this shop menu. Inside here, I won't need all these tabs. I'm just going to keep this middle one of the Quest tab, which I'll drag on out to the top of our hierarchy and then delete all these other tabs. I'll rename this title tab and change the text to say shop. Next, inside our pages, we're not going to need any of these, but we can reuse this inventory page. So I'll drag that to the top and delete these pages. Also, I'll rename this inventory page to be shop content. We'll remove this grid layout group and we'll add a horizontal layout group, which on control child size will tick width and height, and a content size fitter, so that when we add our player inventory area and our shop inventory area, they'll fit horizontally next to each other and expand to fit this area. So let's do that by right-clicking on shop content and going create empty. I'll name this player inventory area, and if we duplicate this out and name this shop inventory area, you can see we've got two equal size boxes. Also in here, let's add a UI text, which I'll just call the player inventory title. We'll get this to say players inventory, expand this out, align it to the middle, set it to black, and I'll drag in our custom font. Next, I'm going to right click and go UI scroll view, which if we open up, we can delete this scroll bar horizontal, open up our viewport, and on our content is where we're going to right click, create empty, and this will be our player inventory grid. Cool, so you can use another vertical layout group to organize these, or you can manually place them out. I'm just going to manually change these. You can follow along with the settings I've got here, but it's entirely up to you. So on my scroll view, I'm just positioning this down below my player inventory and setting my player inventory grid to be similar, but as you can see, it spills off the edge here. This is so as you scroll, any content below, which will be our slots in our game, will be visible once we scroll. To see what I mean, let's make our slots. So let's go inside our prefabs, and we can use our existing slot that we use for our inventory. Copy and paste this. I'll right click and rename this shop slot. On here we can remove the existing slot script, as we're going to write a new one of those later on. And now if we drag this into our player inventory grid and duplicate this, obviously these just stack on top of each other because we haven't set up our grid yet. Let's go to our player inventory grid, add a new component of a grid layout group. Let's set the padding to be left 25, top 50, and the spacing between them to be 50 and 50. Now in my inventory, I can have 24 slots, I believe. Whoops, I typed 59 instead of 50, spacing 50 and 50 on the Y and X. Just as an example, you can see 25 slots actually fit nicely within this scroll view content. So if I press play to show you, you can see all our slots are here, and as we scroll down, we can see more slots appearing. In our script later, these will dynamically appear, but if you want, you can have them all displaying all the time. It's up to you, but cool. Let's continue with our shop slot. For our items, we're also going to want a price, so let's right click and go UI, text, and I'll call this price text. I'll position this to 80 and minus 75. Change our text to a number so we can test the sizing out for now. I'll change the font size to be 28, and I'll change the color to be black. If you like, you can bring this width in so you know it won't go past here. Next, I'm going to right click and go UI image and call this coin icon, so we can add a little coin picture. In my sprites, I've currently got a coin ready to go. This is from our Ninja Adventure asset pack, so you can check that out, linked in the description if you haven't got it. I'll drag this into our image slot. I'll set the width and height to be 25 by 25, X position to be minus 35, and Y position to be minus 70. Okay, these don't look perfectly aligned, so I'm just going to go to my text, line these images up, and set it to be in the middle of the alignment. So now they are aligned. Cool, as we've amended this prefab, we need to click on this drop down over here that says overrides and click apply all. So this is added to all of our prefabs. And now with this in our player inventory all set up, we can actually reuse all of this in our shop inventory area. So I'm going to copy both of these and paste as child in our shop inventory area. I'll rename these to say shop inventory title, and inside our scroll view viewport content, I'll rename this to be shop inventory grid and change our text to be shop inventory. Of course, feel free to mess around with the positioning. It's all up to you. But cool, that's got our shop areas done. Next, I'm going to right click and add UI text for our player money text. And I'll stick this up -190 and 212. I'll set the alignment to be to the right. We'll set the text to be gold, 100 just to test it out. Set the color to be black, and I'll throw in our custom font again. This text looks a bit big, so I might set it to 28. In fact, instead of having the text gold, we can do the same as we did for our labels. I'll go inside my grid, inside one of my slots, and copy this coin icon and paste it out as a child to our text. And now we have a nice icon to show our players money as well. Cool, and one more thing, just helps with testing. I'm going to add a UI button for a close button. I'll just make it red, make it 50 by 50, and I'll edit the text to be a nice big X. Cool, I'll position this at the top and scroll down to on click, where I'll click the plus, drag in shop menu, click on the no function drop down, and on game object, we'll click set active and leave this unticked. So when you click this close button, it'll close our little menu down. That way I can press play. I can test out the scrolling of our inventories. Looks like it's all working, and I can close it down and keep on playing. Very cool. To get us set up for the next video, let's go into our prefabs folder, go to our shop slot, and add a new component of a new script for our shop slot. We'll double click on this to open it up, and in here we won't need our start or update, so we can delete those, but we will want a public game object for our current item, a public int for our item price, a public TMP underscore text, which if we hover over show potential fixes, and using TMP Pro for our price text, and a public bool for is shop slot, which will set to a default of true. So in our shop menu, we'll set true to when it's on the shop side, so we know we're buying stuff, and false when we're on the player side, so we know we're selling stuff. Next we'll want an awake, where we'll check if exclamation mark to say we don't have our price text, so is our price text null. Then we'll set our price text to equal transform.find price text, as this is what I've named the component that holds our price text in my Unity game. Make sure this is whatever you've named your text object on your shop slot. .get component and pass in TMP underscore text. Then we'll go public void update price display, where we'll say if price text to check if it's not null, and current item to check if that's not null. Then price text.text equals item price dot toString. And finally we'll want a public void set item game object item comma int price. We'll set current item to equal item, item price to equal price, and then we'll call update price display. So when we're loading up our shop, we'll be able to load in and set items into our shop slots by passing in these details from our outside shop controller. But where are we going to get these price fields from? Well, if we go back to Unity, on my prefabs, in our prefab folder, we have our item prefabs. On all of our item prefabs, we have an item script. This has its details like its ID, name, and quantity. If we double click on this, inside here, we're going to add some new fields for our shop. So we're going to want a public int for buy price, which I'll set to a default of 10, and then a public float for our sell price multiplier, which I'll set to equal a default of 0.5f. So when you sell to a shop, they're going to buy it for 50% of what you'd be able to buy it for. To keep this multiplier between the range of 0 and 1, what you can do is go range 0, 1. This just makes sure this stays safe. And you can't sell an item for more than it's worth to buy, because then you've got infinite money in your game. Next, we're also going to want a new function, which I'll do below our awake, of a public int get sell price. Here we'll return our mathf dot round to int, so we can get a whole number of our buy price times our sell price multiplier. This will be handy when we grab this in our shop controller in the next video. But cool. For now, we'll keep it simple with that, so our videos don't get too long and hectic. In the next video, we'll get real scripty with it and set up our shop controller. To grab the scripts from our videos and all others I've ever written on this whole channel, you can join my Patreon, which I'll link below. Or to get this whole template for yourself and all future updates, you can check it out on itch.io, or it's also sold on Patreon too, so you can take a look. Otherwise, thank you for watching, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, when we walk up to our shop NPC, we'll see our shop stock appearing in our shop UI, as well as our player's inventory. But we'll get the buying and selling done in the next video, as there's a lot of code for this one. Let's check it out. Cool, so first of all, I'm going to go to my game controller. On here, we've got lots of different controller scripts. We're going to add a new script for our currency controller, which we can use to add money to our currency amount and also take away from it. So let's double click on this. And in here we won't need the start and update, so let's delete those. But we will want a public static currency controller instance, as well as a serialized field of a private int starting gold, which I'll set to equal 100. This is how much gold you'll begin with at a new game. A private int for player gold, which will be our player's current gold. And a public event action, which we'll want to pass in an int, and to get this to work we need to hover over show potential fixes and using system, and I'll call this on gold changed. So whenever our gold is changed in our game, either by selling or buying or maybe a quest reward, we can trigger this and have other things subscribed to it so that our currency text gets updated where it needs to be. Next we'll want to use Unity's awake to say if our instance is not null and our instance is not this, we want to destroy that game object, else we want to set this instance up to be this game object so that we only ever have one that is statically used across our whole game, and we'll set our player gold to equal our starting gold. Now we can write a simple get method with a public int get gold. You do brackets, arrow function, so equals and then greater than player gold, so we can get this amount from outside the script. Also on a public bool, and we'll pass in an int for the amount, where we'll say if player gold is greater than or equal to the amount, player gold minus equals the amount, and then we can call on gold changed question mark to make sure this has been set, dot invoke player gold. So we're going to be using this to update the text in our shop. When we invoke this, we pass in how much current gold we have so that we can add that to the text on our UI. Now if we have enough money, we're going to return true to say our player gold was more than the amount. So we was able to spend our money, return true. Otherwise, if our player gold was not greater than or equal to the amount, we didn't have enough money, so we're going to return false. Next, when we sell an item, we're going to want a public void for add gold of the int amount, and opposite of our other one, we want this to plus equals the amount on our player gold, and copy this from above, we want our on gold changed dot invoke player gold again. And finally, for when we load our game, we're going to want a public void for set gold. Once again, our int amount. Here we'll just set player gold equal to the amount and copy and paste this from the other functions once again. Cool, that's our currency controller all done. Back in Unity, we're now going to add our shop controller. I'm actually going to add this as a separate object on our game controller. This just makes sense in my head. You can obviously put these wherever you want, but they'll have to be on an object. It's always turned on in your game, so it's always accessible. I'll create a new script on this and call it shop controller. Double click on this to open it up. Now we're not going to need the update, but we will use the start, so I'll leave that there. But at the top, we'll once again want a public static shop controller instance. Then we're going to have some references to our UI elements for our shop. So I've just added a little header. This will pop up in our inspector in Unity. But we're going to want a public game object for our shop panel, a public transform for our shop inventory grid, comma, and our player inventory grid, a public game object for our shop slot prefab, and a public TMP text, which we'll have to do show potential fixes and add using TMP Pro for our player money text, comma, our shop title text. And finally at the bottom we'll want a private item dictionary for our item dictionary, which we added in our game before. And we're also going to need a private shop NPC, which we haven't written the script for yet, for our current shop. We'll add this script in a minute, but first of all let's add our awake and a shorthand version of making our instance, just so you can see the different ways of doing it. If our instance equals null, our instance equals this, else destroy our game object. This does the same as in our currency controller, it's just a shorter syntax. You can do whatever you prefer. So now inside our start, we're going to want our item dictionary equals find object of type item dictionary. When we start our game, we don't want our shop panel active, so we'll set our shop panel active to false. And we'll check if our currency controller is not null. So currency manager.instance is not null. Then we'll go currency controller.instance.onGold changed plus equals update money display. So when the gold is changed, we'll update our money display as we pass this in with our player money text. So down below, let's write this function of a private void update money display where we're passing in an int of our amount. And we can say if our player money text is not null, player money text.text equals amount.toString. Cool, so when our money is changed, it'll update our money display as we've added this to this event. And we'll also call update money display on start and pass in our currency controller .instance.getGold. Cool, now let's write a function for when we want to open up our shop menu. So we'll go public void open shop and we'll pass in, again, we haven't written the script yet, but it's going to be our shop NPC shop. We'll write the script once we've done these two functions, don't worry. Then we'll set our current shop to equal shop. Our shop panel.setActive will be true. Then we'll say if our shop title text does not equal null, so we've got our text passed in, then our shop title text.text can equal the shopkeeper's name, and then shop. So if the shopkeeper is called GCL, it'll be called GCL's shop. We'll write some functions in future that we'll call here, which will be to refresh our shop display so that when we open a shop, we get our items in of that shop. And we'll also refresh our player inventory display so we can show any new items our player might have picked up that they might want to sell to the shop. We'll also call our pause controller, set pause and set it to true so that when our shop is open, we can't go running around. Cool, and then we also want a public void close shop, which very easy. We'll grab this shop panel set active to true and change that to be false. This current shop equals shop from the opening we'll want to set to null. And our pause controller setting to true, we'll want to set this to false so our game can play again. Very cool. Okay, let's take a little break from our shop controller. We'll come back to it, but let's now go create a shop NPC. So back in Unity. So if I take a look inside our map bounds, inside T1, we've got NPCs running around. Inside these objects, we have our waypoint parent as they walk around and our NPC. I'm going to copy out our NPC old man and paste him down below, close down our map bounds. And on here, I'm not going to need our NPC script. I'm not going to need our waypoint mover as he's going to be stationary. And I'll leave our sprite resolver in case you want to change his icon and have your NPC animated around. That's up to you. I'll rename this to be Shop NPC and I'll move him to be standing outside our building here. So cool, on our Shop NPC, I'm going to add a new component of a new script and call it Shop NPC. We'll double click on this to open it up and we won't use our update, but we will use our start. So we'll leave that there. And at the very top next to mono behavior, hopefully you've done our interactables video because we're going to use our iInteractable so that we can interact with our NPC. Of course, if you hover over, it's telling us we need to implement these two functions for our interface to work. So we can click on this and add them in. I'm going to move our start up above them just so it's tidier. And at the top, we're going to want a public string for shop ID. This is what we'll use in our save to know which one's which. So you can call it whatever you want, shop merchant number 1. And then we'll want a public string shopkeeper name, which I'll just call merchant. Next, we're going to want to know what items we have in our shop. To do that, we'll add a nice little class using a system.serializable, then type in public class shop stock item, where inside we'll want a public int item ID and a public int quantity. So with these, we can make a public list of a shop stock item, which I'll call default shop stock, and we'll set to equals new brackets. Then you can duplicate this down with Control D, make this a private list of shop stock item, and we'll call this current shop stock. And finally, we'll want a private bool called isInitialize, which I'll set to a default of false to know has this shop been set up before. We're going to use this in a function that I'll write below our start for a private void initialize shop, where we can check if is initialized, and if it is, we'll return, so we don't do this again. Then we'll set our current shop stock to equal a new list of shop stock items, and say for each item in our default shop stock, we'll go current shop stock dot add new shop stock item, this is getting hard to say, and set our item ID to equals our item.item ID, comma, quantity to equal our item.quantity. And outside the for each, we'll set isInitialize to equal true. So this will set up our default stock, and this will be overwritten by our save system if a save exists. We'll call this initialize shop inside our start. And now we can set up our two functions that we need for our interface. So for can interact, all we're going to need is return true, because we always want to interact with our shopkeeper. Maybe in future you want to add features where the shops only open in the day or at night. So you'd be able to check something like time manager.is day and return this to be your true or false to say it's only open in the daytime. Or maybe a certain quest needs to be complete, so you can be like return quest manager dot is complete, that kind of thing. But for us, we're always going to have this shop open. And then in our interact, we'll want to use our shop controller we just wrote and check if there's an instance. So shop controller equals null. And if it is null, we'll return, as we can't open our shop as there's no script. Else we can say shop controller dot instance dot shop panel dot active self, which is basically us checking, is the panel visible right now? So if it is visible, we're going to want to go shop controller dot instance dot close shop so that this closes down. Else we're going to want to go shop controller instance dot open shop, and we'll pass in this so it knows that this is the shop we're opening and this is the details we want. Okay, now let's get our functions ready for interacting with our shop. So we're going to want a public list of a shop stock item called get current stock, which will simply return our current shop stock. For our save system, we're going to want a public void set stock, where we'll pass in a list of our shop stock items. I'll call this stock. And here we'll want to set our current shop stock to equal the stock we're passing in and loading from our save. Next, we'll want a public void add to stock, where we'll pass in an item ID and quantity. So this will be when we sell to our shop. So we'll want a shop stock item, which I'll call existing, to equal our current shop stock dot find, and we'll go s arrow function s.itemid equals item ID. We're seeing if we've currently got any. If existing is not null, so we've found an existing item that matches the one we're adding to our stock, we'll simply go existing.quantity plus equals quantity. Else we'll go current shop stock dot add brackets new shop stock item curly braces item ID equals item ID comma quantity equals quantity. Cool, so that adds to our stock. Now, as with everything, we need the yin and the yang. We'll need a public bool remove from shop stock. And again, we'll pass in int item ID, int quantity. So let's copy what we did in our add to stock, paste it down below, and we're going to adapt this. So we still want to find our existing to remove from the shop stock. In our check for if the existing is not null, we're also going to say, and our existing dot quantity is greater than or equal to the quantity we're passing in. Then instead of plus equals quantity, we'll want minus equals, so we take one away, and then we'll return true. And instead of this else, we're simply going to return false. Cool, so that's everything we need for our Shop NPC script. We can now go back to Unity. We'll be able to test out our Shop NPC, but first of all, let's go to our shop controller and set up our UI here. So let's click the little padlock at the top so this doesn't move while we click around. Open up our UI canvas. Here we've got our shop menu that goes into our shop panel slot. We'll open this up. We've got our player money text that can go in our player money text slot. Open up our shop content. So we've got our player inventory area. We'll open that up. Open up the scroll view, open up the viewport, and inside content, we've got our player inventory grid. So that goes inside our player inventory grid. I'll close down the player inventory area, open up the shop inventory area. We've got the shop inventory text that goes into shop text title. And then inside the scroll view, inside the viewport, inside our content, we've got our shop inventory grid. So let's drag that on in. Then last of all, we've got our shop slot prefab to fill. Let's go inside our prefabs folder. And inside here, we've got our shop slot. Drag it on in. And now we should be able to press play. We can walk on over to our new Shop NPC, press our interact button, and we'll see our shop pops up. Hooray! If we press our interact button again, it'll close our shop on down and we can move around again. Cool. So now let's get our shop populated with the items in our shop's stock. If we go back to our shop controller script, on our open shop we have these two functions we commented out that we want to make. So let's make those. We'll first do our public void refresh shop display. Well, we'll first check if our current shop is equal to null, we'll return. Else we're going to go around with a for each for our transform child in shop inventory grid and destroy that child.gameObject. So we're going to clean out the whole shop display. Then we'll go for each bar stock item in current shop .getCurrentStock. We'll check and say if our stock item.quantity is less than or equal to 0, we'll continue and skip over this. Else, we're going to call a new function that's going to be create shop slot. This is where we'll create our shop slot and add in the item that the shop contains. Before we do this, we can go back up to our open shop and add this function in that we've just written. And now we can write the next one, which will be our refresh player inventory display. So let's copy our refresh shop display, as we can reuse some of this, and rename it as our refresh player inventory display. So instead of checking if our current shop is null, we're going to want to check for if our inventory controller .instance is null. If so, we'll return. Else, we'll clear out every child in our player inventory grid and clear that on out. This for each is going to be a bit different as we want to go around our inventory. So we're going to go for each transform slot transform in our inventory controller .instance .inventory panel .transform. Then we'll get our slot of our inventory slot to equal our slot transform .get component and pass in slot. And we'll check if our inventory slot question mark to check if it's null or not .current item is not null, so we do have an item in our inventory slot. We'll go item.original item equals inventory slot .get current item .get component and pass in item. And then that's where we'll call our create shop slot to hold our inventory items. Cool, now let's go up and add our refresh player inventory display into our open shop before we forget. Then down the bottom, we'll do our create shop slot function. Let's go private void create shop slot. We're going to want a transform for the grid, an int for the item ID, an int for the quantity, a bool to know if this is our shop grid or if it's our player's inventory grid, and a slot for the original slot, which we'll set as a default to equal null, as we'll only need to know this if it is not our shop and it's our player inventory. So cool, let's go game object slot object equals instantiate shop slot prefab, comma grid. So we're creating a new shop slot within our grid that we passed in. Then a game object item prefab to equal our item dictionary dot get item prefab and pass in our item ID. If our item prefab equals null, we'll return. Next, we'll create a new item instance of this prefab. So we'll go game object item instance equals instantiate and pass in item prefab into our slot object. So we've got a new one of our items inside our shop, and to make sure this is centered, this is what I do for our slots. In our inventory, we do item instance .get component rect transform .anchored position and set this to vector2.0. Next, we'll want to go item equals item instance .get component item, and we'll set our item .quantity to equal our quantity passed in, and then item .update quantity display. So our shop might have 100 of one item. We'll want this displaying in the shop. Next, we'll set up our price. So if it's in the inventory or in the shop, it's going to be different. So we'll go int price equals is shop question mark. So if it is a shop, we're going to want our item .buy price. Else, we'll go colon item .get sell price. Each item has its sell multiplier that we set up in the last video on our items. Next up, we're going to want our shop slot equals slot object .get component, and we'll pass in shop slot. Oh, we'll call this shop slot shop slot a lot of repetition, and we'll say slot.is shop slot equals is shop. So we know when clicking on these items and on these slots if we're in the shop grid, so we want to buy things, or if we're in the inventory grid, so we want to sell things. Then we'll go slot.set item, pass in our item instance and the price. So this will work for both our inventory and our shop. Cool, in our next video we're going to be adding a little bit more here, where we'll need to edit our item handler that's on each of our items, but we'll do that next time, so don't worry. For now, our create shop slot is done. We'll copy this and paste it both in our refresh player inventory display, where we're going to want to pass in our player inventory grid, our original item .id, our original item .quantity, false, as this is asking is it a shop? No, it's not, it's our inventory. And we'll want to pass in our inventory slot. Then up in our refresh shop display, we'll want create shop slot and pass in our shop inventory grid, our stock item .item ID, our stock item .quantity, and is it a shop? Yes, it is. True. We don't want to pass in any slots, as these are just being created in our grid for us. Cool, that is our shop controller script for now. Well done, that was a lot of code. Let's go back to Unity, and if we press play now, our shop inventory will be empty because on our shop NPC, if we scroll down on the script, we haven't added any default shop stock. This has been a tongue twister. So let's add in some new elements. We want to grab an item ID and set its quantity. If I go to our prefabs and check our items, you can see on my item script, my green potion has an ID of 1 and my heart item potion has an ID of 2. So on our shop NPC, I'll add in, let's go heart potion first. So ID number 2 is going to be first. I'll say we've got 5 of those, and ID number 1, we've got 2 of those. So now when we press play, so let's talk to our NPC. You can see inside his shop we've got the 5 heart items and the 2 potions. Our player inventory is empty right now as we haven't picked anything up, so let's go up into my forest. I'll pick up some items. That was 3 normal potions and 2 heart potions. Go to our NPC. Oh, maybe I picked up 4. And now you can see our player inventory has populated. You can see the buy price is half of what you can see to sell these items. They're worth half as much as in the merchant shop, as our buy multiplier is 50%. Oh, and I've just remembered, if I click this X, we stay paused in our game as we didn't add our new function onto this close button. So let's close our game down, go to our UI canvas, and on our close button, we can scroll on down, drag our shop controller into this on click. On no function, we'll scroll down to the shop controller and select close shop so that when we click that button, it'll close down properly and unpause our game. Cool, just to test out, I'm going to change the buy price of our heart potion to be double so we can see the differences in the prices showing up. So let's go to our NPC. We can now see these are worth 20 each and 10 each of our potions. Let's test it once again and pick up a couple of these. In my inventory you can see I've got 2 potions and 1 heart potion, and there we are. These are worth half the amount, so 20 to 10 and 10 to 5. Of course right now this doesn't do anything as we've got our drag handler on and nothing else in our game, so this doesn't work properly yet, but we'll do that next time, as well as add it to our save controller so we don't get overwhelmed. And by we, I mean me. Until then, if you want to grab every single script I've ever written for this series and the whole channel, you can check it out on my Patreon, or if you want this whole template completed for you with all finished and future updates, you could check it out on itch.io, where you get this whole Unity package for yourself. Otherwise, like and subscribe, and I'll see you in the next one. Bye! By the end of this video, when we go to our shop NPC, talk to him, and open up the shop, we'll be able to sell our items, get some coins, and also buy items from our merchant shop. We're also going to be able to save our game so that our inventory and the shop stock is saved when reloading. Very cool, very exciting. So currently in our shop, all we can do is drag our items around. We don't want to be able to drag these around anymore. So if I go to my prefabs and check out our main item prefab, if we scroll down, we can see we've got this item drag handler script, which controls dragging around in our player's inventory. We're going to want a new script that handles when we click on items in our shop. So in my assets folder, I'm going to right click and go create C# script, and I'll call this shop item handler. I'll double click on this to open it up, and we're not going to want our start or update here, but at the very top next to mono behavior, I'm going to go comma, I pointer click handler. This will have a red underline, so we'll hover over, go show potential fixes, and using Unity engine.event systems. We'll use this to check our right click. But first of all, we'll go private bool is shop item, and we'll also want a public slot for our original inventory slot. Then we're going to set up a constructor to initialize our items. So we'll go public void initialize, and in the parameters we'll want a bool for shop item. Then we'll do arrow functions, so equals greater than is shop item equals shop item. That way when we initialize this, we'll set up in our script whether this is a shop item or not. Now if we hover over our I pointer click handler, we can do show potential fixes and use this to implement our interface. We can use this to set up our right clicking. So we'll go if event data dot button equals pointer event data dot input button dot right. Then we can say if this is a shop item, then we can call our function to buy our item, else we'll call our function to sell our item. Of course, these haven't been written yet, so let's go ahead and write those. First of all, we'll get a private void for buy item, where we'll want an item equals get component item, and a shop slot equals get component in parent shop slot. We'll do a quick if check and say if not item, so is it null or not, or if not slot, then we'll return as we've right clicked somewhere that wasn't on an item in its slot. Otherwise, if those are both not null, we'll say if currency controller dot instant dot get gold is less than slot.itemPrice will return here, and this is where you'd be able to do some kind of message to say you don't have enough gold. Maybe you want a little pop-up, but I'll just debug log to say there's not enough gold. Otherwise, we do have enough gold, so we'll say game object item prefab equals find object of type item dictionary. Then we can call get item prefab, pass in our item.id to get a fresh prefab of the item that we're trying to buy, and say if our inventory controller .instance .add item, and pass in our item prefab. Then our currency controller .instance can spend gold and pass in the slot.itemPrice. Our shop controller .instance .refresh player inventory display can be called. And we're also going to need to add a new function to our shop controller to remove this item from the shop. Now our add item function returns a bool. It's true if it is successfully added, else if it's false, it means that our inventory is full. So I'll just put a little line here to say that our inventory is full. Now with this function, we can copy it and use it up in our right click event, and we'll scroll down to add our private void sell item. We're going to want these top 3 lines from our buy item, same as above, but in this if and return, we're also going to want to go or not original inventory slot. So now we'll go item, inventory item, so inv item equals original inventory slot dot current item question mark to make sure this isn't null, and go dot get component item. Check if not inventory item. So if this is null, we'll return as we've right clicked on a shop slot that has no item in it. Else if our inventory item dot quantity is greater than 1, we'll go inventory item dot remove from stack and pass in 1. So else if there wasn't more than 1, we will destroy the original inventory slot dot current item and set this current item to equals null. Then outside this else, we'll want to say inventory controller dot instance dot rebuild item counts, our currency controller dot instance dot add gold, and add our slot dot item price, our shop controller dot instance dot refresh player inventory display. And again, just like in buying, we're going to need another new function in our shop controller where instead of removing items from the shop, we're going to add that item to our shop. So cool, with this function we can copy this and add it up in our else. So for now that's all done. We've got these 2 functions to add in our shop controller next, and then we'll come back to this to finish it up. So let's go back to Unity, and in my assets I have my shop controller script. So we can hop on over to that, double click on this to open it up. And in here down the very bottom, we currently have an item drag handler on our items. So we'll go item drag handler equals item instance dot get component and pass in item drag handler. And we'll say if drag handler, so this is not null, then we'll want to go drag handler dot enabled equals false, just to turn off this dragging capability. Then we'll want to go shop item handler, which is the new one we've just written, which I'll call handler, and go equals item instance dot add component shop item handler. So we're adding this script to this object. We'll go handler dot initialize, that function we just wrote, and pass in is shop to see if this is a shop or not. And we'll say if this is not the shop, so if not is shop, we can say handler dot original inventory slot equals original slot. Cool, now we're replacing our dragging with our new right clicking functionality. That's all done. Let's write our 2 new functions that we need still in our shop item handler. So we needed a public void add item to shop, where we're going to want to pass in an int of our item ID and an int of our quantity. We'll check our current shop and add an exclamation mark at the beginning to say if not current shop, so this is null. That was my cat. We'll return. Otherwise, if we do have a shop, we can go current shop dot add to stock, pass in our item ID and our quantity, and then refresh our shop's display. Very easy. Next up, we're going to want a public bool for our remove item from shop. And once again, we're going to want our int item ID and int quantity. We're going to want this check again for our if not current shop, and return false if our current shop is null. Else we're going to want a bool for success, which we'll set to equal current shop dot remove from shop stock, pass in our item ID and pass in our quantity. If this is successful, so if success, then we'll refresh our shop display and we'll return success. Cool, nice and easy. Now we can go back to our shop item handler, the script that we've got just up here. You can hold down Control and click on this script name to jump to this script. Then down in our buy item, we can see here, as we buy an item, we're going to want to remove it from our shop. So let's go shop controller dot instance dot remove item from shop and pass in our item dot ID, comma 1. If you want to add in multi-selling and buying, this is where you can just add in how many you've selected to buy or sell. Cool. Now down in our sell item, we're going to want our shop controller dot instance dot add item to shop. Once again, pass in our item ID and 1. Cool, and that's all we need. Let's go back to Unity and test this out. Shouldn't need any setup. We should be able to just press play. Now when we go up to our shop NPC, we can right click on this heart potion and see it appears in our player inventory and the quantity went down by 1. Oh, and if you check, our currency is also going down in the top. Yup. And now let's take a look. If I sell from my player inventory by right clicking, we should get 5 more coins. 1. Yep. And sell our potion back. We've lost 20 coins. You can't just buy and sell items for the full price back. You can customize this if you want on your item sell price modifier. Now the problem is if I buy out all his green potions, close this down and save, then I'll close my game and press play again, and we'll check in our shop. The stock is refreshed. We want to be saving our merchant shop so he doesn't have infinite stock, unless of course that's how you want it in your game. So let's go back to Unity, and currently on my game controller object I have a save controller. We can double click on this to open it up, and in my save game I have a script for save data. I'm going to hold down control and then click on this save data to open it up, and in here we can add some new fields. We're going to want a public int for our player gold and a public list of our shop instance data, which we'll write in a second. I'll name this shop states and set this to equal new. Cool, I'll copy this chest save data and reuse it for our shop instance data just because I'm lazy to type it out. So we've got a public class shop instance data. We want this public string to be shop ID. And instead of this bool, we're going to want a public list of our shop item data to know the stock of this certain shop. Once again, let's copy this, paste it down below, and create some shop item data. In here, we're going to want an int for our item ID and another int for our quantity. Cool, we should be able to use these in our save controller to save and load this data into our shops. So let's go to our save controller, and at the top we're going to want a private shop NPC array, which I'll call shops. This will track all our shops in our scene, which will populate down in our initialized components, where we'll go shops equals find object of type and pass in shop NPC. Then down in our save game, we'll want to go comma after our hand in quest IDs and add in player gold equals currency controller dot instance dot get gold, comma shop state equals get shop states, as we'll do this in its own function outside of our save game. Oh, we've got an error up here. I did find object of type. It should be find objects of type. So this passes back an array. Sorry about that. So we're going to want a private list for our shop instance data called get shop states. Similar as our chest one, we're going to want a new list of shop instance data, which I'll call shop states. And we'll say for each bar shop in shops shop instance data shop data equals new shop instance data curly braces, and we'll go shop ID equals shop dot shop ID, comma stock equals new list of shop item data, and we'll want a semicolon at the end of those curly braces. Then still within this for each, we're going to want another for each of var stock item in shop dot get current stock, which we wrote in our previous video, and go shop data dot stock dot add new shop item data curly braces, and go item ID equals stock item dot item ID, comma quantity equals stock item dot quantity, and a semicolon outside of that bracket. Cool. Then outside the stock for each, but not the shop for each, we'll go shop states dot add shop data. So that is within our shops for each, and outside of that we'll then return our shop states. Cool, so we're basically looping around these to gather all our data that's in our game. So make sure you've got this in your save game for your shop states equals get shop states. Next, let's go down to our load game, and we can again use our chest states as an example. So we're going to do something similar where we have load chest states. We'll do that in a second, as we're also going to want load shop states, where we'll pass in our save data dot shop state. Other than just that, we're also going to want our currency controller .instance, and to set the gold to our save data .player gold, which is nice and easy. So let's go down to where we've got our load chest state, and similarly we're going to want a private void load shop states, where we'll pass in a list of shop instance data, and I'll call this shop states. We'll check and make sure this isn't null by saying if shop states return, in case we haven't saved anything like that before. Oh, we can't do that with a list, so we'll just go equals null. So if this isn't null, we can go for each var shop in shops, which is our shops in our game that we made at the top. We'll say shop instance data, shop data equals shop states dot first or default, and we'll search for our s arrow function s.shop id, where this matches our shop.shop id. So we're trying to find some save data for the shop in our game. If our shop data does not equal null, we'll go list shop NPC dot shop stock item and call this loaded stock equals a new list of shop NPC dot stock item, and go for each var item data in shop data dot stock. We can add this by going loaded stock dot add and adding a new shop NPC shop stock item curly braces item ID equals item data dot item ID, and quantity equals item data dot quantity, and semicolon at the end. Still inside this if, but outside of this for each, we can then go shop dot set stock to loaded stock. So we can override any default stock that the shop has with our save data stock. Oh, I spelled load wrong in my load shop states. So cool, let's scroll on up to our load game and make sure you have load shop states and passing in our save data dot shop states. Very cool. Now our saving should be working. Once again, to find your save location, if you're using a weird path, you can put a breakpoint in our initialized components and start the debugger up here with the play button. And when we press play, this will hit our breakpoint. We can hover over our save location and see where this is stored. So if I go to this folder, I can see my save data saved here. I'm going to delete this so our player will have money again, as I spent it all in our previous test. If you instead want a different save location that's a bit easier to access for testing, we can just set this to our application's data path, and I'll rename this to be testdata.json, which I'll show you where this appears just in a moment when we next save. So now when we press play, we should have a fresh save file. If I go over to my shop NPC, I've got nothing in my inventory and I've got 100 coins. So I'm going to buy out these 2 potions, close this on down. If I check my inventory, you can see I've got 2 potions in here. So I'll go to my settings and press save, close down my game. As you can see, our test data has appeared in our assets folder. This is much easier for you to check or delete if you need to reset your game data. So cool, when I press play, I can check my inventory and see I've still got those 2 potions, but we can also go on over to our shop NPC and see that his stock has also been saved, as well as our currency amount. So very cool! Our game now saves and loads shop stock, as well as allowing us to buy and sell items. Yay! Now we've got a pretty good template for most top-down games. There is so much more I could add to this generic template, but maybe we start adding some fun stuff, like monsters and combat. Huh? What'd you think? Pretty cool, but we'll see how it goes. As always, if you want to grab all the code, all the scripts for this whole channel, you can check it out on my Patreon, or grab this whole completed template, the whole thing set up. You can grab that on itch.io for all finished features, and also including future updates. Otherwise, like and subscribe, and I'll see you in the next one. Bye!